Uh, am I audible to the online participants?
Recording in progress.
Yes, you're audible.
Okay, thank you. Today we will start with theme 4, nature-based solutions for climate mitigation. First we have a keynote address by Professor U.V. Bawa. Professor Dr. Ummu Salma Bawa is Chairperson and Professor of European Studies of the Center of European Studies, JNU, New Delhi. She is also a guest faculty at the Foreign Service Institute, Ministry of External Affairs. We welcome you, Madam, for this session. We have two chairpersons for this session. Dr. Shobha Jokerkudan, Head Finfish Fisheries Division, ICRC MFRI, and Dr. Sujita Thomas, Principal Scientist and Head of Mangalore Center of CMFRI. We have two rapporteurs, Dr. Rajesh N. and Dr. Suresh Babu, Principal Scientist from Mariculture Division. Let me welcome all the chair and rapporteurs to this session. Over to chairpersons.
Good morning, everyone. I welcome Professor U.S. Bawa to this seminar and the second day of the seminar, and I invite Madam to present her keynote address. Over to you, Madam.
Thank you so much, Madam Chairperson. Good morning. I hope I'm audible to all of you.
Yes, Madam.
Let me at the outset congratulate everybody for this wonderful conference, which is extremely timely, and I'm very happy to participate in it. Let me add a little caveat. I do not work directly in the area, but given in my last 40 years of being in teaching, research, and public policy, I think the environmental and conservation have been very close to my heart, and I'm happy to address all of you this morning. My keynote addresses integrating traditional knowledge and science in the conservation of the blue ecosystem. The world's blue ecosystems, our oceans, coasts, and marine life, are indispensable for planetary health and human well-being. Yet they face unprecedented threats from climate change, pollution, and more importantly, overexploitation. Addressing these complex challenges effectively calls for a paradigm shift in conservation strategies, moving beyond singular disciplinary approaches and recognizing diverse knowledge systems and stakeholders. The integration of traditional ecological knowledge with modern scientific methodologies offers precisely, in my opinion, a pathway, creating a powerful synergy that unlocks new possibilities for sustainable development efforts. I believe that the fusion recognizes the inherent wisdom accumulated over generations by coastal and local communities, along with the empirical rigor and global perspective of contemporary science, leading to more robust, culturally appropriate, and ultimately more effective conservation outcomes. This recognition becomes the base for what I call knowledge co-production and co-management of creating resilient communities. I think traditional ecological knowledge, often passed down orally through generations and lived through practice, represents an intimate understanding of local ecosystems which are born from centuries of direct observation and interaction. Local communities, fisheries, coastal dwellers possess invaluable insights into species behavior, understand seasonal cycles, knowledge and practice such as rotational fishing, sacred no-take zones, or specific harvesting techniques often embody inherent principles of sustainability and resilience. This knowledge, we should understand, is not merely data. It is intrinsically linked to a lifestyle, the understanding, cultural values, social structures, and often spiritual beliefs which provide a holistic framework for living in harmony with the environment that is often sometimes overlooked when we purely take a scientific approach. This does not mean that science is not valuable to us, but perhaps the local community is often the first and the most important custodian of the ecosystem given their intimate daily engagement with it. However, As compared to what we have seen with local communities in practice, there is a step forward because modern science provides crucial tools and perspectives that expand the spatial and temporal scaling of understanding. It offers the capacity for large-scale data collection, predictive modeling of climate change impacts, and analysis of complex ecological processes that may not be perceptible at a local level. With the advanced use of technology, satellite imagery, genetic analysis, deep sea exploration, and advanced statistical modeling, it allows scientists to map larger global patterns, identify underlying mechanisms of degradation, and also assess biodiversity at unprecedented scale. This scientific rigor provides a foundation for evidence-based policy. It also facilitates collaboration from the local, regional to the global level and offers technological solutions for monitoring and intervention to keep the ecosystem healthy, safe, and secure. Thus, a true transformative power emerges when these two distinct yet complementary knowledge systems are interwoven. Science can validate what are often anecdotal observations from a traditional knowledge, lending quantitative support to long-held beliefs about healthy fish stocks or critical habitats. Conversely, traditional ecological knowledge can also provide what we call as the granular, localized data that fills gaps in scientific data sets, offering historical baselines and insights into long-term ecological trends that predate formal scientific study. This synergy approach enables the creation of a more robust and culturally appropriate conservation strategy. It is vital today to build transdisciplinary model that includes not only the physical and natural sciences, but also the social sciences and humanities, and works with traditional and local knowledge holders, the civil society, business, and government, which is essential to co-design and co-deliver a solution-oriented research that creates new communities of practice. For instance, in establishing marine protected areas, integrating local knowledge of culturally significant sites of traditional fishing grounds alongside scientific data on biodiversity hotspots can lead to more effective and locally supported protected areas. Similarly, climate change adaptation strategies become more resilient when global scientific projections are combined with local traditional knowledge of historical weather patterns, resilient species, and a community coping mechanisms. I believe that the engagement of a community with its ecosystem, including the marine ecosystem, is constituted in their daily life and practice which they inhabit. Thus, intergenerational knowledge stemming from actual engagement with the ecosystem constitutes a knowledge base that has served the community through an extended period of time. Such traditional ecological knowledge is also then interwoven into the stories and texts of the communities and become part of the larger cultural practices. Scientific knowledge is a newer and a more modern way of looking at the ecosystem and intervening to protect, reinforce, and revive it. Often the process of intervention could be linked to other policy requirements that also seek to develop the entire ecosystem from the purpose of extracting resources or developing the blue ecosystem from an economic perspective. Such approaches could be detrimental also sometimes to especially fragile blue ecosystem and actually do more harm than good. Local communities thus have long years of experience and collective knowledge bases that offer insights and solutions to problems in their ecosystem. Scientific observation and knowledge bases are relatively new and if not always embedded in the community, will always be informed by the practice they bring to the community. Often, scientific projects and interventions, one should recognize, also reveal that there is a power imbalance on who gets to decide and implement the ideas and projects. The integration of different worldviews, such as science and traditional knowledge, would provide a better foundation for understanding complex biological, and ecological questions. This also connects to the idea of knowledge as a co-construction partnership. Such integrated approaches directly bolster sustainable development efforts by fostering better governance, enhancing community empowerment, and also building resilience. By grounding conservation in local cultural contexts and respecting established practices, they foster higher community engagement and compliance, leading to more effective resource management and reduced conflicts. Integrated fisheries management, for example, can combine scientific stock assessment with traditional knowledge of spawning aggregation and seasonal closure, thus ensuring both ecological sustainability and the preservation of crucial livelihoods which are dependent on fishing. This leads to conservation solutions that are not only ecologically sound, but are also socially equitable and economically viable, ensuring that communities benefit directly from conservation efforts. Ultimately, by valuing and integrating diverse knowledge systems, we move beyond a siloed thinking towards a holistic paradigm where blue ecosystem conservation directly contributes not only to food security and dignified livelihood, but also the overall well-being of coastal communities for generations to come and nation building. So let me conclude. I believe that as we look at the Ocean Decade, which was launched in January 2021 after a proposal from the Intergovernmental Oceanographic Commission, the IOC of UNESCO, which was directly linked to the 2030 Agenda and associated with the Sustainable Development Goals adopted in 2015, we find that integrating both traditional knowledge and scientific efforts will produce the best possible means of co-creating knowledge to address what has been set as a mission for the Ocean Decade. I also draw your attention to the new UN Treaty on Conservation and Sustainable Use of Marine Biodiversity Beyond National Jurisdiction, the BBNJ Agreement, that has recognized the value of traditional knowledge. This recognition, I believe, is unique, making it a pioneer among other international conservation conventions and agreements. Ultimately, as communities of practice, the goal in traditional ecological knowledge and science is to find ways to conserve and still benefit from the blue ecosystem, and efforts that bridge these two should be at the base of knowledge co-production. Thank you so much.
Thank you very much, ma'am, for your insight into integrating traditional knowledge and scientific research. Yeah, we will start our sessions. The first, any questions? Online participants?
Okay, thank you so much. I wish you all a very good conference today, and I'll take your leave.
Yeah, thank you. Everything was crisp and clear. That's why no questions.
I think for me, it's a learning experience. It would have been wonderful to sit and listen, but unfortunately, I start class in a short while, so I will take your leave and, maybe read up on the papers which come out. Thank you so much.
Okay, ma'am. Thank you.
Thank you.
So the first presentation is by S.S. Kawadi et al. Climate Resilience and Economic Sustainability, the role of salt marshes in mitigating climate change in Lakshadweep. Not available. Dr. Kaladaran. Kaladaran sir, you're online. Yeah, sure. Yeah, so the first presentation we'll take it later. Okay, next is S. Venkatesh, Mitigating Climate Change to the Blue Ecosystem, an Integrated Approach of Science, Community and Nature. Venkatesh, S. Venkatesh. Online? Venkatesh, are you online? No. Next is Kaladaran is not available. Next is carbon sequestration, potential of selected mangroves ecosystems in Western India. Ratish Kumar et al. Who is presenting? So, evaluating carbon sequestration and climate mitigation potential in natural and planted mangroves of Panchaganga Valley estuary. Harshita.
A very good morning to one and all. I am Harshita Ramamurthy and I come from ICAR CMFRI Bangalore Regional Center. And today I'm going to present evaluating carbon sequestration and climate mitigation potential in natural and planted mangroves of Panchaganga Valley estuary. Dr. Sujita Thomas is one of the primary authors and I'm just a presenter for her today. So, tidal forest under transition. What I meant by this is that we all know that mangrove serves a variety of ecological and economical services, and they shield the shores. They protect us from the surges and tsunamis, and they capture atmospheric carbon by trapping greenhouse gases, and that's how they mitigate the climate change. And they nurture coastal life and livelihood by being the nexus of many living organisms and people. So in India, restoration is not a new thing or a booming thing. Restoration of mangroves have been happening in India since 1892 in Sundarbans, and it has significantly has been under prominence in 1990s and post 2004 tsunami era with community-led and ecosystem-based approaches. India has been showing encouraging signs of scale and mangrove restoration in recent years through state-led missions and national initiative MISTI. So that is the question. The central question is that is more always good? Restoration is happening in a very numerically good way, but is actually good in every other context. So that is why resilient versus the restored. The present study aims to understand the true carbon sequestration potential of both natural undisturbed mangrove ecosystem and restored sites of mangrove plantations. So the objectives for this paper was to identify a suitable study site for evaluation of both natural and planted mangroves, and to systematically measure the trees and estimate the above ground biomass and below ground biomass of the mangrove transects which were chosen. Systematic measurement of the trees and estimation of and elucidating the carbon sequestration potential of the selected sites, comparing the current carbon holding capacity. This is a one-time study. So the methodology includes selecting the site, which is the Gangavali Estuarine Complex. Why we chose this area? It's because it comprises both natural and planted mangrove ecosystem, and it is very feasible for us to go and take measurements, and only 6 sites were identified for estimation through a non-destructive stratified random sampling method, which is put forth by Kaufman and Donato, the protocol for measuring the mangroves. And it is classified according to the size variation, tree arrangement, species diversity, and root adaptation and soil distribution patterns, which changes from species to species, and also an ecological system. And diameter at breast height is taken as an age determinant. I will explain more about it. And applying allometric equations. It is put forth by Komiyama et al. 2005, and this basically deals with wood density of each species, and also it calculates the diameter of each species, and the wood density is available in a forestry register. So we have taken the data from the registry. And the next step was to estimate the carbon sequestration potential. So the carbon stock is equal to the biomass into 0.5. That is, whatever the total biomass is, we decide that 50% of the total biomass is actually the carbon stock which is present in the area. So comparing natural transects with planted transects is going to happen later after all this. So this is the study area. Panchagangavali is a very dynamic estuarine complex where the 5 rivulets join into one estuarine complex. 6 transects, each 3 of planted and naturally existing mangrove sites were identified based on the feasibility and also the measuring for collecting samples as well. Fewer transects were chosen because there was a striking uniformity in the planted ones, which if you see the graph you can see that, because there was it suggested monoculture as well. A similar species was found all across the patch. So we took a small number of transects in order to conduct this case study. However, in the natural areas, the transects were chosen based on their diversity, because the more the diverse, the more we can find out the variation of the carbon sequestration which is happening in the whole of the ecosystem. So results and discussion. A total of 6 species were found in the transects: Rhizophora apiculata, Rhizophora mucronata, Avicennia marina, Avicennia officinalis, Candelia candale, and Soneraceae alba. So Rhizophora apiculata was found as the dominant species among the transects. Although in the planted patches, as I told before, a uniform plantation of Rhizophora apiculata and Candelia candale were seen. So this potentially suggests monoculture, which it might happen due to these reasons, because while we grow mangroves in a secluded area, it is not possible to grow all the species. We need to take care of the water holding capacity as well, and most of the mangrove species are not susceptible to all environmental conditions and water conditions. So That might be the reasons why they have restored with only these two highly susceptible species. So as you see the pattern, T1, T2 and T5 are the natural mixed patches. You can see a haphazard pattern, but in T3, T4 and T6 it is kind of uniform, which suggests they were planted. And also we took the local data to confirm on that. Natural mixed patches are haphazard, asymmetric and diverse compared to the planted patches. So natural, and when we did this statistical analysis, natural mixed forest plots store far more above ground biomass, that is approximately 350 ton per hectare than the planted plots, and the same pattern holds for carbon, roughly 76 tons per hectare in natural versus 48 tons per hectare in planted. In percentage terms, this is about 55% advantage for a biomass and approximately 60% advantage for a carbon sequestration in natural strands. So what I suggest is that the study what we concluded is that the study explores not only the presence of the species but their functionality in structure. So diversity, when the diversity is the more, functionality is more. So sustenance and contribution to the carbon storage was also found. Concluding, conservation should shake hands with restoration. Not only restoration and blind planting is the key, but long-term monitoring evolution is necessary. Restoration should prove effective not only in numbers but also in functionality, and integrated long-term monitoring, biodiversity metrics, evaluation of restoration success, comparative studies like how we did, and local involvement must be initiated. And this is one of the new era kind of ecological conservation system which is coined, and we are really excited to do more research on this. It's called assisted natural regeneration, which removes disturbances and provide natural seedling growth and enhancing by enhancing environmental and hydrological conditions rather than large scale planting. This method not only preserves local genetic diversity which is there in the particular area, and it encourages native species, it also restores ecological functions over time, making it a far alternative to a conventional replanting. Thank you.
Thank you, Arshita. Sorry. I think you have another presentation which is next in line. Are you going ahead with that?
Ma'am, I'll just
excuse me, I have just one question. I am Padamshri.
Yes, yes.
Can you hear me? Yeah. Hello, congratulations.
Hello, ma'am. Ma'am, your mic is off.
Can you hear me now?
Yes, ma'am.
Yeah, okay. So congratulations on your work and your study.
Thank
now
you,
I just want to ask, what is the time period are we looking for from the time of plantation or restoration? When you're talking about restoration, suppose we plant today, what is the time period it takes to, you know, really start sequestering carbon dioxide and grow, you know, when it's, to a level, right?
Ma'am, the diameter which we consider is 1 meter. So even a wildling or even a sapling could sequester carbon. It has that potential. We have only taken planted planted mangroves, but even the litter which has fallen from the mangrove sequester carbon. So it happens in a very negotiable metrics, but it happens, ma'am.
Okay, but generally what is the time frame, you know, when you're looking for, how much time does it take to grow, right?
Ma'am, it depends on each species, yeah, that is the criteria.
Okay, thank you.
Thank you, ma'am.
Any other questions? Harshita, you have 2 more presentations.
Yes, ma'am.
Are you continuing with the next one? I understand the one on from silos to synergy you will be presenting at the end, towards the end of the session.
Yes, ma'am. Ma'am, could I take some time in between?
Okay.
Is it fine?
Okay.
Yeah. Thank you so much, ma'am.
So up next we have resilience in the face of climate change, coastal strategies in developed and developing regions. This is by Pooja Sharma et al. To be presented by okay. Okay, so that will be presented a little later. What about Anand? Is he available online? You're here in person, okay. So next up is TS. I request the evaluators to please note there's a lot of rescheduling going on. So evaluators, please note the next presentation is TS 4009. Sandy nature of substrata limits the carbon sequestration and storage potential of mangrove ecosystem. A case study from Kundukal in the Gulf of Mannar, India. This is by Vinod et al. Presented by Dr. Anand.
Good morning, everyone. Myself, S. Anand, and I'm working here as a young professional too, under Marine Mammals Survey Authority of India project. So this work was actually done under NICRA project in the Mandapam Regional Center of ICRC-MFRI last year. So our main aim was to access the biomass and carbon stock of the mangrove ecosystem in the Kundugal region of Gulf of Mannar, and possibly to have a study about the limiting factors and the other factors behind the standard nature of the mangroves inhabiting in that region. So as we all know that we all have a proper and basic idea about the importance of mangroves in climate mitigation, due to their exceptional ability to store and sequester carbon, which both act as a sink in their biomass and soils. They can store carbon due to their high primary productivity, sediment trapping capacity, and due to the anaerobic and most probably the anoxic conditions prevailing in their ecosystem. They actually slows down the organic matter decomposition also. So once again, this study was actually conducted at the Kundugal estuary, which is a part of the Gulf of Mannar Marine National Park in the Ramanathapuram district of Tamil Nadu. It's actually a very ecologically rich area, with the seagrass ecosystem being adjacent to the mangrove ecosystem over there. This area is actually experiencing 4 major seasons in the entire year, with the northeast monsoon being the rainy season, with an average rainfall of over 800 to 1000 nanometer in between, and an average temperature of 28 to 38 degrees Celsius in between. So during our survey, we documented about 6 species of 6 mangrove species that's from 5 different families. The 6 different species were Avicennia marina, Cereum struggle, the Pemphis azurilla, Rhizophora mucronata, Lumnitza racemosa, and Rhizophora epicurata. Among the 6, the first 4 were the ones having the most one being the most abundant and being a significant in the biomass also. So we conducted a we conducted a non-destructive method of sampling for the assessment of biomass and the carbon stocks. Totally, there were 11 sampling plots with the quadrates of 10 meter into 10 meter size. And for the assessment of the above ground, for the biomass, we first had the sampling for the above ground biomass, and then at the same time we did the below ground biomass also. For the above ground biomass calculation, actually, we measured the different parameters of the trees, measurement of the tree, including the total height, then the canopy width, then the girth at the breast height, which is then again calculated into the diameter as the breast height, then the basal circumference, and the height, I've already told, height of the tree. Then the GBH, that is the girth at the breast height, was actually measured at the 1.3 meter above above the ground. This is again converted to DBH, that is the diameter. During the entire procedure, all the trees that we were having actually a height of exceeding a height of 1.3 meter and having a GBH of GBH of 4 centimeter were like considered as the adult trees, and all other trees, all other plants were considered as saplings. So after the tree measurements, like the tree parameter measurements, the values that they were applied to an empirical formula for the above ground biomass calculation, and the formula was W2, which means the above ground biomass is equal to 0.251 rho D 2.46, where rho is the wood density, and the wood density of wood density is species specific, and it will be different for different mangrove species, and the D is the diameter at breast height. Similarly, we also have a similar kind of empirical formula for the below ground biomass calculation also. The same rho applies here also, the wood density, and but the other things, like there's a change in that. Then as I have already told that we have completed, we have done a non-restrictive method of sampling for the below ground carbon and the carbon stock assessment, like below ground biomass and the carbon stock assessment. Sediment samples were collected from a minimum depth of 0.30 meter with a stainless steel core of about 1.3 meter height and 3.5 centimeter radius, and from this the above ground biomass plus the below ground biomass totals the total biomass of the entire ecosystem. That's we calculate in tons per hectare. Additionally, another core sample from the same sampling sort were taken to estimate the bulk density of the sediments that we have collected. Then the organic carbon present in the sediment samples were actually estimated through Volkley and Black method. After the analysis, these values can be applied in the formula, in the empirical formula, to have the minimum organic carbon content values. Then the sediment texture, in the methodology also, the sediment texture method was for the estimation of the sediment texture, we have applied the international pipette method, and this is the empirical formula, not empirical formula, the formula for the calculation of soil organic carbon, which is actually the tons carbon per hectare. In that bulk density, the soil depth at which we have taken the sample, and the organic carbon percentage, which we have calculated from the Volkley and Black method, we apply to this, and we'll get the value for the soil organic carbon in tons per hectare. So I've already described about the mangrove species that is occurring in the area, the 6 species and their family which they belong to. Out of this, the Avicennia marina was the the dominant one in biomass and carbon stock. This is the biomass of different mangrove species in that area. Actually, we can clearly see the total biomass stock, total biomass and biomass of the Avicennia marina. And the second comes up Pemphis acidilla, then the third Luminicera, and the least by Cereus stegle. Similarly, we have also calculated the biomass of the total, the entire quarters, the sampling spots sites we have taken, and out of this we can see that the mean above ground biomass was around 37.70 tons per hectare, and the mean below ground biomass was 24.20 tons per hectare, and the mean total biomass of the entire sample locations was 61.90 tons per hectare. Similarly, the above ground carbon had a mean of 18.85 tons per hectare, below ground with 12.10 tons per hectare, and the estimated mean carbon stock was around 30.95 tons of carbon per hectare. So when we calculate the above, then we calculate the above ground carbon plus the below ground carbon and the sediment carbon, and this totaled up to 53.86 tons per carbon hectare in the entire sampling location. And we have also done the sediment texture analysis, and according to that value, according to the values that we had, the proportion of fine sand and coarse sand has been the dominant components in the entire ecosystem. Like the fine sand estimated around 62.45%, they had a variation around 60 to 70% in between, and the percentage of silt and clay was very low when compared with the fine sand and coarse sand. As we all know, we know that the organic carbon content tends to increase with the higher proportion of silt and clay in the sediment. From our study, we found out that this particular area in Kudukal had the fine sand and coarse sand textured sediments more when compared with the silt and clay. We, in contrast, the sandy sediments actually show a negative correlation with the organic carbon because of their low surface area, and which makes them to makes them less capable of retaining more organic matter. So the sand dominated soil contain low organic carbon because they are unable to hold the detritus and fine particles that typically store the organic matter present in them. This limits the microbial activity, which in turn plays a, we know that they plays a key role in the nutrient recycling and maintaining the fertility of the soil. Consequently, mangroves in the sandy soil often display standard growth, reduced foliage and lower biomass. We have also seen, from our observations, we found out that the area, the mangrove species, especially Abyssinia marina and the other species, have a fewer roots or less developed root system and fewer new metaphors than when we compare with the with the same in the muddy or clay rich substrate. So just a minute more. The fine muddy sediments support more extensive root systems characterized by great branching and large surface area and higher porosity. In contrast, the sandy sediments have higher bulk density and lower nutrient availability, which restrict the root expansion and establishment. So the total estimated carbon stock of our current study area was 53.86 tons carbon per hectare, which was equivalent to 197.67 tons carbon dioxide, which is actually relatively low when compared with our earlier studies on mangroves that was conducted on the North Kerala, had reported a carbon stock of between 180 and 210 tons of carbon per hectare, the average. So this entire work, in combined, we had inferred that the low carbon levels in Kundukal might be due to the standard growth of the mangrove trees, adapting under unfavorable conditions. That's all about it. Thank you.
Thank you, Anand. Any questions? Online participants? Okay, I have a comment. It's not a question. Considering that most of the presenters are research scholars from CMFRI, I'm taking the liberty of just advising you all, please learn to stick to the time limit.
Sorry, ma'am.
The first bell is rung as a warning, and the second bell means your time has been completed. So you must learn to limit your presentation to the given time limit, and as far as possible, don't ask for extra minutes.
Definitely, ma'am. Next time.
It's not just for you, for everyone, for all the scholars I was speaking. Yes, thank you. So we will move on to the next presentation again. Harshita, are you ready? Yes. So it's evaluators, please note it is TS4007, influence of anthropogenic activity on organic carbon in mangrove ecosystem, a natural solution to climate change.
Hello everyone again. Now I am going to be presenting a paper on influence of anthropogenic activity on organic carbon in mangrove ecosystems, a natural solution to climate change. So where carbon meets concrete. Organic carbon is a powerful biomonitor in mangrove ecosystem, and they are essential as an indicator of mangrove health. As they lock away the blue carbon for centuries and they buffer atmospheric carbon dioxide, and which increases and help communities to adapt to climate change impacts such as sea level rise and extreme weather. Increasing human activities like urban expansion, waste dumping and hydrological changes are degrading the ecosystems. These disturbances reduce mangrove health, and also it directly impacts their ability to store soil organic carbon, and also which is a key climate regulating function. Measuring this human interference is essential for guiding conservation, and thus the main central idea of our paper. So I'm going to go with aim and objectives. It is to understand how human-induced pressures affect sediment organic carbon. The objectives are to assess bulk density and soil organic carbon from the selected sites from Netravati and Panchagangavali, because Netravati is a highly busy area where it has a fish landing center adjacent to it, and high boat activities and fishing activities are there, and there are a lot of local dwellings which is 100 meters away from the shore. So, and Panchagangavali again, which is another dynamic estuary which is situated in Kundapur, which has less interference of human anthropogenic activities or human induced activities, but it also has a certain moderate amount of interferences, which we'll be finding out. To establish an anthropogenic interference index to infer the preliminary status of human interference, and to analyze the correlation between SOC and anthropogenic interference determination index, which we named AIDI or ID. Methodology. First, we select the study sites. We took 2 study sites for our study, that is Netravati and Panchagangavali, which are semi-natural. Because it has mixed paths. Again, as I told in the previous paper, they have the planted sites as well, and also the restored natural sites as well. And we developed an ID score, scores ranging from 0 to 4 based on 5 notable stressors, which we found in the mangrove area, which is tourism, because in Panchagangavali and Netravati a lot of boats and other tourism activities like mangrove watch and all are going on, and aquaculture and settlement, which is the local dwelling, pollution and habitat alterations due to many of the reasons like environmental as well, and also human induced as well. So the next is soil sampling and core collections for the assessment of organic carbon. Sediment core samples from transects are obtained from 30 centimeters of the depth, which is really important for the calculation of the sediment organic carbon later. And the samples are then neatly preserved in polythene covers for analysis of soil bulk density, percentage organic carbon, and also soil organic carbon altogether. And laboratory analysis is done for bulk density, organic carbon, and also for soil organic carbon, and statistical analysis to compare SOC versus ID, and also to preliminarily correlate soil bulk density, percentage organic carbon, and soil organic carbon was conducted. I'm sorry for the presentation here. As I told about the stressors, we actually coined this composite index based on the human modification index, which was put forth by Kennedy et al. 2019 for field assessed visible stressors. And these are, as I told, tourism, aquaculture, settlement, pollution, and habitat alterations. TASPH are the codes. So this is strictly a field assessment tool which is which can be considered as one of the statistical tool to analyze the preliminary human interferences. So this is our study area. N1, N2, N3 and N4 are from Netravati, and P1, P2, P3 and P4 are from Panchagangavali. We took uniform sites in order to assess. So each variable is scored from 0 to 4, just like a survey based. We asked most of the local dwellers for more inputs on the variables we took, and so we coined 5 strata of the scores which we can assign for each. 0 is there is no impact of human interference at all, which is highly impossible at this rate. 1 is very low interference, and 2 is moderate, 3 is high, and 4 is very high. So we have this spectrum of scores in order to evaluate the preliminary interference. So ID score raw is nothing but the summation of all these interferences, and each transits were given scores, and then we calculated as a whole by dividing it by 20, which because we have taken 5 different variables. So we are multiplying each, and we are dividing, and we are taking an average of all the variables to put forth a normalized ID score. So in Netravati, 0.85 was the score. I'm sorry for the alignment again. And in Panchagangavali, 0.35 was found. Based on the field assessment, Netravati has higher interference than the Panchagangavali, as we can see. So this is the ID versus soil organic carbon trend. The orange line depicts the intensity of anthropogenic interference, and as you can see, Netravati has the highest spike and it has affected a lot, but in Panchagangavali, which is 5, 6, 7 and 8, it has a little lesser interference due to a stable environment which is happening over there, and less the variable interferences. So the associate is highly susceptible to the ID shifts in the transits is what we found. Conclusions. Anthropogenic interference determination index proves to be a useful and a preliminary field assessment tool to monitor regular stresses occur, and can incorporate time series and non-linear models for the further analysis. This can be backed with field data as we took, and satellite tools and local knowledge to provide really accurate measures, and this can support policy and restoration through interdisciplinary research, where we come across a lot of geospatial data and also the field data and also the local knowledge. So future work which we have decided for it for this paper is standardizing this interference index with field specific variables which can vary across the mangrove patches, and power it by remote sensing and geospatial data. And we should consider more transects for accurate determination of interferences, because we've only taken 4 and 4, and to create a database of anthropogenic interferences in the mangroves for effective implementation of policies in the conservation. Thank you.
Yeah, any questions? It's open for discussion. Yeah, please.
So regarding the AIDI, which you just described, can it be only applied to mangroves or other?
Not necessarily, ma'am. This is derived from several indexes which we did a literature survey on. There is a human dependency index, and there are also site-specific indexes for terrestrial forest as well, and even urban specialized indices are also available. So this was only coined in context of our research for making it easy.
Okay, thank you.
Yeah, please.
I was a wonderful presentation. I really liked, this is a very novel work. I understand that you're taking care of the primary survey and connecting it with the data.
Thank you.
I want to know that correlation. So are you progressing towards running a regression and finding out actually what is determining in
Yes,
future?
ma'am. This was a preliminary work, and we got this idea like in a spur of the moment kind of a thing this was. But we are now, currently we are now analyzing the spatial data from 2000 and early 90s, so that we can get a track record of how it's been affecting since then. And we are considering NDVI, which is Normalized Difference Vegetation Index, where we can see a gradual depletion in vegetation or the increase in vegetation in certain areas. So we are currently under work, ma'am.
All right, so you will use the socio-economic data and connect it with that?
Yes, ma'am,
Okay.
because that is how we can really know what is happening in the ground. So this is purely based on local knowledge and also our observations. So we should be able to assess this with accurate spatial data as well and other data as well.
Maybe you will be comparing both the scenarios? Or
Yes, ma'am.
This is the idea.
Yes, ma'am.
Wonderful.
Thank you,
Appreciate
ma'am.
your work. Yeah, bye.
Yeah. So the next presentation is TS 4005, Carbon Sequestration Potential of Selected Mangrove Ecosystem in Western India, by Radish Kumar et al.
Good morning, respected chairs, other dignitaries online who are participating online and offline. So I'm going to present about the carbon sequestration potential of particularly mangroves in the western part of India. So my previous speakers, particularly Anand, has made my job easy. Next. So I'll not be going into the details of the methodology part. So we all know the importance of mangrove, what role it is making in coastal protection, how much it is important to the biodiversity. So everybody is aware, no need to go into all that details. And we know the importance of mangroves in sequestering carbon. So how it is regulating the climate, the global climate. So it is said that the carbon sequestration potential of mangrove ecosystems is 4 times more than the tropical rainforest. So that is it. So it is having a major role in climate control, global. So my study objectives include the quantifying the below ground, above ground and sediment carbon along the west coast of India, to map the spatial distribution of mangrove and associated blue carbon. Then to analyze the temporal changes using remote sensing, as my previous speaker was mentioning, the NDVI, and identify the hotspots of blue carbon sequestration and the vulnerable zones. These were the objectives. So the methodology already it was discussed, so I'm not going into the details, just in brief. So from different areas, identified sites along the west coast of India, say as from Maharashtra, Goa, Karnataka and Kerala. From the identified sites, the above ground, below ground and sediment carbon was estimated first to make an estimate of the blue carbon potential of that particular ecosystem. Then again, so we also used the Komiyama et al. Equation. Then again, organic carbon using the titration method. Then what we did is, again, for this particular ecosystems, we tried to find out the NDVI values to check out whether there is any change in the mangrove cover, whether there is any increase or decrease in the mangrove cover. And we again try to convert it into monetary terms. Because for the policy makers, when we are telling that there is a reduction of this much kilometers of mangrove, they are not able to perceive it as such how we want to. So when we are converting this value into an economic monetary term, so it is easy for the policy makers to take a decision. So to make a strong conservation effort and for the policy makers to take action, so these were the objectives and the methodology we delayed upon this. I'm not going into the details because it was dealt in detail by Anand. So this is the same methodology for estimating the core carbon stock, the above ground, below ground and the sediment carbon from different ecosystems were estimated and based on the different species. So we identified the species also from this location. So this is the methodology and the major species. So we have again transects, 50 into 50 transects was used. Then again from that transects the species density was counted, the tree height, the branching area, the canopy. So using all that things we calculated the above ground biomass Then the below ground biomass using the basal width, then the root depth and the carbon in that area. So based on that, we estimated the carbon stock in that particular mangrove ecosystem. So the major species what we have identified from the west coast is listed here. I'm not going into. This is the estimate. This work is going on. Actually, my scholars, when they are going for the marine mammal survey in a particular state, they'll be covering this also. So they'll be collecting the details from that particular mangrove ecosystem. So this work is going on already. Kerala also we have completed several sites. So this is about the carbon potential from different ecosystem. What is shown in red is having the maximum sequestration potential, that mangrove ecosystems. I'm not going into details. This is again a bar diagram showing the different carbon stock in different areas in Maharashtra, Goa, Kerala and Karnataka. So again, as I mentioned, for the policymakers, so we know, so based on all this, we calculated the carbon stock, then again converted it into monetary terms. So we made it into carbon dioxide equivalent using the IPCC and IPCC 2007 equation. So it is shown in carbon dioxide equivalent is equal to total carbon stock into 3.6. So again, based on the Rick et al. Equation, we made this carbon dioxide equivalent into monetary terms and trying to find out how much of carbon is stored in our sediment, in our Indian coast in monetary terms, so that it will be easy for the policymakers. Again, it will help in carbon trade also. So this is going on. Again, we try to find out the change in area in the cover, mangrove cover in different, all these ecosystems, how much in temporal scale. So previously what was the cover, and now based on sentinel data of 10-meter resolution. So the NDVI, already my previous speaker was mentioning about the NDVI, normalized differential vegetative index. So if it is between 0.3 and 0.8, it represents the mangrove. So based on that, so the red zones represent that in the temporal scale, when it is moving forward, the mangrove area is coming down. So this is again for the policy makers to take an action. So how much of carbon wealth, and again we are converting it into monetary terms, how much we are losing amount in terms of carbon, in terms of mangrove. So this is a strong indication to take restoration and conservation efforts for mangroves. So these are the results. So for different sites, we have identified the hotspots for this blue carbon stocks, and we mapped the hotspots in JS platform, and we converted into, and again using the NDVI, we calculated the loss in area because of anthropogenic activities. Then again, we converted to monetary terms and suggested this policy interventions. So this is the conclusion. So the mangroves are one of the most important blue carbon ecosystem. As I mentioned, it is having potential of 4 times than the tropical rainforest, and conserving and restoring mangroves is essential in the fight against climate change, the global warming phenomena fueled by increase in carbon emissions. So these are some of the efforts which our division, particularly MPEMD, is taking forward for restoring and conserving mangroves. So in different areas along the Kerala coast, we are, even last week also our team has been to, which area? Kadamakudi for restoration. So this work is also going on. So that's it. So with this, I stop my presentation. Blue economy for a green Viksit Bharat. Not only the vision for Viksit Bharat, it should be climate friendly. A green Viksit Bharat we anticipate by 2047 through conservation of mangroves and restoration efforts. Thank you all.
Thank you, Ratish. It's a wonderful paper, and in fact, it's very close to my heart. My entire, the idea of this research is based on this concept, why mangrove could be planted all around the coast of India. See, such a wonderful natural barrier of all kind of water-related disasters is a mangrove. And I spoke to my co-PI Abdul several times on this matter, and we discussed, and we wanted.
So you are not audible.
Am I? Oh, I'm sorry. What I was telling you, that I was speaking to with Dr. Abdul, my co-PI, several times, that why we can't have enough mangrove grove plantations entire Lakshadweep area, where exactly our focus of research is, the Minikoy particularly. Now the question is, the Kerala being the God's own country, I would say God's own state, doesn't have the mangrove cover, very unfortunate. Whereas Maharashtra has, Goa has, and even Karnataka has. the question is this, we could have definitely done it. My question is more general than scientific, because you are a scientist, I am not. So since I am handling the people, society, and you are handling the science, so we are gelling there. My point is, why it couldn't be possibly be planted in Kerala coasts, where it is more plausible and more appropriate because of the land fertility and the coastal area and all that. So simple. It may be a little political.
Yeah, that's it. I was about to tell.
Yeah.
It's a bit social and political. We have good mangrove areas in Kannur region, in Kollam Ayiranthangam region, even in Cochin, in Ernakulam, Puduvaipu, that region we have good, but it is not comparable with the other parts. Like you mentioned in Maharashtra, how much we are having in Karnataka and even Goa. They have huge areas protected. But here the problem is, even we are facing, when we are going for mangrove restoration also, the people are not ready, because once the area is established as a mangrove forest, then the property belongs to the forest department, even it is a private land also. Then again, the activities are restricted. We cannot destroy, we cannot construct. It will be a part of the CRZ. So there are several political and social things involved in that. So people, public normally, they don't want to convert an area into a mangrove, even though they know the importance of the mangrove. Even the politicians also, because coastal area, you know, the economic activities in the coastal area. So they want to develop, we have to be in an equilibrium. Development, conservation, and the social dimension. So we have to think about all the three dimensions. So you have to make an equation to satisfy the needs of the developers, to needs of the society, and the politicians. So that's where the problem lies.
Thank you very much.
Thank you, thank you. Thank you.
Yeah, thank you, Ritesh.
Thank you,
Any other questions? Online participants? Okay, thank you. So next we'll move on to Subal Kumar, TS4010, unveiling the hidden riches, ethiofaunal diversity from mangroves of Champa Estuary, West Bengal. Dr. Subal?
Yes, madam. Good morning, madam. Madam, it is visible.
Yeah, it's visible. You can put it in slideshow mode.
Yeah, I already put it slideshow, madam.
Okay.
How it is, madam, now?
Still in, it's not in slideshow mode.
Now also not like that, madam.
No. So we'll
You
just
can,
check
stop sharing, do the slideshow, and then share again. I think that will be better.
Okay, madam. Now it is, madam.
Yeah.
Full slide, madam.
Yeah, you can start.
Moving, madam. Now it is moving.
Yeah,
Sliding.
it's moving.
Okay, madam. Yeah, good morning to all, and today I am presenting the topic on unveiling the hidden reaches, the ethiofaunal diversity from the mangroves of Champa Estuary, West Bengal. And I think everybody knows what is the importance of mangrove ecosystem. Many of our speakers already mentioned that it is one of the most productive and biological diverse habitats on the planet, which act as a low carbon sinks and adding climate change mitigation, which serve as a vital in ecosystem or a nursery and breeding ground for many of the commercially important finfish and shellfish species. And my study area is the Champa Estuary, which is located along the coastal stretch of West Bengal, that is Purba Medinipur district, which has a very good mangrove vegetation and it has a dynamic estuarine environment. Despite its ecological significance and importance, the ecological diversity of this region has remained unexplored. That's why the present study aims to document the species diversity and the composition of the fishes, pinfish and shellfish inhabiting in this unique ecosystem. And coming to the material methods, as I mentioned, my study reached Champai estuary, and sampling period was conducted during April 2023 to March 2025, and sampling was done mostly fortnightly, and from the traditional bag net, the Behendi jal, which was operated by the local fishers in this region, and the species identification was done by with the help of the standard literatures and statistical analysis done in the R software. And this is my sampling location. And coming to the resultant discussion, in the present study, I could able to identify the 167 species belonging to various group under 124 genera and 75 family and 38 orders. And if you see that highest contribution was done by Decapoda, followed by Acanthuriformis, then Gobiformis and Crubiformis, and other species are contributed very few only. Hello, am I audible, madam?
Yes, yes,
Hello.
go ahead.
Similarly, if you see the percentage contribution by family recorded, highest contribution was by Pinidae, followed by Gobidae and Cyanidae also. And similarly, if you see the genus wise, highest species was by contributed in the genus Jonius, then Cyanoglossus and Metapeneus, and many of the species of genus contributed a very limited species. And if you see the we have also done some season wise diversity analysis. We found that in the cluster dendrogram cottage and that dissimilarity analysis, we found that if you see the biodiversity among the April to June and October to December, and more or less similar kind of diversity observed, whereas the other season it was quite different from this months. And similarly, if you see the hill diversity number, that highest diversity was recorded during the April to June, and whereas the lowest was recorded during the October to December month. Similarly, Shannon in diversity index also indicated the same only. And this is the plot showing the cumulative percentage abundance and of the 4 seasons, which is the similar kind of result we observed. And these are the as I mentioned, this is the some of the species photographs I mentioned here, and these are the species we have recorded with many. You can see the most of the species are highly commercially important, and which clearly indicate that it is one of the important nursery breeding ground for the these species. And similarly, these are the shellfish species we have recorded during our study period. And these are the length range of finfish and shellfish. So this is the some of the species I have noted here, and this is the length range and mean length of the species. And as a conclusion, I would like to say, as you know, the Champai estuary is support a rich and diverse assemblies of Isthaia and undergoing their role as a vital nursery and feeding grounds for many of the finfish and shellfish species. And it documented the several species of ecological and commercially important, many of which depend on the estuary environment for the part of their life cycle. And seasonal variation species composition highlight the dynamic nature of the estuarine ecosystem and the need for continuous monitoring. And this baseline data provides a valuable insights for biodiversity conservation, fisheries management, and habitat protection in the coastal West Bengal. Protecting these hidden aquatic reaches is not only essential for sustaining local livelihood, but also for ensuring the ecological integrity of the estuarine mangrove interface. And coming to the way forward, it's highly essential to promote the protection of such critical mangrove habitats as a fish nursery and breeding grounds, and recommend site-specific restoration measures in the degraded zones, to establish the baseline data for future ecological assessments, and to monitor the climate change impacts and the anthropogenic stresses on the fish diversity, and also to involve the local fishery and citizen science initiative to involve and inform the local fisheries management policy using scientific findings, explore trophic interaction, ecosystem service, encourage multidisciplinary research to link biodiversity with ecosystem function. These are my references. And lastly, I would like to say conservation begins with awareness, and let's protect our hidden aquatic treasures. Thank you.
This is now open for discussion. Any questions? Okay, thank you, Subal.
Thank you, madam. Thank you.
We will now move on to, I just want to know if SS Kawade is available. No. Yeah, what about Venkatesh? No. Okay. No. We have one more presentation from this session, that is Harshita's. Okay, I now call Dr. Vipul Sharma. So evaluators, please note, this is a paper moved from the previous session. So the number is TS3009, no, TS3004. Mapping the impact of climate change and disaster on tourism in Rajasthan, a district level analysis.
A very good morning to all of you. So my study is a little different because
Please, can you be louder, please?
Okay.
Can't hear you.
So my study is a little different from the what all has been happening here, because this is the desert state of India, Rajasthan, and the study focuses on this particular state. So the idea here is to mapping the impact of climate change and disaster on tourism as an industry in Rajasthan. So what we are trying to do is we are trying to do a district level analysis in our study. So just to give you a brief background about this state, when we go about the geographical profile, when we can see that it is northwestern India, largest state by area, and topography is varied. You have a Thar on the western side, Aravalli ranges which dissects the Rajasthan almost in two equal parts. There are major rivers like Chambal, Banas and Luni, and in terms of climate, it is arid and semi-arid, and extreme temperature variations are observed. And if we talk about tourism in Rajasthan, tourism and hospitality sector, this has been accorded the full benefits of industry status by the government of Rajasthan. Tourism sector contributes around 12% of state's GDP. And let me put it here, it is more than the national average. And in financial year 23, 179 million domestic tourists and 1.7 million international tourists visited Rajasthan. Now, tourism's economic role, here comes the intersection of socio-economic angle. So tourism is a major catalyst of socio-economic development. As per various reports, including the RTSA report, Rajasthan tourism sector contributes around 7.48% to state GVA, provides 11.26% of employment, and when we compare it with the national tourism GVA, the national tourism GVA is 9.24%, and employment share is around 12.38%. So what's the rationale for this study? Now, when we see the rising significance of tourism as an industry in terms of providing employment, we see that globally travel and tourism contributes around 9.1% of world GDP as per the 2023 data by WTTC, and it created 27 million new jobs in 2023. When we talk about India and Rajasthan, we can see that IMF World Economic Outlook, in its 2024 April report, it says that India among the fastest growing tourist economies and expected 6.5% real GDP growth in India. And Rajasthan was supposed to be the major contributors in this growth journey. Why this study? Now, despite the impressive growth, Rajasthan tourism faces increasing risk from climate change and disasters. Understanding how climate hazards may undermine tourist-led development is crucial. So joining the dots, high tourism dependence, especially in heritage and rural districts, makes climate risk assessment its urgent need. So this is a brief literature review of all the studies of similar nature conducted. So I'm just moving forward. So what we did, we run a regression model, and formulation of this model is captured in this equation. We first run the fixed effects model, a panel data regression using Stata software. The Hausman test is performed later to undermine whether a random effect of fixed effect model should be chosen. Now, based on the results, the Hausman test suggests that the random effect model must be adopted. After conducting the random effect model, the results are tested for heteroscedasticity by deploying the Waltz test. Now, Waltz test suggests a higher level of heteroscedasticity in the data. Consequently, it is removed by performing the panel generalized least squares regression. This is the data description of our research. These are the variables. Now, variables are the tourist arrivals, migration, population density, rainfall, literacy, and the per capita income. So we try to capture the socio-economic indicators as much as possible. Due to scarcity of data, with the state government, we missed few of the important indicators, but this in totality try to capture all the major socio-economic indicators. So this is a scatter plot, and we try to study the decadal variation from 1991 to 2001 and then to 2011. This is the annual rainfall versus total tourist arrivals in the state of Rajasthan. So district level analysis, we are trying to, this is the representative data, we were trying to capture how in a decade things are moving vis-a-vis the annual rainfall. So this is for tourist versus annual rainfall. This is our second indicator, which is literacy rate versus tourists. This is again the decadal variation from 1991 to 2001 and to 2011. So this captures district at the district level, how things are moving. Similar is with the per capita income versus the tourist. And similar with the, I'm not going into the details because it will come eventually in the next slide. This is population density versus the temperature. So the findings. So when we ran our model, it was found that the migrant variable is removed as it is found to be highly correlated. So we removed this variable, and the overall level of significance of the model is substantially significant, as it is reflected by the F value. So the coefficient of determination or the goodness of fit or the model is substantially high, around 62.5%. So coming at the major findings, the per capita income significantly affects the total number of tourists. However, it has a significant negative impact on tourists. This suggests that as per capita income of the district increases, it reduces the footfall of tourists. Now again, when we compare with the population density does not affect tourism significantly, though an increase in population density reduces tourism in the district, suggesting tourists are moving more driven towards uninhabited and less urbanized regions. When we compare with the rainfall as a variable, rainfall significantly increases tourists, suggesting that as Rajasthan has been marked as a dry and drought region with an increase in rainfall, the tourists in the districts of Rajasthan have increased their footfall. And in last, literacy rate is not directly related and affecting tourism significantly in any way. So in conclusion, we can say that climate change has emerged as a key factor positively influencing tourism in Rajasthan, acting as a driver for increased tourist inflows. Visitors are increasingly drawn to less populated and less urbanized districts, as indicated by significant negative association of tourists with per capita income and population density. These are the few major policy recommendations which we think can be like somewhere added in major policy discourses. One is to promote tourism based on a quantitative research and the findings which we found. The first is promote tourism in low income and less urbanized districts. This is because since per capita income negatively affects tourist footfall, districts with low income levels appear more attractive to visitors. So based on these, the recommendation can be develop rural and heritage tourism circuits, and invest in basic infrastructure like roads, sanitation, and encourage community-based tourism to ensure local benefits while preserving authenticity. Second is protect and enhance natural resources. Now, since rainfall positively impacts tourism, indicating tourists are attracted to greener landscapes and better environment conditions, in such conditions, recommendations can be integrate climate adaptation measures in tourism planning and water conservation, develop ecotourism projects in semi arid districts, and also strengthen disaster preparedness to protect tourists and infrastructure against extreme climate events. Next is diversify tourism beyond urban centers. This is because population density reduces tourist inflow, showing tourists prefer less crowded destinations. In such a condition, recommendation can be to promote offbeat and lesser known destination rather than concentrating on major cities like Jaipur and Udaipur. Provide incentives for tourism business to invest in smaller towns and rural belts, and design zoning policies to prevent over-concentration of hotels, resorts, and commercial hubs in high-density areas. Next is align tourism growth with sustainability goals, because high model significance, almost 62.5% R-square value, indicates that socio-economic and climate factors strongly shape tourism inflows. Next is rainfall as a tourism opportunity. Now, since climate vulnerability, particularly increased rainfall, is enhancing Rajasthan's appeal, in such a condition, recommendations from this research can be position Rajasthan as an emerging green desert tourism destination during wet seasons. Invest in seasonal tourism calendars that matches climate advantages, and integrate climate resilient infrastructure like shade, water management to mitigate extreme heat risk. Next is, now this is interesting, literacy rate and migration. These are not policy priorities vis-a-vis tourism, because our model reflects that these are insignificant in this study. So since literacy rate and migration show no significant effect, tourism policy should not overemphasize these factors. And focus should be on infrastructure, environment quality, climate adaptation, rather than literacy-driven campaigns. Thank you.
Any questions?
Yeah, hello, Dr. Vipul. Yes. Now, you have done a study, and one of the parameters rainfall, but then no study has been done with increased temperatures, because temperature, one of the major change in climate change is increase in temperatures. So what about the increase in temperatures and impact on tourism?
So, this is the further extension of the study. We will be incorporating two important variables again. One is temperature, and another is in last 3 and 4 decades, district-wise, how many disasters have been declared by Government of Rajasthan. Since the data we have moved from department to department with the Government of Rajasthan, but they have not maintained the data in a time series format. It's very difficult to extract data from the government. So this is an ongoing process, and we're trying to we will include these two major variables in our study in the coming times.
Okay, thank you.
Thank you.
Any other clarifications?
Yeah, Vipul, it's a wonderful point, but then ecotourism you have mentioned rather little briefly. Taking the access to ecotourism, what exactly parameters that you think about it? And see, Rajasthan is a state where not only sands abound, but also there are some jungles. We have Ranthambore Reserve Forest. Now the question is how much the climate change, how it is affecting. We had read as the news a few years back that flood had delodged the animals in the Ranthambore, and they have become shore along. So how do you equate these things, and what are the parameters of the climate change effect on the general temperature of Rajasthan, and how you think it should be better coped with?
Thank you, sir, for the question. So let me bring to the notice that when we look at the map of the Rajasthan, what we see is that Aravalli range is almost equally dividing the state in two parts. The western part falls almost in the desert state. The eastern part is like semi-arid and some vegetation is there. So when you say that, like in a study also we pointed out that in 2024 December, Rajasthan government came out with the Rajasthan tourism policy. In last year only they came out with Rajasthan tourism unit policy to incentivize the tourism units. So what exactly is missing, that they are not going at the level of district. They are looking the state as a state entity, and they are formulating the policy based on considering the whole state as one unit. But when you go at a little granular level, and when you analyze that district level, there are very much differences in terms of tourist footfalls, the geography, the climate, and the variation in the variables. You need to fine tune and modulate the policy incentives and parameters accordingly. I think if at the level of district, when we analyze such variables, the results can be different, and what we expect can be achieved if we go a little deeper and analyze at the level of district.
Thank you, Dr. Vipul. Who was it? Please talk into the mic.
Very nice presentation, sir. Actually, I have doubt about you are telling about the disaster, but in there in PPT you didn't mention any disaster related thing.
So this is the gap. Actually, we couldn't gather the data from the government of Rajasthan. We have data for disaster from 2011 to 2024. So that is not even in time series format. What they do in Rajasthan, 3 major disasters are there. One is hailstorm, second is flood, and third is drought. And like in terms of earthquakes, there are no major earthquakes, although we have few tremors, but low intensity tremors. And the disaster in Rajasthan is a political issue, because once the government of Rajasthan declares any particular disaster, it has associated incentives to the farming community. So in legislative assembly, there are frequent questions from local region MLAs that why this particular event has not been declared as a disaster by the government, because this much rainfall has occurred and farmers are impacted. So in such a situation, what they do, from 2011 they have maintained the data on their disaster and relief department website, in which they declare they put the notification that these are the districts in which drought has occurred, these are the districts in which hailstorm has occurred, and this is a loss, and this is the amount which the government of Department of Finance will provide to the districts. But before 2011 they have not maintained this data in digital records. I visited the department many times, but they are unable to provide the files, because these files have been moved to us. They have this clearing mechanism. Once the file gets old, they are deposited in some storage unit, and that storage unit is not sequenced. So you cannot find a 2010 data there, because it's a black box for us. You have to scroll through all the files one by one, year by year, district by district. So I think the paucity of time didn't allow us to go much deeper for disaster data, but this is an ongoing study, and we'll eventually try and gather the data related to disaster.
Sir, another thing is you are collecting rural data.
I will just break him because we are running short of time. Maybe you can take this conversation outside and discuss with him over tea. We'll be breaking for tea after the next presentation. Thank you, Dr. Vipul.
Thank you.
Harshita, are you ready for your presentation? Yeah. So this is TS4002, From Silos to Synergy, Navigating Changing Tides in Interdisciplinary Mangrove Carbon Research.
Um, once again, hello to everyone. This is one of the review papers which I authored, and it's called From Silos to Synergy, Navigating Changing Tides in Interdisciplinary Mangrove Carbon Research. I would love to give a disclaimer because this PPT is a little incomplete, but I'm going to present it as it is. So, introduction. What are silos? Silos are the pockets of research. Like, we are researchers, and there are people who are dependent on an ecosystem, and those are called stakeholders, such as carbon scientists, ecologists, social scientists, policy makers, governance, local community participants, any individual who is actually living in this planet, and also ecologists. So why like this fragmented effort towards conserving an ecosystem has been it's like this provides a poor data interoperability. Like it won't give that much of effective conservation as we had thought, because we will be having one data set and other scientists will be having a separate data sets. But when do we get to mix everything and we see it a larger picture? So we that is the main notion of this paper. So again, these are the restoration limits, and even while planning, one perspective of a scientist is not enough. So what are the gaps in data management? So we are only seeing it in one perspective, as I said before, but the data is multifaceted. So each individual has something to offer and has some observations to make. So there is a need to bring forward a collective effort from all the silos to boost the effectiveness of the conservation. Navigating changing tides. Here, what I mean by changing tides is that shift towards the system-based science and need for a unified and a scalable interdisciplinary database. How is that possible? So these are the emerging synergies which are ongoing now. We have heard about artificial intelligence including in all the aspects of our life. So we are literally being the slaves of AI right now. So, but this in conservation is a good thing. So WWF's passion project, it's called Mangalaria, is one of an emerging and leading project which is going on, and it has been effective to collect all the data, be it environmental parameter, be it human interference, or be it any other aspects. So it is automated and it is collecting data like in a systematic way, and we can collect all the data in a complete database. So this has been very good hybrid model, and UAV, which are drones, unmanned aerial vehicles, are used in order to collect the spatial data, and also community driven monitoring, which is really important in order to locally understand the variations and conservations and to make climate policies, and also carbon finance platforms where the community get to have the benefits and can make the most for their basic livelihood. In conclusions, this integration of all the mangrove research brings about interoperability, inclusivity, which includes each and every scientist or each and every individual who are considered as the stakeholders of the mangrove ecosystem, and also it also provides systematic thinking, like it provides a way on how we can think about conserving a particular area. So the data harmonization and multi-scale modeling, which is particular to each area, and a cross-sector partnerships where we can take like their insights in order to bring about another particular conservation medium can happen from this kind of integrated approach. Thank you.
So, yeah, with that we have come to the end of this technical session. We now break for tea. We will take a short break of 10 minutes and gather back at 11:25. Online participants, we are taking a short tea break. We'll be back at 11:25. Thank you.
Recording stopped.
we are moving to the next session. Theme 5, Innovations and Emerging Technologies for Climate Resilience. The session will be chaired by Dr. J. Jaishankar, Principal Scientist and Head of Fisheries Resource Assessment, Economics and Extension Division, ICAR CMFRA, and co-chaired by Dr. Somi Kuriakos, Principal Scientist of Fisheries Resource Assessment, Economics and Extension Division, CMFRA. And we have two rapporteurs, Dr. Gina N.S., Senior Scientist and Dr. Ashish Kandewal, Senior Scientist.
Thank you very much, madam. Very good morning once again. I think you had a heady session before this, especially focusing on climate mitigations. Now this session is all about the other side of it, because mitigation and resilience, I feel they are two sides of the same coin. So it's like, the coinage is something like this: innovations and emerging technologies for climate resilience. And I am joined by my capable colleague, Dr. Somi, and two very able rapporteurs, as madam announced. So we have, I think, five presentations with a slight change in the order. So basically, I expect to listen to presentations which talk on the probably giving the nudge towards the technologies or innovations which are going to be of relevance to climate resilience, because it's a very big canvas, as all of us know. And when it comes to our own domain, like this CMFRA's domain, it's furthermore tricky. But as such, I feel that those technologies which have these kinds of either mitigation, or which I feel it as maybe adaptation, or maybe resilience as adaptation and mitigation as sort of a prevention. So either prevention or adaptation enshrined in any technology or any idea organically is supposed to be the way forward for anybody planning to add to this particular research area, or maybe ideology or domain of ideas. So maybe I am quite as much, because the topics are a bit variegated, starting from a sort of a tool where citizen science plays a role, and forecasting a big mangrove cover change and things like that, and another type of interactive maps, some GIS based application, and with something to be in transgenerational acclimatization of a particular resource. We call it as guinea pig, or whatever we call it, our marine medaka, that is Varisias dancina related work, more of a lab kind, and a very interesting topic to round off the session on seaweed farming. So it's a sort of I would like to say, bouquet of many flowers, different fragrances, but hopefully all guided towards nudging the society towards better tomorrow, so that our whatever goals, there are many goals now, be it Viksit Bharat goal, or 2050 goal, or IPCC scenario based those kinds of goal, or you call it by any name, blue goal with greening, all those things. So ultimately we are working towards something which is going to make the world, universe, a better place to live in. So with that in mind, I exhort upon the presenters to keep your own verb and be crisp and to the point, and be energetic. Don't lose energy at any point in time. And I am informed by the organizers that you are being given the luxury of communicating for 7 minutes and exchanging for 3 minutes. So I don't know if somebody keeps the time, kindly make note of it. So may I now invite Madam Ansi C. Stoy to present her talk or work titled Tarbakua, an Android powered mobile application and mini Sechi disk for monitoring watercolor and clarity. Ansi, please. 7+3. Yeah.
Thank you, sir. So a very warm good morning to one and all present here. I'm Ansi C. Stoy, DST Inspire Senior Research Fellow from ICAR CMFRA. And I'm at CMFRA, I work in the intersection between digital innovation, citizen science, and water quality. And this work, I'm very excited to present Turbequa, an Android-powered mobile application and mini SecuDisc for monitoring water color and clarity. This is a part of my doctoral research program work, and it is supervised by Dr. Grimson George, Director CMFRA, and it is co-supervised by Dr. Minikoy, Principal Scientist CMFRA. Yes, let's get moving. Thrissur Puram. So, dear Keralites, I hope I don't have to add any explanation towards this. So, as a native of Thrissur, Thrissur Puram means the festival of festivals or the mother of all Purams. So, what I feel is that once people came to Puram to watch, feel, and be present. But as a native of Thrissur, I'm feeling now we are witnessing many come not just to see, but to record. See the number of raised hands with smartphones in their hands. So this recognizes a shift in social behavior, the way we monitor our environment and surroundings, because we are treating smartphones as an extension of ourselves, and we are always carrying it everywhere and anywhere. So we thought about, why can't we do something productive, creative, or innovative out of that? Yes, why can't we use that for creating science? This is exactly what the Turbequa mobile application, which is a mobile application that is developed by CMFRA for water-led citizen science monitoring, came into being. So using the Turbequa map, we can record the Secchi depth, which is a measure of water clarity or transparency. And comes the foreign UL color. It is used to measure the water color of natural water bodies. Then you can also add temperature measurements and upload the water surface images through that. So all these data are getting encapsulated, and including the geotagged images are transferred to the CMFRA, the central server that is placed at CMFRA. And this is how Turbequa is supporting the citizen science initiatives. I will come the more detailed explanation in the coming slides. So the Turbequa is not alone in our initiatives. Turbequa is having a companion, and that's the mini SecuDisc. So as you can see in my hand, this is a mini SecuDisc. It is used for taking the water transparency measurement. You can vertically insert this disc into the water and measure the Secchi depth by measuring the distance at which the Secchi disc disappears in water. And you can see a foreign UL color scale, which is a standard scale used for measure the color of water bodies, that is 3D printed on the casing. And it spans from 1 to 21 in colors, from blue to green to yellow to brown. So along with the Turbequa mobile application and mini SecuDisc, we are leading the citizen science activity. So what is happening? It's all happening in Lake Wayanad, which is the largest water body, largest lake in Kerala and the longest lake in India. So we are zooming on to the southern side of the lake, where you can see the paddy field cultivation is happening around the lake. From there we are moving on to the hotspot, that's the Padira Manal Island, which is an eco-sensitive zone, and where more than 90 migratory birds and other butterfly, other aquatic plants and species are seen. Now we are zooming on to the Thandirmukham Bund, which is India's largest mud water regulator, which prevents saltwater intrusions into the low-lying paddy fields. Then we are moving to the northern side. Yes, you can see the densely populated area in Kochi. The way we're zooming is the Wellington Island, which is the largest artificial island in India. So see how physically complex my study area is. So this is exactly this physical complexity, and its added optical complexity adds the citizen science activities, and we can lead water-based water quality monitoring in this study area. So meet our citizen scientists. So they are students, university students from 13 colleges situated around Lake Wayanad, and we have entrusted the mini SecuDisc, and all these people have downloaded the Turbequa app in their respective smartphones, and they are doing the citizen science activities since 2018. So now I'm focusing my presentation to the foreign UL colors. So this is the classic foreign UL color scale, which consists of 21 colored liquids in vials. But it is not safe for citizen science projects or for public use. Why? It's because these liquids, they are made up of hazardous chemicals. For example, potassium chromate and cobalt sulfates, these are carcinogenic. So we cannot use it for public or citizen science initiatives. So what we have done? We have come with an innovative idea to include the digital foreign UL color scale in the Turbequa app. So using the spectral data, these colors were conveyed into the digital values, the sRGB values, and we have used the standard color space CIE 1931XYZ for that. And now the users are taking water surface images through the mobile application, and the digital foreign UL scale get overlapped onto the image. And the users can now compare the color of the water surface image with the foreign UL index in the digital foreign UL scale, and it's very convenient for the citizens to classify the water color. Now, next week came, yes, now we're having two sets of data. The first set of data is collected using the standard 4LUL color scale imprinted on the mini Secchi disc, and the next set of data is collected using the digital 4LUL scale in TurboQuab. Why can't we compare it? And yes, out of 844 data, we got exactly 677 user measurement, which showed a perfect agreement between the digital and standard 4LUL values. So that's a great news, but we all are humans and this is citizen science data. Minor discrepancies are expected, it's always expected, and it tends to have a little underestimation or overestimation of the values too. So we are going to have a closer look, what we have gone wrong. So see the 4LUL index, what we observe is that the 4LUL index, like 4LUL index 18, 15, 17, which belongs to the extreme end of the scale. Those color, it means the 4LUL color scale from 18 to 70 means water belongs to greenish brown to brownish green to cola brown in color. They are getting misclassified to the 4LUL scale 6 to 9, which means that belongs to the 4LUL index greenish blue to bluish green zone. So there is some sort of misclassifications or confusion that exists among the users while selecting the colors belonging to the extreme end. That's when the greenish brown colors getting confused with greenish blue to bluish green zone. So this is an ongoing work, so we are investigating more into this, whether some calibration aids can be added or for more specified trainings can be made available to citizens to wipe out this sort of errors also. So finally the question is, what is the most prominent 4LUL color class in Lake Vemrad? And yes, we have an answer. It is the 4LUL index from 14 to 17, which means the water is greenish brown to brownish green in color. You can step out from the institute. The Vemrad Lake is just opposite to this institute. You can just go and visually verify what's the color of the water. Yes, it's in greenish brown to brownish green. And what it means? It means the lake may contain high amount of nutrient, phytoplankton, sediment, and dissolved organic matter concentration. So that's quite typical for water belonging to near-shore areas. So that's a general overview of my work, and with some extension slides I have. You have Android users, if you would like to download the app, you can quickly scan the QR code, and for the iOS users, the work is still in progress. We are in the process of making TurboQuab international, so just wait for some time. And you can see, those who want to know more about this work, I'm having a video in region language, which is shot as a part of my Kerala Science Slam presentation, in which I was a finalist. And for all other people from different parts of India, you can log on to the English video as shot as part of this Trevor Platt Science Foundation Outreach Fellowship programs. And I'm pleased to say that I could also feature my research in the second popular Malayalam daily called Madhrubhumi. So that's it. Thank you everyone for your keen attention, and I would like to thank your belief in people-powered science also, and I would like to just mention our partners. Thank you ICC MFRA, DST Inspire, my funding partner, Plymouth Meridian Laboratory, Meridian Solutions, and Brewtech Limited, UK. Thank you. Have a nice day.
Thank you very much. Now the session is this presentation is open for discussion.
Yeah. Hello, Ansi.
Hello, ma'am.
Congratulations. I just want to know, because your app is mainly based on the color, right?
Yes, ma'am.
Yeah. So how is it, how do you compare it to water testing? You have very advanced water testing machines available, which will give you many more parameters, like, many more parameters on a single water sample. So how do you explain that your app or Turb Aqua is advanced or advancement on that?
Okay, ma'am, thank you for the question. I would like to emphasize the fact that there are a lot of traditionally most advanced, even hyperspectral photometers are available. The data is available, satellite data is available, but still people
have hand, water testers, very advanced, very electronic, and you can take them to the site and you can just take a sample and you can get many more parameters, water parameters. So, yeah, not only spectrophotometers which are in the lab, but then you have handheld small monitors also available.
Yes, ma'am, but I would like to emphasize the fact that this is a citizen science initiative, and while our scientific team is going for the water quality measurement, we are using all those scientific instruments, but for a citizen science project is concerned, we have to simplify the instrument as small as possible, because we have to attract the citizen scientist into the work, so that I would say that the most primary indicators of water quality in anyone and everyone, there is no age limitations for involving in citizen science activities. So the first and primary instinct when a person sees a water, if you are given a glass of water, we will just suddenly, the first thing we will notice it, what's the color of the water. If it is turbid or murky, we won't drink it. So this primary instinct of this watercolor is what we have integrated into the citizen science initiative. So we are making the work easier for the citizen scientist to add this data to our project, and the other part, our scientific team is doing all the advanced water quality parameters also. So it's like they are complementing us in data collection. That's why we have.
Thank you. Thank you.
Thank you so much.
Yeah, thank you, madam. I think my request to those who want to participate in the discussion would be to introduce themselves and then start asking questions. I'm sorry if madam has already introduced herself before. So any other point on this? Offline participants, any questions? Would you like to ask any question to us?
No, I just want to request, like we are in search of the citizen scientists for this academic year 2025. So anyone, if wish to participate, it's so simple. We are having the slots in our lab. We will just hand over after giving a preliminary trainings, and you can take part, and it will definitely contribute to the vision Viksit Bharat 2024. And yeah, enjoy learning. Please be part.
Viksit Bharat?
2047. I'm sorry, 24.
You are back to the future. Anyhow, congratulations, and it was a nice presentation. I think the key thing which I as an individual take from this is the citizen science part of it. So madam asked a very complicated question because it was a very, it has to be analyzed on its merits, because many things were probably nudged forward, but you gave a reply which is, of course, which suits the focus of your work or study. So I take citizen science as the key. Maybe that's how, because I think some 10 years before probably citizen science would have been sounded like an oxymoron. Now I think they have become synonymous, because every citizen is a scientist, and of course scientist has to have his citizenship, values. So my what you can say, like full-blooded appreciations to your, you have been the brand ambassador, I should say brand BMW now. So hopefully you become brand satellite. So may God bless you. Thank you very much for gracing this. So I'm moving on to the next presentation. As per the list provided, it's an online presentation by Ajay Nakhawa, my colleague from Mumbai Center. He is the scientist in charge, and he wished to share his thoughts on the work, which is entitled Forecasting Mangrove Cover Change in Mumbai using a modeling approach for climate change resilience. Ajay ji.
Yes sir, it is visible sir.
Yeah, it's visible. आप थोड़ा slide show mode में चाहिए. Floor is yours.
It is okay now sir.
हाँ, बढ़िया है. चलिए. All the best.
Good morning all. Today I will present on forecasting mangrove cover change in Mumbai. Mangrove cover change in Mumbai using modeling approach for climate and the coastal resilience. So mangrove are the unique intertidal forests that serve multiple ecological functions. They are our natural sea wall, absorbing the force of wave storms, which is increasingly critical as climate driven extreme weathers are getting intensified. They are also a biodiversity hotspot, serving as a nursery for fishes, crustacean, and sustaining both artisanal and the commercial fishes. If you see in the climate perspective, mangrove are the globally significant as a blue carbon ecosystem. They sequester they sequester carbon dioxide not only in their dense biomass but also in the sediment, locking carbon away for centuries. And IPCC now has emphasis mangrove as a nature-based climate solution. So most of the Mumbai mangroves are located along the Thane Estuary creeks. So it has got different tags, such as Thane Estuary is considered as the largest creek in Asia, and some part of this estuary has been designated as a flamingo sanctuary, as it is a stopover site for the iconic migratory bird flamingo during migration route for feeding purposes. And recently it has been designated as the Ramsar site, which make an international importance of the site. And they are also called as the lungs of the Mumbai. It is a metaphor used to underscore the role in the urban environmental health. But though there are too important. They are under the severe threat due to rapid urbanization and land reclamation activity for the infrastructure and the coastal development project. And another is the pollution from the untreated effluent by the nearby industrial area further degrade this fragile ecosystem. The challenge is just not local. The city across Asia, Africa, and South America face a similar pressure, making Mumbai an international example of the conflict between the urban growth and the ecological resilience. But some positive sides are there that some of the international, multinational, global corporation are attracting towards this. Recently, Amazon has invested 15 million for with agreement with the Mangrove Foundation for because of this increasing recognition of the economic and environmental value of this ecosystem, and this demonstrates how the growing trend where the private sector is taking up active role in climate resilience effort with a positive signal for the future of the conservation. So in our methodology, we have used satellite data from Landsat satellite image. It has a long satellite series data from 1970 onwards to till date. So we have used two satellite data from 2004 to satellite image and 2025 from Landsat satellite. And the software we used were QGIS open source software with Mollusk plugin, which is a model for the land cover classification, land cover classification evaluation. It is a robust plugin used for this stimulation, land use change stimulations. And the spatial driver we use were hillshade aspects, slope, and roughness. Hillshade used for separating the rocky substratum and flat mud flats. The low contrast value are related to flat mud flats, while high contrast value are related to rocky substratum. While the aspect spatial variable help to know the exposure to the sunlight and tidal channels, which help to determine the sunlight exposure, temperature, soil moisture, which are important for the growth of the mangrove ecosystem. And third is the slope. Intertidal, it helps to identify the intertidal zone and strong and know the strong influence of soil depth, erosion, drainage, and the potential region for the mangrove expansion can be identified. Then fourth is the roughness, which helps to identify the coastal vegetation from the hilly vegetations. So this special driver were used. So our methodology used the analytical framework. Our framework integrated two complementary modeling approach: artificial neural network used for learning complex and non-linear pattern of land cover change during the multiple spatial variable, and cellular automata allowed us to estimate.
एक मिनट अजय जी, कुछ यहाँ प्रॉब्लम हो गया. एक मिनट होल्ड कीजिए प्लीज. सम इश्यू हियर. 1 minute. एक मिनट भाई, थोड़ा यहाँ पर क्या है ना, ये जो ऑफलाइन वाला हमारे ऑफिस का जो है डिस्प्ले बंद हो गया है, तो थोड़ा रीस्टार्ट हो रहा है. 2 मिनट मैं बताता हूँ आपको, प्लीज. हाँ आप शुरू कीजिए प्लीज. You can start now. Yeah.
So our framework generally integrated two complementary modeling approach. Artificial neural networking, where used to learn the complex non-linear pattern of land cover changes given by the multiple spatial variable. Then the cellular automata allowed us to simulate how these changes propagate across the landscape by grid, capturing the spatial dynamic of the expansion and loss. And the calibration was done using the historical data and while taking the baseline data from 2025 and to know the model predictive accuracy. This dual approach has been used internationally in land use land cover science, but this approach has been used first for the urban mangroves specific to this region. Then stimulation workflow was that first we classified, as we explained, satellite imaging to land land use classification. Then we integrated the spatial drivers from it, and third we trained the NN using the transition matrix was prepared, and the NN module was used. We can use multi-criteria. There are different modules in this molus we can use. We use ANN as it is robust. There are as it is robust, and there are certain parameters we have to set, and it is basically a trial and error method till we get the best accuracy coefficient. So we have to set the hidden layers, then training for the number of times the training data set has to be trained, then the learning rate, how model output update the weightage for different spatial variable, and validation, the portion of the data set used for the testing. Then we run the cellular automata for stimulation of the project future scenario under observed development and trend. Finally, we identify the degradation hotspot and area most vulnerable to loss and regenerative hotspots, and where the ecological restoration will be succeeded. So this is a status change map from 2004 to 2025. So mangrove has increased slightly during this period, around 583 hectares has been increased, but the spare mangroves has been declined drastically by nearly 14,000 hectares. And mudflat, which is often transitioned into mangrove, also fell sharply. In contrast, built-up area has increased significantly, underscoring the relentless pace of this expansion. So in if we after stimulating this, we got a mangrove cover for the 2036. So the green area represent the mangrove coverage for the year 2036. So moreover, the dense, if we see only for mangrove perspective and the spare mangrove, the dense mangrove are relatively highly stable with 99% of remaining area remaining unchanged. Only tiny loss of 40 hectares is predicted primarily due to the built-up area. This indicates the resilience of the established mangrove, but underscore that even small losses are ecological significant. The major concern where the sparse mangrove has identified most vulnerable category with 50% only unchanged, and the model forecast that around 1,184 hectares will be converted into the built-up area or for some into terrestrial vegetation. These suggest that survey degradation and conversion pressure like from urban expansion and coastal development. And here you can see the satellite image with zooming that red area, which is currently is being spare mangrove area, is likely to be converted into the built-up area for the developmental project. So this is around 1,400 hectares of area which can be converted into the built-up area coming in 2036. So now this is overall change from the 2024 to 25. So the map highlight, we can see the stable mangrove persist, but the peripheral zone show widespread degradation and conversion, and built-up area is expanding along the creek areas, often directly encroaching the mangrove habitation. This is one example where the down the Google Earth images are there. Here you can see clearly that the spare mangrove area and mangrove area has been converted into for the international airport. So around 1,200 hectare area of the mangrove has been converted for the developmental purpose. So this examples was a powerful validation of our model, finding that underscore that immense pressure that urban expansion is taking place over the mangrove ecosystem. So there are some policy and conservation intervention need to be taken. First, the enforcement of coastal regulation enforcement. Though Maharashtra have the strong Maharashtra Coastal Zone Management Authority, which is a nodal agency for granting any developmental projects in the mangrove area or CRZ area. But community-based restoration, especially in the peri-urban, can secure the long-term mangrove resolutions. And special focus will be given to the spare mangrove because they are treated as a priority restoration zone, supported by the ecological engineering integrating the urban planning. Mudflat must be protected by binding reclamation and recognizing the role as a blue carbon sink and promoting ecotourism. And regular remote sensing monitoring and community participation will ensure this adaptive management. And like carbon credit or payment for ecosystem services schemes can help to link with the climate resilience goal and can make the conservation both ecological and economical viable.
Thank you, Ajay ji. It was quite sumptuous just before lunch. Now the presentation is open for discussion. Please, sir.
Dr. Ajay,
yes.
I'm a layman. I do not know much about the scientific side of the mangrove.
Ajay, one request.
Yes, sir.
You can just stop the slideshow and then come
okay,
on.
Okay.
Video can be put on.
I don't know much about the taxonomy of the mangroves and others. I've got two simple questions. One is by common understanding, what should be the time gap between the plantations? Say, once you plant mangroves at a certain hectares of lands, and then how long would you wait for the next plantation, or would it be a continuous growth like people tree or banyan trees like? Second, the CRZs are generally taken care of.
Hello.
Yeah, am I audible? Am I audible to you?
Yes, sir.
Yeah. My second question is, often the CRZs are taken care of by the social interest groups, and in that condition, the populations go very close to the seashores, and that way the disasters occur and they be mostly affected. By planting mangroves, we can definitely make a gap between this disaster and the habitations. So what is your suggestions taken care of as you have already worked in the Mumbai area? So what is your suggestions about this? How far it could be controlled? Thank you.
Yes. Sir, actually in Mumbai, taking a mangrove plantation is a little bit challenge, because if you want to, most of the community structure in the Mumbai mangrove is Abyssinia marina or officinalis, and as such, if you see, the mangrove diversity is not much in Mumbai, because as compared to the other region of Maharashtra, where there is because the creeks are unpolluted, because Mumbai Thane Creek is a little bit polluted due to the domestic sewage and nearby industrial sewage, and planting Abyssinia in this region near to mudflat make challenges, because already the tidal influence and all, that after plantation keeping them, it will be very difficult. So natural expansion is only the best if you are preserving that ecosystem, where the mudflats can be act as the expansion area for this mangrove area, are the best solution in condition of this Mumbai region. I'm telling, if you are going from southern Maharashtra like Ratnagiri, Sindhurg and all, there are higher diversity of mangrove area. So like Rhizophora micronata or that capital or this kind of mangrove are good for the restoration purposes. But Abyssinia, I don't think will work better. And that's I know, sir.
Any other question? Anybody else would like to interact with Ajay ji? Offline? नहीं तो मेरे तरफ से एक सवाल है अजय जी, एक नहीं, मतलब एज यूजुअल जो होता है उस टाइप का जो, सो टुवर्ड्स आई थिंक योर कंक्लूजन स्लाइड इट गेव अ, I don't know, should I say greeny picture or rosy picture? Rosy is English idiom and greeny happens to be more related to your topic. So in your studied opinion, how do these two things, I think sir also was hinting, I think you yourself hinted when you compared northern Maharashtra and Sindhudurg situations. So one is diversity, other one is coverage. So you are, I think 2004 to 2034, you know, there's, whether we really need to be, because you are talking about built-in, you know, development and things like that. And those things are not supposed to, I don't know, we cannot put a sudden break on those things. So in my opinion, see whether we, can you give, based on your own understanding of, you should leave the CA based, ANN based modeling, all those things I understand, they give 99% of information except the all important verdict. verdict is supposed to be naturally intellect. I mean, it is supposed to be based on NI as of now. Up to AI, we can go to, with using AI, 99% is possible. My question is, diversity versus coverage. That is one thing. And then overall, 2004 to 2034, though you have mentioned in many points, do we really need to be worried or alarmed as of now? Because 2034 is, pages yet to be turned over. 2004 is well within, I remember the tsunami. Okay, so your opinion on these things, diversity versus coverage, plus is the status of, mangrove patches in your state are in a state of, red, green, orange, where do they stand?
Sir, actually, scenario has changed in Maharashtra after the mangrove sale or mangrove foundation, because they are now becoming a nodal agency for the mangrove conservation or mangrove safeguarding mangrove areas. So now the core mangrove patches are little bit means not having that much impact of having urban development and all, because they have to go through the stricter management clearance like MCZM or clearance of mangrove foundation or mangrove sale. So converting these hardcore patches of mangrove getting it for urban, it is very difficult, because lot of NGOs or public, they will oppose, and even the stringent stringent agencies are there to regulate this one. So mostly in Ratnagiri, Sindhu, there are no such urban pressures to convert this land into. Mostly there are some aquaculture activity that may be having little bit impact. But due to Mumbai, it is a special case because there is no scope for landward expansion of the infrastructure facility. So they are moving toward the seaward side, because most of the port also, they are now trying to build towards seaward side, because in reclaiming the mud flats and all for the development. So there is a continuous pressure on these mud flats or the ecosystem, which will be in future will be getting expanding into mangroves areas. Okay, so there is a continued threat, because we are degrading or we are utilizing the mangrove related ecosystem like mud flats or spare mangroves that can be grown into full grown mangroves area in futures. So that area has been continuous threat because of this urban expansion. Core mangroves are little bit safeguarded, sir.
Okay. Thank you very much. Probably we gained more, I mean, equally as much as you presented in the interaction also. So I think, thank you very much, Ajayji. I think, let me move on to the next presentation. May I now invite my best friend, Dr. Shelton Padua, Senior Scientist, to present his views on the topic, interactive maps, an efficient tool for ensuring last mile connectivity in climate hazard awareness. So last mile connectivity, that rings many bells. All the best, Paduaji.
Good morning, all of you. I am Shelton, and I work with the CMFRA. And the title of my presentation is Interactive Maps, an efficient tool for ensuring last mile connectivity in climate hazard awareness. And these are my co-workers. The last mile connectivity, it refers to ensuring essential information and resources that reach the most vulnerable and isolated populations before, during, and after a disaster. Actually, this includes delivery of early warning, emergency supplies, and access to communication networks. And successfully addressing the last mile challenge, actually that is very much important for disaster preparedness, response, and reducing the loss of life and suffering in case of a disaster. We all know that awareness is the cornerstone of preparedness, and visual media, it can play a major role in educating different stakeholders about the threats posed by various hazards. There is a famous saying that an image tells 1,000 words, but a map tells 1,000,000. Coming to the objective is to develop an interactive multi-hazard atlas of India. This was the methodological framework used in this study. And we have selected 3 CIDs. CID means climatic impact drivers. That means the physical state of climate system that can affect either society or the ecosystem. And out of these 3 that were found to be more concerned with the coastal area, 14 elements or parameters were selected, and those 14 parameters were grouped into 5 different hazards like sea level rise, shoreline change, flood hazard, heat wave hazard, and cyclone hazard. And these 5 hazards, those were integrated into a multi-hazard index. Actually, the usefulness of this is, if you are having resource crunch, you can concentrate on the multi-hazard index information. But if you are having plenty of resources, you can address each of these hazards separately and address those areas which are more vulnerable and make them less disaster prone. And these were the softwares used for the study. And regarding the data sets, the India Meteorological Department, from them we have sourced cyclone data, flood data, and heat wave data. And for sea level rise, we have sourced the data from Copernicus. And for shoreline change, we have collected the data from Ministry of Earth Sciences, Ministry of Environment, Forest and Climate Change, and NCCR. And this, depending on the data and the parameters, we have made composite index or ratio based index, and those were ultimately made into the scaled hazard indices. This is a tabular form of the result. Here we can see that there are 6 columns. The first 5 columns represents the individual indices for the respective hazard, and the 6th column represents the index for multi-hazard. Here you can see that in case of cyclone, Odisha is highly prone. In case of flood, Kerala is highly prone, and like that, depending on the hazard, their proneness varies. And if you see the multi-hazard, the Andhra Pradesh is the state which has maximum proneness, and followed by Odisha. This is the map showing the cyclone hazard. It very clearly shows the east coast is highly vulnerable, and we know that the Bay of Bengal produces maximum cyclones, so that's why this east coast is more prone. And this is the flood hazard index. You can see that Kerala is more prone to floods. Of course, we should keep in mind that these are analyzed for all the coastal areas. And this map represents the shoreline change index. And here we can see that West Bengal, it shows the maximum shoreline change, followed by Kerala, Tamil Nadu, and Maharashtra. Then comes the heat wave hazard index, where we can see that Andhra Pradesh and Odisha is having maximum proneness to heat waves. And this is the sea level rise index map. Here we can see that Gujarat and Karnataka is facing more problems. Now, we have created the multi-hazard index map, wherein it shows that the state of Andhra Pradesh and Gujarat, then Odisha are having more proneness. So, if the planners are interested in making the coastal states disaster resilient, they should concentrate more on these areas like Andhra Pradesh, then Gujarat and Odisha. Now, those maps were converted into interactive map. The usefulness is if you have a net connectivity, and if you know the URL of this, this map, you can easily access it. And moreover, it gives more information compared to the static maps which were shown earlier. So it is very easy for anybody to access the information, either it is for planners or the layman. And here that URL is given below. If you click that, it will come, but I don't know how here it may not be possible. But if you click those highlighted areas, you can click that. Click it. Close the timer. Okay. This is the map for state level, district level multi-hazard index. This is for state level hazard index.
Excuse me, the audio is not audible. I cannot hear.
Madam, from here?
Can you hear now, madam?
Yeah, better now. Yeah.
Yeah. What I was telling is these interactive maps. It is easily accessible by all the parties. If you have the URL for this interactive map. This map is uploaded in our CMFRI website. Layman or the policymaker, anybody who is interested in this information, they can easily access. Moreover, it gives more information compared to the static maps. This is the state level multi-hazard index map. Coming to conclusion, the interactive maps, it can serve as one of the best media for imparting hazard information to different stakeholders. Thank you.
Thank you, Dr. Saab. I don't know, you have spoken more than 1 crore words now. There's many maps, because one map is supposed to express many things. Now the discussion is open, the presentation is open for discussion. In fact, this has been
congratulations, Dr. Padua, for your maps. It would be really nice if you can extend it to North India, and maybe also include, earthquake disaster. And nice to see your, these atlas and that you've developed for South India. It's mainly, Bombay and below, right? Mumbai.
Madam, can I answer? Madam. Madam, actually, our institute is Central Marine Fisheries Research Institute, and we are mostly concerned about the coastal states or the maritime states. And we have developed this map for the maritime states. That's why it is like that. It's not that we are partial to North India or Central India.
No. I would be happy, I congratulate you for your work. I would be happy that you could also include maybe your team next time can include North India also.
Okay, madam, we shall try.
Thank you, thank you.
An additional information, madam, I think to all the audience that Padua and Madam Reshma's, this technology has been certified by Indian Council of Agricultural Research. So it has been a sort of what you can say, one of the major achievements of the institute in the last year. So this has
congratulations,
been and
okay,
basically,
thank you.
Basically, it was part of the assignment of NICRA target, and of course, coastal districts rather. I was about to ask that question, but Madam has already, my question has been already, exposed, or it's a leaked one. So one half, I think Dr. Padua, you were showing districts, and the other half, you were going for states. So what was the judging thing? Which disaster is state specific? Which disaster is district specific?
Sir, actually, if you have a lot of money, you take the district-wise map. You consider it. If you have less money, you consider the state maps.
So you are ambivalent. I mean, depends upon your pocket.
Yes,
because
sir.
You showed both the things. I was just commenting on the presentation. Otherwise, it was a brilliant one. Any other questions, sir? You had switched on, I thought probably no. Offline? Online also, maybe? Any further questions on this? Because this has been a very much discussed aspect, and but the problem is that it's a very useful tool. Actually, going by the theme probably is one of the major contributions which probably should be coming out in the proceedings. But when this was presented before experts, like who were what you can say reviewing this project, NICRA, climate resilient agriculture. So at times, that I think Krishna district of Andhra Pradesh happened to be the most, vulnerable kind of thing. So the chairperson was from Andhra, Dr. Venkateswarlu, and his immediate whip was, everybody knows Krishna is prone to all these disasters. So the problem is that when it's presented in that way, so when things are becoming so too simple to, for people to follow, then we need to have, because the type of work which they have done, the team has done, to arrive, because as Madam raised, why don't you cover North India? But at times it stays the obvious. I think in Kerala it is Alapi or Kannur. So in Kerala, which district? I think Alapi or Kannur? Highest in the multi-hazard in district.
That is Alapi, sir.
Alapi, because it is well below the sea line. But there are many things which are quite obvious, but this is one of the, I think, most scientifically oriented, probably it has got a publication, it has got a patent or this thing now. Patent means this certified technology. So naturally, it's meant to, it is supposed to go places now. So thank you very much, sir, for enlightening. Yeah, please.
Actually, when the planners are taking the decision on implementing disaster preparedness, actually this district level map will play a major role. Of course, Sri Ramalu sir may be knowing that, Venkateswarlu sir may be knowing that, but some other IAS people will come and see, they may not be knowing. So that's it.
Thank you. Big hands for him. Thank you, Sheltonji. Yeah, wonderful, as our seniors mentioning. May I now that's for you to take a call, answer. So the next contributor is going to present online, Madam Krishna Sukumaran. Her topic is influence of transgenerational acclimation on thermal tolerance in marine medaka. Madam, please, floor is yours.
Okay.
7 plus 3. 7 plus 3. Yeah, you are audible, please.
Okay, sir. Is it okay now, sir?
Kindly go for the, yeah, now it's okay. Yeah.
Okay, sir. A very good afternoon. I would be speaking on the influence of transgenerational acclimation on thermal tolerance in marine medaka, rises Tanzania. Now, as we have been discussing, global warming is a major threat to the biodiversity and ecosystem functions. And temperature, as we all know, is a major abiotic factor which influences the physiochemical and biological functions. Now, every species we know performs or survives around a finite temperature range, which decides its abundance and distribution. This happens in nature, but in captive conditions, the organism has to rely on its physiological tolerance to cope up with the thermal stresses. Now, fish, because it cannot regulate its temperature, is particularly susceptible to climate change. Therefore, it is an urgent need for us to scientifically predict its thermal response. Now, when we went to understand the effect of climate change or the climate change effects on a teleost fish, we have used a model organism, a model fish, that is a Rhizus dansana, because it has a very short generational time and it's also urihyrine in nature and it has a small size. So it is very easy to monitor a transgeneration effect. So whenever we go for assessing the climate vulnerability of a species, we have to understand its thermal tolerance. Now, this thermal tolerance in turn can be influenced by abiotic factors like thermal acclimation, which is a response of the species within its lifetime, or it may be due to genetic factors, which involves heredity. Here, we are dealing with the acclimation aspects, that is, the responses within the lifetime of the organisms, or the plastic responses. Now, we have two objectives for this work. The first was to estimate the climate critical thermal maximum or the critical temperature tolerance of the species, because the data was not available for this particular species. And then we went to understand whether a short-term acclimation, that is for around 30 days, or a long-term acclimation from embryo stage, or a transgenerational acclimation of F1 to different temperatures has an influence of Ctmax. Essentially, we try to understand whether the species or a fish, how they will adapt to the future climate scenarios when they are exposed to warming on a longer term. Now, this is how we had, we had 3 treatments. In the first treatment, that is a short-term acclimation, that is a standard procedure. In this, we have exposed the fish to 4 different temperatures for 30 days. And after that, we have conducted the thermal tolerance study. And then the second treatment, that is a long-term acclimation. Here, we have taken newly fertilized embryos. They were acclimated to the 4 temperatures, and the adults were raised in the same temperatures. So that is, the animals which we have used were raised from embryo stage at 4 different temperatures. And the third treatment is it's transgeneration acclimation. So here, from the embryos that were raised at these 4 temperatures, we produced adults, and they reproduced into F1. And then we tested the thermal tolerance. That is, we wanted to see how at each of these stages the animal is adapting, because even what they say is early life stages have a profound influence on the whole lifespan of the further life stages of the organism. Similarly, parental influences also have a profound influence on different parameters of the offspring. So this was the setup we have used. So we have 4 thermostatic setups, which involve chillers, heaters, and thermostatic systems. And 4 temperatures were maintained: 24, 27, 30, and 33. And we have studied the Ctmax, the acclimation response ratio, the thermal safety margins, and the plasticity of this critical thermal tolerance. So this is the results of the first objective, that because data was not available, this was the study telling that the critical temperature maximum of a rhizoid dansana was around 40 to 42 degrees C. So beyond this, the organism loses the capacity to escape, loses its equilibrium and the capacity to escape from a high temperature environment. Considering the maximum SST along the west coast, which is around 32.1, we feel the thermal safety margin was estimated to be around 8.5 to 10.5 degrees for this species. And again, we also, similar to the previous studies, this study also reinforces the fact that if we acclimate an organism to higher temperatures, it enhances the thermal tolerance of the species. Coming to the next objective, so the first part of the graph, it's already been discussed. So that is a short-term acclimation, and this helped us to arrive at the Ctmax. If you see the second part of the graph, when we went for the long-term acclimation, the Ctmax has increased around 43 degrees. That is, when the animal were exposed to higher temperatures of 30 and 33, the Ctmax has increased to around 43 degrees. This is the long-term acclimation. And in transgeneration, there was a further rise to around 44.38. So we feel that there's a progressive increase in Ctmax. Now, the plasticity of this Ctmax, that therefore ranges from around 1.9 to 3.1 degrees C. Now, what was interesting for us was that if you see, if you compare the data of short-term and long-term, we found some sort of expected results. Because if you see 24 degrees and 27 degrees, the bar graphs, if you see the blue bars, we feel that there was no much variation when the acclimation was at 24 degrees. So thermal tolerance almost remained the same in short term and long term. That is, it was around 40 and 41. And when we increased the temperature, it was it increased from 42 to 43. But there was some unexplained data. If you see the transgeneration acclimation, if you see the blue graphs, even at 24 and 27 degrees, there was a slight rise in Ctmax. So this is something we have to understand further. right now we can only assume that maybe we have giving a very optimal nutritional diet during in captivity. This may have improved the quality of offspring. Maybe that may be accounting for the increasing city max even at lower temperatures. So essentially, this is what was confusing for us. So what I have done is we have discounted for this increase in city max at lower temperatures, and we can see the plasticity of city max due to long-term and transgender emission will be around 1.1 degrees C. So this is a graph just showing the acclimation capacity or the acclimation response ratio, which reaches from around 0.21 to 0.34. And from this study, we understand that when we expose the species to a long-term acclimation or a transgender acclimation, the maximum tolerance limit was possible to raise it to around 44 degrees from where we began is around 41 or 42 degrees. So up to 44 we could have gone with this. So this shows how the species are adapted. So basically in the study we were able to arrive at the CD mass of the species. The study also helped to demonstrate the extent of phenotypic plasticity of Rhizostomi dancina through short-term, long-term and transgenerational acclimation to higher temperatures. And also we found what is highest CT max we could have obtained when we exposed to this projected climate change scenarios of 33 degrees. Hence we got around 44.38. Basically, it was a study demonstrating the adaptive capacity of Rhizostomi dancina and also gives us some idea how fish may respond during long-term exposure to global warming. So that was this work about, sir. So that's all, sir.
Thank you very much, madam. You made that, should I say, transition? Yeah, big hands to her. From Shelton's macro picture to semi-micro lab level. So it's a sort of a pleasant shift. Now the paper is open for discussion.
Well, Doctor, I have a simple question. How exactly the marine medakas expose the marine or lagoon ecosystems change? Do they at all do it?
So actually, if we why we have taken medakas was right now it's not possible for us to directly take up a food fish or ornamental fish because most of the species they mature in 1 year or 2 years or maybe 4 years. So, but when we go for medaka, we have a very short generational time. Like it reproduces within 60 days. It is possible to see a transgenerational change. So this gives us an indication that the species can adapt, but at least not adapt exactly. There's a plasticity in thermal tolerance. This is what it shows us. So it is also maybe reflecting in the lagoons also we can say, because Rhizostomi is a species which is also present in the brackish water systems. So definitely it also reflects the adaptive capacity of the species in the estuarine areas.
Thank you very much.
Thank you, sir.
I think Dr. Divu, I think only in your presentation I saw CT max for the first time. I think you have done some similar studies over there. Okay. So, madam, I have a layman question. Should I? Or can I?
Yes, sir.
Thing is that, one very big, I think, Pitamaha in our field, marine fisheries, he quipped once when such things were being discussed. Now you say that the transgenerational advantage translates to around 44 point some degrees Celsius for this species. So, are we, this is, I'm just paraphrasing him. I'm not exactly able to reproduce what he told because it happened 2-3 years back. So what do we really mean by, because that study was, talking about even 50 degrees and all those things.
Yes,
if resilience, if it is going to be, are we saying something which is bordering more like adapted characters than resilience? Because resilience should have its upper limit, adaptation.
Yes, sir.
But this becomes sort of a, like your transgenerational, it becomes a transconceivable or metaphysical concept. So any ideas on that? Yeah.
Yes, sir. Actually, when we went for the Rhizostomi species, we have not just done CT mass of the species. We have started with embryology, how it affects the development. We went for growth. We have also recorded its reproduction, what is the impact of reproduction. And this is the final aspect of the work is CT max. Now, CT max actually doesn't reflect whether there is no other problem. Like it's not that it doesn't reflect growth, doesn't affect reproduction. It reflects that a level at which the organism loses its equilibrium and it cannot escape that place, that space, and that is why it will succumb. That is finally almost very closing to the lethal limit. It is a lethal limit. It is not the optimal limit. Actually, there was one interesting study when I was coming across is rises. So if we, one of my concerns, maybe which we will be addressing in future, is that if it is exposed to higher temperatures of over 33 degrees at an embryonic stage, there's a big chance that we will have woolly males. So these are things, it's not that everything is okay at high temperatures, but this is a temperature at which the fish will not escape. So this is what I want to say, sir. So this is the higher limit, but we are also studying all the other aspects. So what all problems we can anticipate.
Great, thank you, madam. It was asked by a Pitama. That's what, it's not my
so
question.
Actually, we need to cover all the aspects now, sir. So we have covered. We have making a attempt for that.
Thank you. Any other questions?
So much,
thank you. Wait. Any other questions on that offline? Yeah, if not, then thank you very much for your brilliant presentation, madam. Thank you very much.
Thank you so much, sir. Thank you.
So, thanks, madam. Then I think one addition is there. Is Dr. Johnson available?
Sir, good afternoon, sir. I'm audible?
Yes. Sir, one நிமிஷம் சார் நான் சொல்லிடுறேன் நீங்க எதை பத்தி பேச போறீங்கன்னு சொல்றேன் நான்.
Okay, sir.
Okay. So I think Dr. Johnson from our CMFRI's Mandapam Rameshwaram Center. Yes, he's a very what you can say fortunate person to be there at the Lord's feet. He is going to appraise us on seaweed farming, which is a very popular trust area. Our PM often mentions it, especially when he's on tour to foreign countries. So seaweed farming, advancing environmental sustainability and socio-economic prosperity, all positive words of our scheduled caste fishers. NICRA, that is the project's name, initiative. Now Dr. Johnson, floor is yours, please. 7+3.
Sir, slides visible, sir?
Yes, sir, please go ahead.
Most respected chairman, co-chairman, my dear senior colleagues, very good afternoon to all. At outset, I thank the organizer for giving me this opportunity. Sir, this work is basically, I will be narrating what we carried out under National Innovation on Climate Resilient Agriculture project, which is being carried out for past 10 years in ICR CMFRI, and that too in this one component is Scheduled Caste Subplan program. So whatever the work carried out in last 5 years, I will be narrating through this presentation. So coming to seaweeds, seaweeds have lot of ecological and commercial significance. It is a multicellular macroscopic marine algae, marine macroalgae. So it is being commercially exploited or used for the phycocolloids, that is agar, algin, carrageenan. And past 1 decade, the focus is also being given to manure, that is biofertilizer, food and fodder supplement and bioactive metabolites. The global production is 36.4 million tons. So though our share is 0.2% to the global share, that is 72,000 tons, but still we have a lot of potential to reach the top 10 countries in the global level. That is why the focus is being given last 4 years very specifically under Pradhan Mantri Matsya Sampada Yojana. The right hand side, the 6 seaweeds is being used now by most of the industry. The first row for agar, the second row, that is brown algae, Sargassum terribnia for alginate, and the last one, the Capaphagous cerveraceae, is being farmed mostly in mainland, and in Lakshadweep and Andaman, the Gracillary edilis is being advocated. So just a brief introduction to the entire house of the audience. The techniques also, there are 3 major techniques is being adopted in our country. The first 2 one, raft method and monoline method, is being adopted at Tamil Nadu coast, and the tube net method, which can be ideal for the rough sea condition, is being adopted at Gujarat and other wherever the similar situation, this is being adopted. We also worked out the specific rate of CO2 sequestration per hectare. It works out to 760 kg CO2 per day per ton of dry weight. So coming to the actual program, sir, last 5 years we could benefit directly 31 fishermen families. That is, we could provide 600 rafts or monoline units. This is from 19 to 24. So here the basic, first we will approach the village and we create awareness, and then initially they will be reluctant, and somehow we will apprise them what we are planning to do, and in that all will not convince, very few will be convinced, and then we will identify the location. That is the biggest challenge in this entire exercise, because sea is a common property. So earmarking the area for seaweed farming is the biggest challenge. So we have to involve the local panchayat, fishermen cooperative society, then fisheries department, and in some cases even religious institution in certain village. So in their concerns only it will be earmarked, and that will be exclusively used for the seaweed farming. So we even formally get a consent from the panchayat level. So we could benefit 31 families. In 24-25, these 31 families in 615 units, they could produce 35.5 tons of dry weight. That is 10% of the fresh weight, means in fresh weight it is 355 tons. So coming to the revenue, if you see last 24-25, they could earn around 34 lakhs per year. Almost each family, if you see, they earn around 10,000 to 15,000 per month. And the CO2 sequestration based on the 19 kg per day per ton of dry weight, what we have worked, we have extrapolated with this, we multiplied with the 35.5 tons, and we could you can see that 674.5 kg CO2 per day, the sequestration potential is could be achieved through this 31 families and the 615 units. So this impact, though it is too early, because it is some 2 to 5 years of adoption from the beginning, now in 2025. So, but this is a preliminary impact or preliminary research. The first 3 factors you see how much significant impact. The income, 60% increase in their income, because earlier there was only one source of income through fishing. When additionally through seaweed farming, they could get 12,600 rupees. And saving also, the saving behavior has increased by 95%. That has really impacted in reduction of indebtedness and repayment of the loans. Similarly, home and material changes also, there are some visible impact. You can see some 20 to 40% in case of like household appliance purchase, vehicle purchase, and renovation and modification of the existing house. In case of welfare, the second point I want to stress, sir, actually 61% they could provide a better education through the income which they achieved by the seaweed farming is one of the significant thing which we observed in the field itself. They could give a quality education, like higher education in well-reputed institute, because earlier the money was a constraint. Now they could spend as a fees for the children, and they can even make them to travel up to Ramanathapuram from their village. So such an impact has been created through this farming. And one success story, she is Srimati Jyoti Priya, a very young farmer, and when she gave an interview to Doordarshan during 2024, it was a very good experience actually, how a farmer can change to this level, because earlier they were all reluctant, but when we initiated with 20 units in 2020-21, she herself could expand double the thing, and at present she is earning 18,000. And the interview she has narrated that without the support of his husband, because earlier they were relying on their husband's income. Now without relying on him, now they could meet the family expenditure or repaying the loan or children's education. So it is like a vivid example for financial management and decision making ability of the fisher women. So the major constraint which almost 31 fisherwomen, they expressed is one is disease, when there is an increase in temperature above 30 degrees centigrade sea surface temperature, or decline in the salinity below 25 ppt. And the second major issue is the grazing, especially rabbit fish, theropon, in certain period of months. And third is a minor issue, epiphytism, one seaweed growing other seaweed. For first two, we made an intervention. We provided a salinometer and a pH meter and thermometer. We trained them. They are recording periodically, and it is somehow, I can't say that is the only solution, but it somehow it can, they can know what is the situation. And the second thing, for grazing, we couldn't give for the entire 31 families. In that few families, we could provide this pen-like structure wherein we introduced the sea bass. The sea bass will take care of the grazers, and somehow it is like a biological management approach that is working well. And of course, the third one is periodical monitoring and cleaning. To conclude, this is one of the evidence that it is an inclusive livelihood development for socio-economically marginalized group, and such initiative will be key for sustainable and thriving seaweed farming industry in India. So these are the things, are the interesting part. They are continuing the adoption 5 years. Maybe in the 10th year, we have to evaluate once again, still in the same tempo, or whether they drop, and what are the issues. So with this, I thank sir once again for this wonderful opportunity. Thank you, Vanaka.
Thank you. Thank you, Dr. Johnson. It was a comprehensive presentation. Now it's open for discussion.
I have two questions. Dr. Johnson, thank you very much for the paper. I'd like to know, since our research is specific to Minikoy, so I'd like to know this, whether seafood, the seaweed can be an alternative seafood. See, any data do you have about how much seaweed is cultivated in the in the UTL, I mean Minikoy especially? Second question is, can seaweed be in the food option to the island coastal economy, which generally is dependent upon the mainland supplies?
Regarding Lakshadweep Island, sir, we have identified 11 potential sites working out to 200 plus hectares. But initially we were thinking that whether Cryptophagus, what is being grown in the mainland, can be cultivated there. But since it is an exotic species, they have not allowed that, and only Gracilaria edilis is being cultivated, wherein our KVK did the demonstration during 20 and 1920s. They have done a demonstration, and we could find 20 times growth we could observe there. And there are industries also very much ready, like Turtle, Purple, TSC. They have a collaboration with the Netherlands. They already procured the material. And according to me, since it is 20 times growth, the economics will work there. And moreover, if the industry is also in the near future, if it is coming, because it is a seaweed cluster. Department of Fishery, Government of India has declared Lakshadweep as a seaweed cluster for our country. So definitely many infrastructure will be coming in the coming years, and species like Gracilaria edilis and one more Gracilaria dura is the candidate species there, and which can create a significant impact, sir. One. And second one, for edible, we advocate only green seaweed, mostly Ulva lactuca, we are working on it. So such a kind of green algae can be promoted in near future, which can meet the need of as a human consumption, which can be promoted in the coming days.
It is 25% or 25, what would you say? 25%.
Which one, sir?
25, pardon me?
20 times of growth, sir. When you put some 10 kg of material, you will get 200 kg in 45 days.
Okay.
So that 20 times growth we couldn't find, we couldn't record in the mainland.
Correct.
Lakshadweep, such a wonderful growth record is there. So that is why our native seaweed species has a prospects in Lakshadweep Island.
Okay, thank you very much.
Thank you, Johnson ji. I think Dr. Johnson, I don't know, sir, for those who are not attached to CMFRI, he may sound more like a mariculturist or a biologist. Basically, he's a social scientist. He's an extension man. Yes. Maybe I think he has exposed himself by talking about economics. Otherwise, team. Yeah, that's what, this is one thing I think if we can call it as like a kalpvriksh type of thing, equivalent in English, that is seaweed. It should not be called as weed. I think some move is there. It should be called as something else. Yeah, that is one thing. And yeah, wave breaking capacity. Yeah, that's what, it's a win-win kind of situation. Yeah. I think you switch on the mic if you don't mind. If you don't mind. नहीं नहीं वो सूत्रधारी को ये जानकारी पहुंचना चाहिए ना सर.
What I wanted to propose is that it is a very good paper which gives enlighten us about the utility of seaweed in the social behavior.
We invite Dr. Johnson to be as part of our workshop, which we are going to see.
He will join online.
He will join online.
We can put a questionnaire to him.
Yes.
He could feed that questionnaire. That would be that would go into our research.
Correct.
And it is as he has rightly pointed out that UTL has been declared by the government of India as a seaweed seaweed cluster.
Seaweed cluster.
So that way
so Dr. Johnson,
he prospers to be one of the very good ideators on this matter.
Yes.
So we would like to invite you online, of course, because we do have got fun problems.
And Dr. Johnson, I would reach out to you regarding the economic viability of this, and then incorporating it as a social cost benefit analysis, where I will exactly exhibit the benefits and economic benefits part of it for
in the workshop,
right?
in the workshop in Minikoy.
But empirically, I would reach out to me also.
Thank you. I think the last point. Yeah, please, Dr. Johnson, please.
Oh, okay, sir. Okay, sir. I have listened to them and will be part of it with the approval of my guide, Dr. J. Jaishankar sir.
Of course, you will be giving the
director.
Of course, you will be giving the credit for whatever you contribute to the research.
Yes, sir. Yes, sir.
I think the icing on his cake, whatever I would call it as his team's cake, is that recently ICR, our council, has recognized this that Mandapam Center as a center of excellence for seaweed research.
Oh, wonderful.
So that has been, I think, last fiscal, our Honorable Minister of State inaugurated it formally.
Oh, very good.
So like Mandapam is doing a huge job and he is spearheading it. So hopefully it's going to be win-win for all, research side as well as society side.
So I also saw the documentary, I think prepared by ICR, and that was about the weed, the stages of weed, and that was selected in the UGC also, that documentary.
Pleasure hearing that, madam. Thank you very much. We are running short of time. So any other question? Maybe one question max, offline, online? I don't know, he is unquestionable, but otherwise. Okay, in that case, maybe, may I draw? Thank you very much, Dr. Johnson bhai. It has been, as usual, supernormal, contribution. I don't know, we are running short of superlatives. So this session has been quite unique and productive. I don't know, I did not have the fortune of being present in other sessions. So thanks to madam for this opportunity, but I feel that it's like a Panchatantram, Pandav, whatever you call it. There are 5 delicacies served. One about citizen science, one about mapping, other one is about modeling, green cover tools, and third one on Dancina. So we had dance, we had cover, we had model, all those things. They gel in different world also. So thank you very much for this opportunity. I would like to thank my, I don't know, madam, you do not feel bad that you did not have a chance to interact, but yeah, your presence also added grace to the occasion. And my 2, I think, brilliant colleagues, I think इनसे मैं पहली बार मिल रहा हूँ, आशीष भाई, आशीष खंडेलवाल जी, कोटा से हैं, जो भी बड़ाई जो है, ये दूसरा कोटा नहीं, ये KOTA है, जो है कोटा सिक्का छोड़ करके जो भी काफ़ी कई चीज़ों से अब आजकल पेपर में नाम आता है कोटा का, हमारे ऑनरेबल स्पीकर का कंस्टिट्यूंसी. So I am meeting him for the first time, and brilliant work. And Gina madam, as usual, is all perfection personified. So thank you very much, and I hope all the participants enjoyed. A special thanks to those who have contributed to the session, and I think with this I call it curtains for this session. I think another enticing session is in the offing. Thank you very much.
Thank you.
Thank you, Jayashankar sir, Somi, and Ashish and Jeena. Thank you very much. I think now we will break for lunch. Is it? Then what is on the agenda now? One more session. Okay. Oh. Okay. Then over to you, Ramya. You can announce for the next session.
Good afternoon, everyone. Let us move to the last session, that is theme 6, infrastructure, disaster resilience and community preparedness. Chair is Dr. Ramachandran C., Principal Scientist, Fisheries Resources Assessment, Economics and Extension Division, CMFRA, and co-chair Dr. Imelda Joseph, Principal Scientist of Mariculture Division, CMFRA. And we have two rapporteurs, Dr. Sumitra T.G., Senior Scientist, and Dr. Sanal Ebenezer, Scientist of Marine Biotechnology, Fish Nutrition and Health Division, CMFRA. Madam, over to you.
Good afternoon, everybody. So the theme 6 is infrastructure, disaster resilience, and community preparedness. And there are 6 presentations in this, and except one, all are online. So I request the first person, Aditi Alabat et al., to present her paper on interlinkages between climatic and socio-economic vulnerabilities, a case study of Kerala. Aditi?
Good afternoon, everyone. Am I audible? Can you please confirm?
Yes, you are audible. Continue.
Yeah, thank you. Good afternoon, everyone. This is Aditi Alawat, and I'll be presenting on a short case study of Kerala, which is to show the interlinkages between climatic and socio-economic vulnerabilities. So as we all know that Kerala has one of the most diverse geographies in our country, and it also faces unique challenges in terms of climate change and also in terms of the increasing socio-economic development. And this increasing climate variability, increasing shifts in the rainfall and temperature patterns, it has huge implications for the land use, livelihoods, and the ecosystem services of the state. If we understand how these climatic shifts impacts the human vulnerability, then we would be able to build resilient communities. So for this study, I have taken 2 districts in the state of Kerala, which is one is Wayanad and another one is Thiruvananthapuram. The objectives of my study are to map the land use land cover changes in both the districts over 5-year intervals starting from 2000 till 2025. And then to analyze the spatial and temporal dynamics of these changes in relation to climatic and socio-economic vulnerabilities. Now, to study this, I have taken some remote sensing data sets to map land use land cover changes. I have taken Landsat 7, 8 and 9 data set, which is at 30-meter resolution. To study climate changes, I took temperature and precipitation data. Temperature has been taken on the mean as a mean scale, and precipitation as total, which has been taken from ERA 5 land monthly averages, which is at 9 kilometer, approximately 9 kilometer resolution. To study the socio-economic variables, I have taken population density and also the literacy rate and workforce participation, which is in percent. It has been taken from Census of India at the decadal scale. I'll talk in very brief about the methodology. Majority of the mapping has been done in Google Earth Engine, and the maps have been prepared in Google Earth Engine, and eventually the statistical data which was taken from the Census of India, it was correlated with the changes happening on the land, which is the LULCC, land use land cover change. So starting with the Thiruvananthapuram, we saw that there has been a decline, a sharp decline in the forest area in the district of Thiruvananthapuram. Starting from 2000, the forest area has significantly decreased from 2000 to 2025, indicating the ongoing deforestation or maybe land conversion likely due to urban expansion and land development pressures, which will eventually be correlated with the increasing population data towards the end of the presentation. We also got to know that the water body area has been fluctuating, and it shows high variability in 2010, and then the water body area dropped to 142 hectares in 2022, which suggests some seasonal changes or maybe some water management issues or maybe changes in rainfall patterns. However, when I studied the temperature and rainfall in Thiruvananthapuram, there were not much changes in the temperature, minor changes in the rainfall over the span of last 25 years. We also got to see the significant increase in agricultural land. It had a sharp increase, particularly from 55 hectares in 2000 to 317 hectares in 2015, suggesting land reclamation or maybe conversion of forest land into some plantation area. Now coming to the district of Wayanad, Wayanad also showed a sharp decline in forest cover from 2000 to 2025, indicating maybe extensive deforestation or maybe due to expanding agriculture or settlement. And yeah, agricultural land in itself was seen to be increasing, particularly from 2000 to 2025. Again, Wayanad also, in terms of climate, temperature did not show any sharp change, or similarly in the case of precipitation also. Precipitation, however, did show some small decline. But yes, we can say that climate change was not having a huge impact on the land use land cover changes in both the districts. Here are some of the graphs comparing both the districts. And if I compare both the districts, then Wayanad experienced more severe decline in the forest conversion in comparison to Thiruvananthapuram. Thiruvananthapuram agriculture, however, increased, and its built up area has also been increased over the past 25 years. Now coming to socio-economic aspects, there has been a high population density in Thiruvananthapuram, and this urban pressure has been contributing to the forest and agricultural land conversion into built up areas, particularly until 2020. And limited land availability may also explain fluctuations in water bodies and modest agricultural expansion. Wayanad, on the other hand, has much lower population density, though it tripled over 30 years. This, however, may suggest and support the extensive land conversion. Coming to the literacy rate has been rising in both the districts. And this literacy rate might be linked with the more urban planning measures, increasing demand for housing, possibly influencing built-up expansion. Also, with the workforce participation rate, Wayanad workforce participation rate has been declined and then stabilized around 2011, indicating a possible shift from traditional to informal and seasonal employment. So this might be correlated with land use pressure for subsistence farming and migration linked land abandonment or reconversion. Concluding the study, I would say that there has been, if we look at the climatic conditions, the climatic data, there has been a relatively stable climatic conditions over both the districts. The observed land use LULC changes appear to be primarily driven by socio-economic factors and not by the climatic conditions. Those socio-economic factors are the population growth, urban expansion, agricultural intensification, and changing workforce dynamics. In the end, I would say that this study highlights the need for integrated land management policies that consider both ecological sustainability and local livelihood needs. Thank you.
Thank you. The paper is open for discussion. No discussion? Then we'll move on to the next one.
Hello, can you please speak a little bit higher? You're not audible.
There is no discussion. It seems to be no discussion.
Okay.
We will move on to the next paper. Thank you, Aditi.
Thank you.
So the second and the third papers will be presented by Rachel Batre. We will have the discussion after both the presentations. First one is mapping ecological vulnerabilities to resilience, a conundrum to political economy. Dr. Rachel, please. Online. So then we will move on to the fourth presentation, a multi-decadal review of frequency and human impact of extreme weather events in Kerala 1983 to 2023 by Wasim Pesi. So
hello. Okay, very good afternoon all of you. My name is Wasim PC, a research scholar in ICRC MFRI. Today I will be presenting on the topic, a multi-decadal review of frequency.
Volume please, can't hear you. Hello.
Okay, a multi-decadal review of frequency and human impacts of extreme weather events in Kerala for the time span of 1981 to 2023. Let me give you about what is extreme weather events and its relevance. Extreme weather events are unusual, severe, unseasonal weather patterns that is significantly deviate and unlike slow onset events, slow events such as ocean acidification, sea level rise, these events grab more attention due to its immediate and devastating impacts, and these events impose enormous pressure on infrastructure, economics, and communities. And a major type of extreme weather events are flood, drought, tropical cyclones, heat waves, cold waves, and coastal storms and storm-generated surge. Coming to Kerala context, Kerala is a maritime state in peninsular India which is predominantly influenced by monsoon. The state is most vulnerable to multiple hazards including floods, landslides, heat waves, droughts, lightning, and strong winds. Analysis from 2006 to 2020 shows Kerala along with Karnataka exhibiting highest climate change signals. In this background, my study has been conducted in Kerala based on three prominent events that are flood and heavy rains, and cyclones and heat waves for the time period of 1981 to 2023 with the objective of to analyze the long-term trend in occurrence and mortalities of extreme weather events in Kerala and to identify the most lethal type of extreme weather event during the study period by death to event ratio, and to detect the regime shift in frequency of extreme weather events, also to assess the decadal variation in both frequency and mortality rates. Here are some visuals which are showing the impact of extreme weather events in Kerala during the study period. Coming to data and methodology, the data is sourced from disastrous weather report which is published by IMD, and data from 1981 to 2023 for Kerala was used. Coming to the methodology, year-wise trend of number of events and mortalities were analyzed. A death to event ratio was calculated to identify the most lethal extreme weather event, and a cumulative sum test was conducted to detect the regime shift and flag the time points, and comparative state analysis of mortality were also carried out. Coming to the results, a total of 601 extreme weather events and 5837 deaths were reported in Kerala. Of this, 95% of events and 97% of deaths were attributed by flood and heavy rains. Despite the lower occurrence of cyclones, events were more lethal than heat waves. Coming to time series data of this occurrence, we can see that flood and heavy rains are consistently dominating over the years, and we can see a sharp peak in 2018 in the case of mortality. In 2018, Kerala experienced its worst flooding result in the 9 to 8 reported deaths. Cyclones remains relatively infrequent with scattered occurrence in some years, but often result in deadly. Notably, Cyclone Oki in 2017 and 92 cyclone were among the deadliest. Heat waves have emerged only in recent years, peaking its frequency in 2019. While annual deaths remain relatively low, their presence has been consistently in recent years. And check the correlation coefficient of event per year, mortality per event, and mortality rates. And correlation coefficient is used to detect the direction and the change, and also check the statistical significance. Flood and heavy rains show a strong and significant increase over time, while mortality per event and mortality rate exhibit slight, non-significant upward trend. The similar case in heat waves, statistically significant rise in frequency over time, highlighting them as a recent and growing threat. Mortality per event also show a statistical upward trend. Coming in the case of cyclones, cyclones are relatively infrequent with weak, non-significant trend in event frequency, mortality per as well as in the mortality rate. And now coming to death to event ratio, cyclones are the deadliest, although cyclones occur infrequently. Each incident leads to high casualties. Owing to high frequency of flood and heavy rains, have a lower death to event ratio compared to cyclones, but their cumulative impact result in a substantial loss of life. This ratio highlights event severity rather than the total frequency. Coming to Kusum test, that is cumulative sum, is a statistical method used to detect the regime shift in mean and to flag the specific time points in which the deviation has occurred. And I applied this test in the case of occurrence of flood and heavy rains, and the line crosses the control threshold around 2015, which shows that the deviation is statistically significant. Coming into a comparative study of annual number of events and mortality rates were carried out for the 3 events, flood and heavy rains. You can see the number of events were tripled in the most recent decade, along with the significant increase in mortality rate. And in the case of heat waves, there was no reported events in the first 2 decades, and we can see in the recent decade there is a significant increase in the number of events and as well as the mortality rate associated with the heat waves. As I mentioned, in the case of cyclones, cyclones are relatively infrequent, and we can see a slight increase in the most recent decade in the number of events and also in the mortality rates. Coming to a comparison between 2-year time periods, which is used to detect the percentage change. Flood and heavy rains events nearly doubled, and the change is statistically significant. And in the case of mortality rate, there's a 57% of increase in the mortality rate also, even though that is not statistically significant. And cyclones occurrence have risen by 50% in the most recent time period, yet overall number remains low. Coming to the conclusion, the study has revealed that Kerala has been experiencing multi-hazard climate stress. The post-2015 period shows a climate stress escalation. Flood and heavy rains consistently dominate in the frequency and its associated mortality over the years. Cumulative sum test confirms a statistically significant regime shift in the occurrence pattern of flood and heavy rains. Heat-related stress is rising, highlighting the need of stronger disaster management plans, including heat health monitoring system, standard treatment facilities, cool roofs, and increased digging cover. Cyclone remains relatively infrequent in Kerala. However, each occurrence tends to result in high casualties, highlighting the need of strengthen existing adaptive and mitigation measures. These rising frequency and mortality linked to these events emphasize the urgent need of climate resilient infrastructure, improved early warning system, and targeted disaster risk reduction strategies in Kerala. Thank you. Thank you for the attention.
Thank you. The paper is open for discussion. If nobody is asking, I will ask you one question. So you are taking secondary data, no?
Yeah.
So
Data is sourced from
as a student, maybe you are a PhD scholar, no?
No, YP.
YP. What is your role in this? Because any other agency is not taking the data or doing this type of study?
There are some studies that are also going on with this. I took the data from IMD, and I just analyzed the whether number of events, any trend in that, and also analyze the mortality rate, mortality trend.
Mortality in terms of human mortality.
Yeah, yeah, only a human.
So that's why I asked whether our some government agencies will be doing this study, no? So what way it is novel or new for you or for us, for the institute?
The impact of climate change. The mortality is also increasing.
Yeah, okay. No, I'm not satisfied with the answer, but maybe. Yeah.
I'm not aware about whether any other government agency is taking part of this.
Yeah, maybe further when you are studying, you can go for such references, okay. And what more we can contribute, that part you can take care. Okay. Otherwise, it looks like just you are taking a data and analysis being done. So what way it will be useful for our institute or for the people in Kerala, or what way, something new, it should come out from the study. So that's it. Okay.
Well, since it is a secondary data, could you please tell us what kind of disaster management has been taken in the past in Kerala offshores, these areas, when cyclone had affected the life and property? What kind of disasters management had been done, and what was being done today? What is the difference? Is it improving or decreasing? Like, what does your secondary data tell?
Actually, early warning systems are in the case of cyclones, early warning systems are giving, and also disaster resilient infrastructures are needed to be done.
Oh, not exactly. The modalities, what kind of action the government or people or people's body, whoever, had taken in the recent past when any disaster occurred on the Kerala shores. Okay. And what was being done today? What's the difference? Is there improvement or decreasing?
The trend, mortality rate trend. Well, is there any adaptive measures that's taken? You are asking about that.
I'm asking about that.
No idea, sir.
Okay.
Actually, the government is taking some preparedness based on the predictions, When we are given a weather warning, the government will immediately take action, ask people to move away from that place, or some camps will be open, and so like that, because mortality is comparatively less.
That's the usual practice normally being done. I just wanted to find out whether any original people-oriented work has been done or not, because responses government does, government is government's duty, government will do. It is a open secret for everybody, and is the fact for every country. My point is how much people are aware about their responsibilities to to cooperate with the government's efforts. That is the factor. If people-oriented move doesn't happen, then it becomes a very mechanical affair. Then you are only criticizing the government doing nothing yourself. That kind of picture appears. There should be a reciprocation from the people's side also in support of the government actions. So I want to know whether it is being done here or not. Anyway, I got the answer. Thank you.
Yeah. Yes.
the local initiatives have been taken by fishermen in Kerala itself. There have been news like for rescuing people and all. Not plans, sir. Like it was in the news. So local initiatives from our fishermen itself, local people. Yeah, where like when there were floods, they took up the initiative to rescue people who were trapped in the houses and all. So that's all. Thank you, sir.
And next one, we'll go to revisiting the environmental Kuznets curve in extended bricks, a panel data analysis of carbon emissions, trade and energy transition. Dr. Kushi Viksit et al. Online.
Dr. Kushi, are you online?
Yes, ma'am, and I am a first year master student, so I would not be going with the previous talk. Please allow me to share my screen.
Hello, Khushi. Are you ready?
Give me a second, sir. There is a technical issue at my end.
Shall we go to the next one, Pran?
Just one second, just one second.
Okay, okay. Yeah, we are on the brink of a disaster with the rebellious intestines. Okay, okay, okay. Okay. Now, if you want more time, we will allow you the next person and then we can come back to you. Acha, no, there's one more. Minikoy. Yeah. Yeah, yeah. Kushi, please wait. We'll go for the next one. We will come back to you. Don't worry.
So we'll go to the next presentation, relationship between socio-economic factors, awareness of environmental challenges, and nature-based solutions, a case study of Minikoy. Nawaz Shakira.
Is he here?
Here or online?
Online.
Is he presenting from Minikoy?
That'll be wonderful. Okay, okay, that'll be wonderful.
Kushi this side. Greetings to everyone. I am ready if there is still time, I
Acha,
would
Kushi
be
is
happy
ready.
to present.
Okay, if you're ready, then please share the. Acha, she is not able to.
Okay, I have, is my screen visible? Is the screen visible, sir?
Yes.
Yeah, yeah.
Right. Greetings, everyone. So the topic that we have chosen is revisiting the environmental Kuznets curve in BRICS, a panel data analysis of carbon emissions, trade and energy transition. This is co-authored by Pooja Sharma ma'am, Tanu Shivnani ma'am, and myself, Khushi Dikshit. We all know that environmental Kuznets curve is an empirical phenomena, and it was for the very first time observed by Grossman and Kruger in 1991. This empirical phenomena suggests that as countries develop and as their per capita income level keeps on increasing, initially carbon emissions tend to rise with the growing use of resources and pollution that is created as an externality, and they eventually peak at a point after which nations increasingly focus on greener technologies. They undergo structural shifts in their energy mix, and they focus on sustainability, and we see a reforestation movement or environmental conservation movement on the rise. Therefore, the emissions start to fall, and what we are left with is an inverted U-shaped curve. This has become increasingly important to study these days because the recent UNEP emissions cap report, which was released in 2024, projected that the greenhouse gas emissions can reach approximately 57 gigatons by 2030, and we have exceeded the Paris Agreement already, and by the end of this century, the world would reach around 3.1 degrees Celsius of warming. So the increasing pressure that has been put on climate has also led to a surge in the literature which is available on EKC in the recent years. But and that literature also we analyzed very deeply in the paper, and we came to a conclusion that there are some very important things we must keep in mind so as to stand on the shoulder of giants. So EKC is an empirical phenomena which does not capture the global pollutant carbon dioxide very well when just seen with respect to the GDP per capita. And in the early stages, this study by Stern suggests that we should look at convergence dynamics between countries. That is, we should look at countries which are at different stages of development and then analyze how EKC plays out in their economies and understand how one economy varies from another. So this is an idea suggested by him, upon which we build and we incorporate BRICS nations. Now, why BRICS nations are important here? Because although a lot of literature is, yes, available on EKC, but BRICS nations and the BRICS bloc is essentially missed out. And literature that we analyzed also reveals that when EKC is studied, when carbon dioxide emissions are used as a variable, their estimates are higher as compared to carbon dioxide or any pollutants concentrations being used. And moving on, we also analyzed what are the various EKC studies conducted region-wise for different regions. And over there, we were coming to the same conclusion that BRICS as a block has not been explored much. But one thing that was a highlight was we require we require a more holistic approach to understand how the curve actually pans out, and just income will not work because as we see across regions, somewhere it is U-shaped, somewhere it is N-shaped. Sometimes EKC is yet to show a turning point, which is the case with most developing nations. And the literature also reveals that EKC in the turning points in EKC are induced rather than automatic, and they are induced by changes in energy mixes, adopting sustainability, as a practice and focusing more on it. Therefore, we came to the conclusion that it is important to include more variables and a diverse set of variables, and also how institutional factors play a role in this in our paper. Moving on, we aim to understand three things. First, how is the empirical relationship of EKC panning out in the BRICS bloc? And we also aim to understand the influence of the climate resilient policies and sustainable development policies which have been implemented in these regions, and how they have, in a way, influenced the curve. And we wanted to get a holistic understanding using multifactorial drivers of emissions, as I mentioned earlier. So based on the literature, we developed a hypothesis that EKC will not be operating in the regions of BRICS, given the fact that regions are developing. And the previous literature hints towards the fact how developing nations are on an monotonically increasing path of carbon emissions yet, and initial turning points are not seen anywhere near. So we used panel data, and we first run the fixed effects model test, which is the Hausman test, to perform was performed to determine whether the random effect or fixed effect model should be chosen, and we chose the random effect model. We also employed the Wald test, and it turned out that heteroscedasticity is present in the data, and it was removed using the generalized least square regression. Coming to the data description, all the variables that you are noticing are highlighted in yellow are the dummies. And these dummy variables represent in the data, they represent when was a particular international protocol, policy, or agreement finally adopted in a country, not signed but adopted, or it came into effect. And rest all others that we can see above are variables. And one important thing that I would like to mention is that we used carbon dioxide emissions total excluding LU-LUCF in percentage terms and GDP per capita growth annual in percentage terms to maintain similar units. There are also a lot of, and all the data that we used was sourced from World Bank. There are also other potential databases that we found, but we relied on the data which was available on the World Bank data sets. Other sources that we looked at are also mentioned. Again, as I mentioned, the variables and the model. Now coming to the data analysis and discussion, this is a correlation matrix, and this is something that we've done for all 5 BRICS nations. For Brazil particularly, the two numbers highlighted in yellow are showing insignificance, and for Russia, when we look at it, the variables highlighted in blue shows significant relationships or significant amount of correlation. Similarly, we have the correlation matrix for India and China. And for South Africa. Now, this is a scatter diagram which is showing how carbon dioxide emissions in percentage terms are related with the per capita GDP growth, again in percentage terms. And this was studied for a period from 1991 up to 2023. And we see that the trend line is more or less flat. And what we observe is that emissions are and the next thing we have is for Russian Federation. This is again a scatter plot showing how GDP varies, how carbon emissions vary with GDP. In Russian Federation, similar scatter plot for India. China is one country which has shown a decreasing trend, most likely due to the institutional factors and the push that the Chinese government has given to sustainable practices in green energy. The plot for South Africa. And this graph shows the trend of carbon dioxide emissions in percentage terms for all BRICS nations individually, and also the average of BRICS countries from 1991 to 2023. So this is a screenshot of the. So what we concluded from the paper was there is a strong relationship between GDP, FDI, and renewable energy consumption, urban agglomeration, and human development index. And inequality plays a critical role in determining carbon emissions. Renewable energy consumption plays a determining role. However, it increases the carbon emissions, suggesting that the impact of renewable energy adoption will need a time lag. And initially, to foster renewable energy, there is a need for carbon-intensive investments. China and India depict a very high correlation in the context of policy and agreements on carbon emission. Thank you.
Okay, thank you, Kushi.
Yeah, it was a very interesting presentation because just one point that there are many people who argue that this model is a flawed one, and I think your work is a saving grace. And maybe you can think about incorporating a different metrics, like for example the well-being. Yeah, then that will be a bigger challenge. It's very good, very good. Thank you. Congratulations.
Kushi, for my GK, I am asking what is this? In your title, no, it is given extended BRICS. Any term like that? Can you clarify it?
Yes, we plan on extending the analysis to other nations which become a part of extended BRICS bloc. So therefore the term.
Increase. Are there. Okay. So under BRICS only these 5 countries will come. Okay. Thank you.
Any questions from online participants? Okay.
This one.
Last one. Yeah, Nawaz. Hello, Nawaz, Shakira. Are you there?
Yes, ma'am.
Yes,
yeah. Sir.
Yeah.
Am I audible, sir?
Yeah.
Yes.
Relationship between socio-economic factors, awareness of environmental challenges, nature-based solutions, a case study of Minikoy. Yeah.
Slide is visible?
Yes. Put in slideshow. Yeah.
Minikoy, yeah. She's in Minikoy?
Yeah.
Good afternoon, all. I am presenting on the topic relationship between socio-economic.
Great work.
Relationship between socio-economic factors, awareness of environmental challenges, and natural-based solutions. A case studies of Minikoy. The climate change, biodiversity loss, and resource depletion threaten ecosystems and human well-being. Island regions like Lakshadweep are highly vulnerable to sea level rise, extreme weather, and reliance on natural resources. In India, rapid urbanization, unplanned land use, and tourism intensify environmental risk in ecologically sensitive areas. Integrated community-based strategies such as ecosystem restoration, sustainable tourism, and climate resilient livelihoods can help address these challenges while improving socio-economic resilience. These are the literature review I have collected for the study. And this is the study area in Minikoy. Minikoy is one of the most southernmost Lakshadweep islands, lies 398 kilometers from Kochi in Arabian Sea. It spans 4.8 kilometers square and it's known for its unique culture, Mahal language and tuna fishing. The population relies on fishing, coconut farming and tourism. The key issues are including the coastal erosion, sea level rise, groundwater salinization, biodiversity loss and poor waste management. It's the fragile ecosystem, so it is highly vulnerable to climate change impacting fisheries, tourism and livelihoods. And mainly the methodology followed is on random primary based survey. Me and my team collected 1,600 samples from the Minikoy island and use a stratified random sample to ensure representation across different groups. This conducted by key informant interviews with community leaders and experts. The data processing and analysis is data processing and analysis is done by descriptive statistics for awareness and willingness index to comparison with across socioeconomic groups, and this outcome is identification of socioeconomic determinants of environmental awareness and willingness to adopt. There are 4 objectives for the study. One is assess socioeconomic factors influencing environmental awareness and willingness to adopt nature-based solutions in Minikoy. Evaluate community awareness levels regarding environmental challenges like coastal erosion, salinization, biodiversity loss, and waste management. Determine willingness of households to participate in sustainable environmental practices and restoration initiatives like mangrove planting. Analyze variation of awareness and willingness indices across demographic and socio-economic groups. These are the descriptive analysis of survey data based on the age group, occupation, education qualification, and average monthly household income distribution. The respondents are mostly middle-aged housewives and low-income earners. There is low level of education and most households earn less than 15,000 per monthly. This suggests a rural or semi-urban setting, possibly with limited access to education and employment opportunities beyond domestic or traditional sectors like fishing. Based on using the scores, the variety of questions we have converted to qualitative questions to indices, that is awareness and willingness indices. These are the some of the awareness aspects, perception on importance of mangroves. Based on this, most of the people are heard about the importance of seagrass and mangroves, but they are not fully aware of why this is important. Okay. We collected 1,600. Most half of the people are responded that they are heard, they are important, but they are not fully sure that why it is important. And most of the people in the perception of shipping activities impact on marine ecosystem is the another aspect of this awareness index. Nearly half of the respondents are uncertain about the link between the shipping and ecosystem damage. And also they responded that this seagrass and mangrove are important, very important for their livelihood, and also responded that they faced natural disaster in last 5 years. And other remaining awareness indices are awareness of ways to protect the tsunami or cyclones. Most of the people responded that they are not sure how to protect this from the tsunami or cyclones, and they didn't experience any coastal erosion, and the methods to mitigate the coastal erosion is by the mangrove restoration. They responded that mangrove restoration is very useful to mitigate the coastal erosion. That shows that that is readiness for community-based conservation initiatives. That is the awareness of sustainable coastal protection methods. And primary concern regarding environmental sustainability is waste management. And another index is that willingness index. These are some aspects of the willingness index. Support for expansion of ecotourism is more, and also they are mostly there's support for the community program, and also they are mostly they are willing to participate. Most of the people responded that they are willing to participate in restoration activities of mangrove and seagrass, and also willing to collaborate with the government officials for the conservation. And this and data shows the integration of the awareness and willingness index. The age group between 31 to 56 age group that will shows the maximum awareness, more awareness and more willingness to participate this program, conservation and restoration program. And also education level increases the education level. They are also mostly willing to participate in the and more aware and willing to participate in the restoration. And also the case of income wise awareness, income is increasing, the awareness and willingness index also increasing. We did by ANOVA and regression model. It is says that the data says that ANOVA shows the model is highly significant. It indicates that the demographic and socioeconomic variables collectively influence the willingness index. It is concluded that the overall regression model is significant, that is a highly willingness to participate in the restoration and conservation program. Then regression results, awareness index plays a significant role in determining willingness to participate in the nature-based adaptive activities. Ecotourism willingness is a significant factor, instrumental in the overall willingness to participate, that is to sustainable, is in the sustainable model. And income is another factor that determines the willingness to participate. Not being aware at all is not a significant aspect of determining the willingness to participate. Therefore, the people can be motivated even if they are not aware. And this is the area mangrove ecosystem in the Minikoy island, and we conducted a mangrove planting on the day of World Environmental Day. And this is the conclusion. Minikoy Island faces critical environmental challenges including coastal erosion, sea level rise, salinization of groundwater, biodiversity loss, and improper waste management. Community awareness about these issues exists but varies significantly across socioeconomic and demographic groups. Willingness to adopt natural-based solutions such as mangrove restoration and sustainable waste management is influenced by socioeconomic factors. Engagement activities like awareness programs and community-led restoration have shown potential to enhance environmental consciousness and participation. Strengthening awareness and promoting inclusive participation are crucial for building resilience and protecting fragile island ecosystem. That's all.
It's a very, very interesting work. Any questions? Online, offline? Okay. No, my only suggestion is that maybe you can tie up with Aditi's team, and since Minikoy is a small place, I think
yes,
that kind of tying up may lead to more insights, and it will enable your work in a better way.
Yes,
Thank you for the excellent presentation. Thank you.
What is I have one question. What is the literacy rate in Minikoy?
93, ma'am.
93. And what more education you are telling that they need for accepting all this? You know, you said education.
They are not accepting this, but their literacy rate is more, but they are not accepting this That is the problem, ma'am.
Yeah, then, but you have mentioned that education will help. What sort of education they need? That's what I asked. Maybe we can look for the future, you know. What is the type of education you mean by that?
I think ma'am, this mangrove, this environmental issues are not being, they are not aware of these issues, ma'am. That is the reason.
Okay, ma'am, what she meant was the willingness, participation, the kind of activities. Yeah.
She said people are aware
They
that
are not
mangroves
aware
are
of-
important.
Okay, people are not aware of this aspect is different from education. If not aware of these aspects is actually leading that they, even if they are not aware, they are quoting their willingness to participate. So that was predicted from the
Maybe
question.
you can rephrase.
Yeah,
here,
so the sentence was that they, even if they are not aware, they are still ready to participate. So that
No,
was
she
the-
said they are
Yes,
aware.
ma'am.
Yeah,
They are
maybe
aware.
she misread. Maybe she misread.
Another way, they want to be inducted into the force of the research. That's what, we have gone into the field. She is our field investigator. She is working in the thick of the whole situation. And what is happening, people are initially resistant. But later on, gradually, when they have been groomed into the idea, they are willing to work. So they have not immediately done enough, but they are now willing to do.
Maybe that citizen science concept, no, that
Yes,
can be
yes,
brought
and that
more
is-
than
that is-
this.
That is their success. The field
that-
investigator's success is so far, which I have evaluated, my team, I have evaluated that they are actually able to make the stone melt. You know, that's the idea. That's success. So I give credit to them for that.
Okay. Thank you.
Thank you, ma'am.
Another couple of presentations so that we have to ready. Rachel Batra, are you there?
Two presentations, you know, which Dr. Rachel Batra is to present. If she is available. Khushi
Yeah,
has
Khushi
done.
is done.
Rachel Batra.
Organizers, it's 2 o'clock. It's 2 o'clock now. Do we have to stop or do we have?
Whether you want us to stop it here? Before lunch. Okay, then let them complete. No, I don't know.
No, like climate change, this is the consequence of enjoying a high discount rate in the previous sessions.
Yeah, exactly.
So we don't want to get these people suffered. Aparat. People say intermittent fasting is good. No, Minikoy, and actually, you know, maybe we can spend some time on it. My insights for you, like certain things you need to keep in your mind, because Minikoy is an island, Lakshadweep is an island. So what, in my opinion, the people have lost is their identity as an islander. So that has to be restored. That is a major part. And second point is that you need to think, realize that this is a union territory, well supported by the government. So the economic system is a highly subsidized system. So what will lack there is the intrinsic motivation. So suppose you suggest something and as human beings, we all think in terms of the economic benefit we get. In Lakshadweep island system, the biggest challenge for us, because we also tried so many interventions, and it did not go the way we expected, the way we wanted to do. The main reason is that suppose we suggest a technological innovation which will fetch them say 100 rupees more. The issue is that what are they going to do with this 100 rupees extra? You see, if you are in the mainland system, you can go to Lulu Mall and spend the money. There is no such provision. So this lack of intrinsic motivation is the biggest challenge. So how to make them motivated, that's a challenge.
She's there, huh?
Yeah, please.
Dr. Rachel Batra, you can present both the papers, and after that we can do the discussion. Mapping of ecological vulnerabilities to resilience, a counter to political economy.
Sir, you will get more insights from people like Assis. He's from the island. Assis. The behavioral architecture, you need to spend more time with him. Yeah. So you have to ferret out some certain psychological details. Yeah. Good. Yeah. No, the reason behind the resistance is this. Simple. Yeah. Just imagine the situation if Lakshadweep has been declared as a state. Situation will be different. So people make wrong comparison with Maldives. Maldives is a country. See, the economic motivation is totally different. And even I would say that the kind of sustainability we see in Lakshadweep is because of this. It's a subsidized economy. Yeah. So now the question is whether we give value to the sustainability or the other one. I prefer the sustainability. Whether it is subsidized or not, we need to value the sustainability which is being maintained there. Yes. Yeah.
Yes. Yes.
They have thought well ahead of the climate disaster which is going to come. Most of them have purchased land in the mainland. See, you said it. Leave them. So the only thing is if we can bring back that. But unfortunately, yeah, they are under different pressures from the emerging political economy. That's all. Anyway,
Rachel Batra. Maybe taking lunch.
That's what. No, yeah, now madam is. So shall we wind up?
Sponsors are not allowing us, to break.
I see. Any post lunch provision, or we will wind up? No, that's what I'm asking, whether we can. Then better. Shall we? Shall we wind up, madam? Okay. So the session will continue or what? No. Okay. So
Okay.
what time we shall assemble back? 2:45. So Batra madam, are you able to listen? Acha, she cannot. Okay. Then we inform her. Okay. Then we will break for the lunch and join back at 2:45. Thank you.
Recording stopped.
Rachel, are you there?
Yes. Am I audible?
Yeah, you are audible. Please wait a bit.
Okay.
She's there. Good afternoon, Rachel Batra.
Good afternoon.
Yeah, you can present both your papers one after the other, and discussion we'll have after that, if at all anything is there. First one, mapping ecological vulnerabilities to resilience, a conundrum to political economy.
Yeah. I'll just
Please.
share my screen. Is my screen visible?
Yes.
Yeah, so good afternoon, everyone. My name is Rachel Batra, and along with my co-authors, today I'll be presenting. I kind of like combined my understanding of both the papers, and I'll be presenting it in one go, mainly with the theme of resilience in the face of climate change, understanding coastal strategies across developed and developing regions. So, as you all know, coastal areas across the globe are increasingly vulnerable to profound impacts of climate change. We're talking about sea level rise, global warming impacts, intense weather events, and persistent coastal erosion are just some of the immediate impacts that we are facing. But there is a lot of long term threat. This escalating threat makes disaster resilience and very urgent and critical priority for all nations, be it developing or developed nations. And perhaps it is this understanding of the approach that I want to highlight through this research. We want to understand, benchmark, and contrast the diverse disaster preparedness and resilience strategies that are being employed in Western coastal regions and South Asian coastal economies or regions. So we're trying to draw a distinction between two of these regions and accordingly structure our research. So I want to dive a little bit more into the research framework. So what exactly are we trying to solve here? And for that, I've like divided my paper into a couple of 4 points. The first one is the importance of adaptation to climate change. As the situations and circumstances are changing, it's important to understand that our preparedness also needs to change accordingly with the evolving times. So, for example, how are regions physically and structurally adjusting to these new realities of climate impacts? Like, what is the ground level reality? Secondly, the sustainable ways of living. Are the strategies promoting long term ecological balance and resource management or not? If not, where do we course correct? Thirdly, the reduction of disaster impacts. How effectively are the strategies or the approaches that we're actually applying minimize the immediate damage and loss caused by climate related disasters? And also we want to talk about other social benefits beyond disaster, beyond like direct disaster mitigation and management. Are these strategies actually contributing to the welfare of people at large, or different aspects like job creation, improved quality of life, or community well-being? Perhaps those are some of the larger questions that not just me but all of us should ask ourselves, right? So getting more deeper into the comparative analysis, why developed versus developing regions. So, as you know, that these regions generally possess greater financial means and advanced technological resources when it comes to developed nations. They have access to greater resources in all ambits of life. The primary approaches often involve, like consequently, of course, engineered solutions. They think large scale infrastructure like massive flood defense works, sophisticated storm surge barriers, and highly advanced early warning systems. So that's something about the developed nations. While these are incredibly effective in minimizing immediate upfront disaster threats and safeguarding valuable assets, they sometimes often fall short. They might not always give complete attention to long-term sustainability or social justice, right? There can be a lot of encroachments when it comes to taking up land and building engineered solutions. So there's a lot of undermining of natural systems, or they kind of like foster a dependency on centralized, often more expensive and fancy infrastructure. In stark contrast, let's understand how the South Asian force actually deals with coastal issues or resilience when it comes to this particular topic. They're more reliant on community based and ecosystem-oriented methods, something that have a positive impact on the environment and nature as well. Examples include vital initiatives like mangrove rehabilitations, the continuation of traditional fishing practices to re-establish the natural rigor of the ecosystem in itself, or grassroots community-based conservation programs. So these strategies kind of build a balance between the nurture and nature debate also that we have. They also build natural resilience against climate risk while simultaneously maintaining local livelihoods and preserving biodiversity. So there's like an essential balance that has been struck. However, these old approaches are often troubled by insufficient funding, limited institutional capabilities, some of the characteristics that are often developing nations are defined by, which can be blockers when it comes to actually implementing them on the ground level. Now going into a bit of the literature review, so I looked at some papers that actually do a bit of policy analysis and understand where all India struggles when it comes to the SDG board levels. We're talking about SDG 13, SDG 14, where especially climate action and even life below water, there's a lot of encroachments that keep happening, and often ecosystems below water go unnoticed and often damaged, and we hear news about it daily as well, like even like oil tankers being leaked by mistake or by some man-made issue into coastal areas, which again wreak havoc when it comes to life below the waters. Similarly, understanding political economy frameworks, the effective governance frameworks, when we implement them, they improve multifold when it comes to environmental performance, or especially in areas of creating strong institutions. We're aware of how strong institutions can have strong impact on the political economy network when it comes to climate governance. Similarly, we also read a bit about institutional theory, that is, the strong regulatory enforcement and civil society engagement promote better environmental outcomes. So I think it's also somewhere about changing mindsets and not just implementing things. When we're implementing, we also have to focus on changing mindsets. Similarly, we also understood the relationship between the polity and the ecological impact. That is, the intervention and governance are key to enhancing disaster resilience and sustainability in vulnerable coastal regions. A proper balance needs to be struck between not just implementing but also having the right governance institutions to actually be able to carry forth the message from the governance side to the masses. Similarly, on the contrary, we also are aware that weak institutions, corruption, and poor implementation lead to severe environmental degradation. So, no matter how good solutions we have out there, if the institutions in itself that implement these solutions are under threat by certain parameters like corruption or lack of funding, then of course, seeing positive results is next to impossible, I feel. We also did some case studies on marine spatial planning. It talks about a particular area that restructured its sovereign debt to fund marine conservation, showcasing a very successful blue economy model. It kind of like restructured the entire debt, therefore ensuring that certain amount of money is maintained for other activities, but at the same time is also maintained for marine conservation that they were facing a huge threat from. Similarly, we also understood impact assessments to see how climate-led sea level rise poses existential threats to coastal areas, and environmental harm in one region can affect not just broader ecosystems but also other coastal areas as well. A particular interesting understanding from our literature review was the fragile state index, and we've also used it in our methodology, which I will talk about later on. But this fragile state index, it actually identifies regions that are most at risk and inform also disaster preparedness, and uses this information to inform disaster preparedness. It's also called a vulnerability index or the fragility state index. So now moving on to the methodology that we used. So far I'd been talking about the qualitative case studies that I had analyzed along with my co-authors, but I also want to highlight a bit on the robust quantitative approach that we've followed. So our model that we've done, if you see, the dependent variable is the GDL, and it's expressed by this particular equation on your screens, where you have the independent variable on the left and the dependent variable on the left and the independent variables on the right, which range from, I'm going to talk a bit about the independent variables, for example, demography, which represents the demographic characteristics of a region, just to give a brief, such as a population size, density, or age structure. We also have the refugees, refers to the number of proportion of refugees within a region, indicating population displacement. Then we talk about group grievances, which basically denotes the grievances related to resource or environmental issues that groups have within a particular area. We have brain drain, especially the emigration of skilled labor outside of the particular region. We also talk about economic inequality that indicates, like you might know, the economic inequality within a region, which can also affect the way resilience is approached in itself. We also have economy, which shows the overall economic health and structure of a region. We have state legitimacy, reflects the perceived legitimacy and effectiveness of a state, like I was talking about in the literature review, which talks about governance and how that can impact the way we deal with resilience. We have public services, which again refers to the availability of governance infrastructure that is present. For example, healthcare, education, all kind of infrastructure that the people have access to. Human rights, do they have the right set of statuses and protection of human rights within a particular region? Factionalities represents the presence and influence of a competing elite groups within a region, and so on are some of the independent variables on the right, and of course followed by the error term that we have.
Can
And
you be,
dependent,
excuse me, can you be little brief?
sorry?
And you're very fast. You can be little more briefer and precise, you know.
Okay, sure. So that's the equation. Moving on. So this was the results that we'd gotten from Stata. The total countries that we looked at was 120. The GDL, as I mentioned on the left side, the dependent variable was the fragile index, and all values were adopted from sources that will be listed. We basically did it for western and eastern coastal areas. Our main research question was, what is the reason for the fragility in these areas? So initially we used a fixed effects model running our analysis in Stata. After a crucial step, we also did the Horseman test, which suggested that the random effects model was statistically more appropriate for our data. So after conducting that particular RE model, we tested for heteroscedasticity using the Wald test, which indicated a high level of its presence in our data. Consequently, to ensure the robustness of our results, we performed the panel generalized least squares solution regression to effectively remove the heteroscedasticity. So before I move on to the key findings, is the data set visible? I'm actually sharing another screen.
It is visible. Madam.
Okay, let me just share my entire screen. So now it should be visible, right? The data set on Excel.
Yes.
Yeah, so this was all of the, we've jotted on the years here. And the countries is in column A, year in column B. And we have the different independent variables, like I mentioned, demographic pressures, refugees, group
No,
grievances.
we can see only table, but what is written, nobody can read.
You just show the correlations and you can come to the conclusion and move on to the next presentation. Yeah.
Okay, yeah. This is the correlational table. Is it visible?
No, we'll not be able to see this. I mean, we can't read it. It is visible. You can just
maybe your inference you
conclude.
can
Inference you can say.
Okay. Yeah, just coming back. So the key findings from our quantitative analysis, firstly, all the variables included in our model had highly significant values in terms of affecting the fragility index or the dependent variable, that is the GDL. And to reiterate itself, the GDL itself is a crucial vulnerability index that we had come up with to monitor and project socioeconomic vulnerability, specifically in the context of coastal regions as well. So that's pretty much it, wrapping up our paper over there. It just showed that all these variables definitely had a high level of significance when it came to affecting fragility or resilience in a particular area. That's about it.
Move on to the next presentation. You can move on to your next presentation.
This is all that I have.
Both together, huh?
Yes, yes.
She merged both the presentations.
Okay,
yeah.
okay, thank you. Okay, any discussion on this?
madam, maybe you can ask something. Then also no problem. She will feel more motivated, you know. You can ask something.
Yeah. So the paper which we were attempting, this is a work in progress. So it's a paper when we are dividing the coastal regions into western and the eastern regions and trying to figure out empirically secondary data that how the socio-economic, political stability and other things, peace factor, all these variety of factors are influencing the trade factor, are influencing the vulnerability of the disaster point of view and the climate change point of view. So a lot of things need to be improved. We need to create our own index of vulnerability, which we adopted from UNDP. But a lot of things are missing in that. So we want to innovate in that way, that we want to add some more factors in that when calculating the index. So this, and divide them into two regions so that we exactly know what is required in the western. We do not blindly adopt what is going on in the west, in the coastal areas here.
Anywhere in the world we have a model?
Not yet, not yet. So this is something which we are trying to figure it out. Identify those factors which are more relevant in the eastern region and for the coastal resilience.
Whether we can compare our vulnerability to some other countries?
Yes, yes. This all will come out in that here. So we have to still segregate and, you know, divide the area into west and east itself is a little complicated thing, politically complicated, but we'll take out some benchmarks where we can identify these are the western coastal areas and these are eastern. And looking at their commonalities, you know, the basis of their living habits and GDP and all that, you know, economic, socio-economic angle, their literacy rate and some commonalities, we'll figure it out and take them out. So a lot of work is pending over here. Yeah, so nothing to comment here.
Okay, so it's a good attempt, and dependence on the secondary data alone, I think you may have to see, because with secondary data alone it is not possible. The kind of picture narrative you are planning to bring out may not be possible. So you have to go for primary data collection also.
That creates a basis for another project or some international project.
Yes. Good work. Thank you. Congratulations.
Thank you so much. Thank you everyone for taking out your time.
So I think we have come to the end of the session. Okay. This was the last in this part of this great conversation. Like Kalidasa said, Sambandham Abhashana Purvamahu. Any kind of conversation is not the end of it. It is the beginning of a new relationship. So I think the most important thing what I see is that I don't want to make any comments on the presentations. All the presentations were very good. As a concluding remark, I want to say just one thing. So let this be the beginning of a new kind of relationship, because as we all know, the phenomenon of climate change is a wicked problem. You know, the characteristic of a wicked problem is that if you are part of the problem, you also want to be part of the solution. So that is the only way by which the wicked problems are resolved. But here the issue is that even if you are part of the problem today, because of the fact that this is the consequence of the what you call generations over the last many years, so this becomes a super wicked problem. So this needs new perspectives, because if you analyze in terms of its ontology, in terms of its epistemology, in terms of its methodology, we need to have new perspectives, new way of thinking, new frames of references. The framing itself is required in a very different way. And as far as the theme of this conference is concerned, the most challenging aspect, or what I call as the Achilles heel, is the word integration. So I don't think the integration has happened. So this is an ambitious goal. What actually is left for us is to attempt the integration of these different perspectives. So that itself is a very big challenge. It's a lot of work we need to do, and the only way I see as the forward looking way, the only way is to provide or think about providing a platform by which this kind of works should continue, and we should enjoy the work and in a continuous fashion. Because what I say is that because people argue that go for multidisciplinary approaches, but when it comes to the funded projects, though it is written in the text, in reality the multidisciplinary convergence is hardly taking place. So I think this could be a very good beginning. Social scientists from Delhi and we both, because we don't have any kind of compartmentalization, because we are basically biologists, and having undergone the training in our specializations, some of us become social scientists, but most of us are basically biologists. So we don't have that kind of a compartmentalization. And you have seen the kind of the beautiful results, for example, Shelton was presenting. It's a result of convergence. So people from very different disciplines work together, and this is the way we move forward. And I think by entering into kind of collaborations in between both of us, I think this will be a very good beginning. And this is what the country wants, the region wants, and also we have to think in a global perspective also. For example, the kind of work Pooja was explaining. If you see the literature, the Chinese people, they are very smart, and the way they advocate their agenda through this kind of inter-country analysis is very exemplary. And we also need to venture into that kind of arenas, and that needs, because it's a methodological challenge, data challenge, data is the real issue, and I think this will be a very good beginning. I wish all the success for the days ahead. We in CMFRA, we are like fish, in a sense. Fish in English language is a epistemologically shallow word, but whereas fish in Sanskrit is a epistemologically rich word. Fish in Sanskrit is Matsya. Matsya means Mata iti harshayade iti Matsyaha, means that which is always happy is known as fish. So let's join together and see that the fish in our waters is happy, so that the stakeholders are also happy. Thank you so much.
I also don't have much to say. The presentations were very interesting and new to us. And like Dr. Ramachandran told, this should be a beginning of more collaborations. Maybe you would have understand from the deliberations that there is some gap which we can do through more collaborations and interactive sessions. So I wish you all the best, and it was nice being here. Thank you for the organizers for choosing me as a chairperson. Thank you for the rapporteurs, and the convener also has joined as a rapporteur in the afternoon. So that shows the, what is that, that commonness in everybody, you know. So I thank all of you for, on behalf of our team. Thank you.
Thank you, sir. Thank you, madam. Thank you, rapporteurs. That was the end of the sessions.
Thank you everyone, online participants also, for having joined us since morning. We now close the technical sessions with this, and at 3:30 we will have a tea break. So at 4 o'clock we will reconvene here in room number 201 for the valedictory session. So we have a break of about 50 minutes. We'll see you all again at 4 o'clock. Thank you.
Recording stopped.
Good evening, everyone. A very warm welcome to the valedictory function of the two-day conference on Vision Viksit Bharat at 2047 with the theme Mitigating Climate Change to the Blue Ecosystems, an integrated approach of science, community, and nature. Over the past 2 days, we have delved deep into the pressing challenges posed by climate change and its profound impact on our blue ecosystem. Now, we have reached the culmination of this meaningful journey. We'll now begin the valedictory session with the ICR song, followed by the CMFRI song. Kindly remain seated.
जय जय कृषि परिषद भारत की, सुखद प्रतीक हरित भारत की। कृषि धन पशुधन मानव जीवन, दुग्ध मत्स्य फल यंत्र सुवर्धन। वैज्ञानिक विधि नव तकनीके, पारिस्थितिकी का संरक्षण। शस्य श्यामला छवि भारत की, जय जय कृषि परिषद भारत की। हिम प्रदेश से सागर तट तक, मरुधरती से पूर्वोत्तर तक। हर पथ पर है मित्र कृषक की, शिक्षा शोध प्रसार सकल तक। आशा स्वावलंबित भारत की, जय जय कृषि परिषद भारत की। जय जय कृषि परिषद भारत की।
provide a brief overview of the two-day conference, I invite Dr. Shobhajo Kirakudan, Principal Scientist and Head, Finfish Fisheries Division, ICR CMFRI.
Thank you, Jia. Good evening, everyone. Since we've been here for the last 2 days, I'm not extending a special welcome to anyone other than our esteemed chief guest for this valedictory session. So on behalf of all of us here, I welcome Dr. R. Jyoti Babu, who is the scientist in charge of the Kochi Regional Center of CSIR National Institute of Oceanography. We are very happy that you accepted this invitation, given the short notice, and you have joined us today here for this valedictory session. And just to give you a briefing about what happened across these 2 days. So this was a seminar that was organized under the aegis of the Indian Council for Social Science Research, who the council has funded a project for the Institute of Social Sciences, New Delhi, and the PA of the project is seated next to you, Dr. Surjit Mahalanobis. This is Dr. Pooja Sharma, who is also who is a co-PA in that project, and we have Dr. Abdul Aziz, who is a scientist in the Finfish Fisheries Division. He is also a co-PA in the project. So under the project, this seminar was organized. They decided to collaborate with CMFRI for conducting this seminar, and that's how we took it up. This was aimed at, the topic of the seminar was mitigating climate change to the blue ecosystems, an integrated approach of science, community and nature. So it was a very broad topic, and accordingly we had 6 themes which covered almost everything under the sun. So we had the ecosystem, and we had the living resources in the open sea, in the seas, plus the human dimension to all this. And we had a lot of good deliberations. Totally we received around 44 abstracts, out of which 40 were presented. Many of it were presented physically, but the whole seminar was conducted in hybrid mode. So some were presented online, and we had secret evaluation also of the presentations. It was very nice because most of the presentations were done by the youngsters. This seminar was particularly targeted towards bringing out the talent in young researchers, which includes young scientists as well as scholars working in different institutions. And we had very good participation from many institutes across the country, but maximum from CMFRI, I must say that. So we were witness to a lot of innovative ideas coming up, and we learned some new terms which probably we can also incorporate into our research. There was, I don't know, Srishti is here today? Okay, there was a Dr. Srishti from Delhi who told us about eco-anger, eco-anxiety and eco-depression, which is all related to feelings created by climate change. So that was very nice. So like that, there were several new ideas, new things that we also learned, a lot of things that we could imbibe from this. And most of all, I'm very happy that we were able to collaborate with the Institute of Social Sciences, and hopefully this will be the first step in taking forward this collaboration. So I'm not going to take much time on this, but with this brief overview, because all of us have been seeing what was happening here over the last 2 days. So with this brief overview, I will pass on the mic to Dr. Surjit to give us his remarks. He is the brainchild behind the project and this seminar.
Thank you, Dr. Thank you, Madam, Dr. Shobha Jo. And it's a great opportunity to be here to present for you. Honorable Chief Guest, Dr. Jyoti Babu, Head and Scientist in charge of CSIR Institute of Oceanography, Honorable Dr. Grayson George, sir, the brilliant team of organizers, vibrant young scholars, scientists of CMFRI, and the brilliant colleagues that I have to work with. On behalf of myself, as the principal investigator and the project coordinator of the project, the mitigating climate change to the blue ecosystems of Minikoy, a science-based social
federal outreach study. I thank all of you, and on behalf of my institution, Institute of Social Sciences, New Delhi, and the Special Call Department of ICSSR for the research, I express my heartfelt thanks and gratitude to all of you for successfully concluding this seminar. We are honored and grateful to you all. The seminar concludes today, but our search for mitigation of climate change to blue ecosystems does not really conclude. Even in Minikoy, it will not conclude with the research. I'm sure the brilliant fieldwork of CMFRI in Minikoy will continue to sustain what we will be leaving in October this year. In our society, we have a brilliant capacity to stop senior people who want to work. This does not happen in advanced countries. Their universities accommodate their senior researchers as long as they want to work. This matter in our country needs to be evaluated, and with the changes that is happening to our society and our institutions since 2012, our new government has come out with a number of opportunities and have even granted many good corpus for the research areas. We expect that this aspect also will be looked upon in near future, and we greatly hope for that. 2047 needs to be vibrant and bright, and toward that goal we are actually working. The vision Viksit Bharat 2047 is a wonderful landmark for us, and it has set a target for us, and that we need to achieve. And unless we achieve that goal, we are actually nowhere. In our country, today India is a power, de facto superpower it is called, though we didn't get the opportunity in the UNSC. But India can do many things which other people who are called advanced, especially China, has already done. India has the capacity to do everything that China has done. We can even peep over China in many competitions. Anyway, so we have gathered very good material in this seminar as a support base to prove our hypothesis and find solutions to the burning issues in climate change. We shall utilize these in our chapters. I'm hopeful after submission of this thesis, I am, as a principal investigator and the project coordinator, will be assigned some more research work by the sponsor ICSSR. For all these, I shall always remain the warm, remember the warm, active and brilliant support from the ICAR CMFRI under the dynamic leadership of Director Dr. Vincent George and Madam Shobha Jo, Madam, Principal Scientist and Head of Fisheries Divisions of ICAR CMFRI. I do not have words enough to express my heartfelt gratitude to all of you and to your entire team. Thank you very much.
Thank you, sir, for your thoughtful words. We now move to the presidential remarks. I take this opportunity to warmly welcome Dr. Grinson George, Director, ICAR CMFRI, to deliver the address.
I will not stand between the lecture you are eagerly waiting, the valedictory address Dr. Jyoti Babu will be doing. But I am very enthusiastic to listen to the words eco-anger, eco-anxiety, probably eco-depression also. Last month I was in Vienna, so that time it was a symposium on living planets by European Space Agency. So one of the dedicated session was on the human stress levels happening because of extreme events, climate change and related factors. It's a truth, it's a reality. They want to measure these emotional stress levels using satellite imagery. So things are progressing that way. So this is not a new topic, but people have advanced so much in this arena. We also have a team of social scientists. Those are working on behavioral dynamics and all those things. So let them take this as an issue. We can have quantified information from satellite remote sensing also to support such studies on how much the change is and what is the stress level. And I even pinpointed in one of the sessions like we can do such studies very easily in India. In European conditions, it's very difficult to get such health information. But whereas in the case of India, we ourselves use a lot of stress-related gadgets, like things can be measured. Like most of the people are like our chief guest is also wearing an electronic watch, and he was telling like today he has completed almost 8 kilometers. So people are looking into those aspects these days, and it's very easy to get such information. If people allow, we have a ready stock information available here in this form of electronic gadgets what we are using, and we can tie up with some of the nearby flats here. Urban heating is a major issue. Even when we are very close to the coastal city of Cochin, the heating what we witness in Cochin is different in different localities. The places like Kalamassery, Kallur, where the activities are more, there is urban heating happening. So that is one topic which people discuss so much. So such things.
This meeting is being recorded.
This also increases stress to some people, particularly the speaker. So this is one area we have to focus upon, and I thank the Institute of Social Sciences and the Indian Council of Social Science Research for taking up this at the right earnest. Social dimensions of the science, what we say, is very important. That's why more and more studies are becoming socially relevant, society relevant. We are bringing in citizen science to several activities. In climate change studies also, this is a very important topic. I'm sure like the recommendations which have come out of the deliberations what we had for the last 2 days is exciting, and probably she will be bringing up a recommendation of that sort after all the matter is compiled. And seeing your faces, I feel like you are enjoying the sessions, and thanks for the team for wonderfully organizing. I think they served tea at Libitum, food also at Libitum, and all was very good, and there was a comfortable atmosphere. Despite serving good food and lot of sugar content also, I feel like none of you are sleeping. So that is an indication that the talks were vibrant and you were motivated by the talks. There will be new ideas. We are at the final phase of NICRA. There was a selfish motive for me because I am the NICRA team leader. I want to see like if we have missed something in NICRA, this is the time to compensate for that. By the time March we are submitting the reports, those who have not contributed to the NICRA in the right earnest, take this as an opportunity. There are more new ideas. I always told the people who are working in NICRA, if you are not done, if you have not got the right resources or right people to team up with, at least in your area of research where you wanted to join with NICRA, the reason for which you have joined NICRA, you should write at least one review paper. 4 or 5 years your toil in this project as a co-investigator. If you have not done that, there is no justification for that. So please make it a point that if you have not contributed to NICRA in a publication form, at least take time and write a review paper in the area where you are supposed to contribute. So there are more ideas flowing in. Let us cross-learn from each other. This is a typical cross-learning exercise where you could listen to social scientists, and the social scientists were listening to the biology, the modeling and related aspects, and many of them were inspired. The way I interacted, I was whenever I got a time, I could see the YouTube version of it. It's a possibility. Even after finishing this entire thing also, this is available in the YouTube. You can easily glance through. Wherever you feel like it's not your topic, you can even make it very faster and skip it off. So there is a possibility of looking into it. And this is one good exercise we should continue in our every brainstorming. Let it be in our YouTube channel. And wherever you don't want to disclose your science secrets, where there is an intellectual property right, you can make it concealed. But for our own team, it can be a vibrant thing to look again and again on the ideas which are being mooted in these brainstorming sessions. Thanks for the entire team for working on this, and I appreciate the work you have done. Let us carry this forward. I think there are more scientific results coming to it. I welcome Dr. Jyoti Babu. He is a close friend. We were contemporaries at NIO, National Institute of Oceanography. That was my alma mater too. I did my PhD from National Institute of Oceanography, Goa. So we had an occasion of getting trained together in the regional center also. 4 months during my PhD at NIO, I was at the regional center Cochin. That time we had very close interaction. So when I got an opportunity, I told Jyoti Babu, and he was also busy today, but he did not deny. So he came here. He's a globally renowned researcher in biological oceanography, and his findings can connect in many aspects to fisheries. So I told him, when you are giving your scientific points, give a thrust like how we can take up that further into the fisheries. So those who are in CMFR, I would like to join hands with Jyoti Babu after listening to his lecture. Feel free to do so. Let us see like the barrier in between can be broken through science. Thank you Jyoti Babu for accepting the invitation. Thanks Dr. Surajitan and his team for being here, and thanks to all delegates who contributed very vibrantly to this session. Thank you, Ananda. Thanks for the opportunity.
Thank you, sir. It is now our honor to invite the chief guest of the valedictory function, Dr. Jyoti Babu R., scientist in charge, CSIR National Institute of Oceanography, Kochi, to deliver the chief guest address and an insightful valedictory lecture on the theme, Plankton, the Pulse of the Ocean.
Good evening, all of you. My good friend Dr. Vincent George, the director of CMFRA, all dignitaries present in this hall. I could see so many CMFRA scientists, colleagues, many supporting staff, all those who came from different places to participate in this national seminar. My warm greetings to all of you. As Grinson has mentioned, I belong to National Institute of Oceanography. It is a regional center just adjacent to this well-known institute, CMFRA. You could see a circular building just adjacent to this compound. That is a regional center of National Institute of Oceanography, where in fact I belong. But I have a connection also to CMFRA, because I don't know how many CMFRA scientists know it, because most of my research work I have done in CMFRA, because those days facilities were very, very limited in our regional center. So literally I spent almost 4 years in a scientist's cabin to utilize those advanced microscope. I don't know whether Shobhana madam was here or not. I used to sit, I used to share his room, and she was so kind and open-hearted to allow me almost 4 years. Initially I started my research career in protozoans. So the entire 4 years I spent in CMFRA. So I have that way also I have some professional as well as personal sentiments to CMFRA. I just mention a few things about climate change, because everyone is worried and everyone is interested to speak about climate change, because one or the other way climate change is affecting everyone, not only the scientific community, even the common people. Everyone knows that there is something changing. So this field was not there earlier, but gradually everyone started accepting that there is something changing. Climate change is something real, because mainly this happened in the recent years because of the unusual incidents like cloud-based. You can see landslides, heat waves, frequent cyclones. Those natural calamities, actually the frequency of those incidents have increased. So everyone started accepting that climate change is real. So it is happening. But still at the same time, if you look at, there are people, even maybe the topmost person of the most developed country in this world, he even now says that climate change is a hoax. It's a trick. It is not really happening. So as scientific community or people who believe science, now at least anybody who studied a little bit science in the school classes, everyone accepts that climate change is a reality. And for marine scientists, this problem is much more severe. Why? Just for the basic reason is that Earth climate 70% is covered with ocean. But the 70% of the ocean which covered basically absorbs 90% of the warming that happens on this earth, because the reason is that water has high specific heat capacity. So basically 90% of the ocean warming is going to happening in the ocean. So it has huge implications. Not only on fisheries, but entire system is very gradually, very slowly it is getting changed. Since this change is very, very slow, you cannot feel it in a year, you cannot feel it maybe even in a decade time, but it is happening. You may be able to feel a significant change maybe in decades of time, maybe 50 years, 60 years, 70 years, but it is real, it is happening. So in my lecture, I will just elaborate a little more on that. At this point, I just want to tell all those participants of this workshop that we need to be realistic, because climate change is something very sensitive, it is happening, but at the same time, you can see even in the scientific community, many people are using that as an opportunity to make it more and more sensitive, which is not really happening in this system. So we need to be sensible, we need to be truthful, we need to be realistic when we need to address climate change. Every change you are seeing every year or maybe even 5-year duration or 10-year duration is not climate change. Climate change is something is completely different. You need to approach it very scientifically. Okay. So some of the points I will cover in this. Anyway, my best wishes to everyone who participated in this program, so that the ideas and deliberations which you have done in this program, I'm hopeful that that will take you a long way in your career, and you will remember all those useful things. Once again, my appreciations and greetings to everyone. So when Grinson, I think yesterday, asked me to just come over here and make a presentation, I was a little worried actually, because I don't know the nature of this community, whether it is, what level of the people are going to participate, whether they are just students or teachers, professors. So Ramya, Dr. Ramya, who was with me for some time in NIO, she told me that, sir, it is a heterogeneous group, all kinds of people are there. So I just made this presentation as general as possible. So mostly it's a generalist presentation. I will not go much details, because it may be difficult for some group of people who might not be really exposed to marine science. Okay. So I just kept my presentation title as Plankton, the Pulse of the Ocean. So if you go to the seashore and take a handful of water, and if you look at that water, you may not be able to see anything. You may sometimes think that there is nothing in this, that much of water, a handful of water, but that belief is completely wrong. So if you see, if you take 1 liter of seawater, you can get around 10 to 100 billions of organisms, living compound entities in that water. So these very small microscopic entities, in general, we can call it as plankton. So plankton, basically they are microscopic organisms, mostly they are microscopic organisms. They occur in the seawater in billions of numbers. So you can see 100 billion means 100 crores of organisms can exist. So they are basically drifters in the ocean, and we can see some of those details further. So if you explain plankton the term, you can say they are highly heterogeneous group, starting from bacteria. You can see the entire spectrum from bacteria to metazoan. All those groups of organisms are there in the plankton, and they respond very rapidly to environmental change. So since they have the ability to respond fast, they are considered as the pulse of the ocean. Okay, and most of the plankton, they have short lifespan, so they have an advantage of responding faster to the changes that happens in the environment immediately. So they are the basis of food chain. They are the integral part of biological pump. They are the integral part of biogeochemical cycles. So naturally, but the question here is this: can fish survive with plankton in the ocean? My answer is a clear-cut no, because directly or indirectly fish has to depend on plankton. because plankton are producing the basic organic carbon in the ocean. Now next question is, what about human? Can humans survive with plankton? They are so microscopic and trivial organisms which are living in the ocean. Can humans survive without plankton? My another clear-cut answer is no, because 70% of the oxygen which we utilize or breathe has come from ocean, from plankton. And even the carbon dioxide, major part of the carbon capture or carbon dioxide capture is happening in the ocean by phytoplankton plants, these microscopic plants. If they are not absorbing this carbon, our temperature on Earth's surface would increase at least by 10 degrees further. It might not be inhabitable most of the places. So for these two simple reasons, you can say if plankton are not there in the ocean, neither fish can survive nor humans on this earth. So that much vital they are. So this picture you can see, if you use a, you can see a picture there. It shows normally with a plankton net, if you collect sample phytoplankton net, this is a kind of organisms you would get in that. Now phytoplankton, there are different types of grouping classification. I do not want to teach you basics so much, because for many people it may be so boring because they already know all those. But this is just for giving a background. Plankton, these microscopic organisms, based on the mode of their nutrition, it can be classified broadly into two. One is phytoplankton, basically they are the plants in the ocean. Other group is the animals in the ocean, they are the zooplankton. So naturally plants have the ability to photosynthesize. They create all the organic carbon in the ocean, and zooplankton is an animal, basically they have to depend on the plants for their nutrition. So you can see this picture. There are different sizes of plants. From this is a normal phytoplankton one might have seen, but there are a lot of smaller components also. So this is a large spectrum of organisms, very small to maybe even 2 centimeters large. Now just for the students, if anybody is interested how this phytoplankton is collected and analyzed, because normally in seawater, if you see this phytoplankton might be around hundreds in numbers. So naturally earlier days people used to use this nets for collecting phytoplankton. Nowadays it's not a standard practice. Even 1 or 2 liters of water directly if you collect and concentrate and settle, you can analyze phytoplankton. So this is a standard method, and there are, you can see different equipments which can be used for collecting sample. Then through microscopy and other many equipments, you can quantify phytoplankton. This is specifically for some students if they are interested. Similarly zooplankton, but zooplankton's problem is that their abundance is much lesser than phytoplankton. Maybe some 5 to 10 number maybe in 1 liter. So if you take some water, you might not see anything sometimes. So in that case, we need to concentrate. There are so many kinds of nets which are used for concentrating zooplankton. You might have seen only 1 or the 2 types. This is the type, you can see HT net, ring net, so many are there. You cannot say any of this net is superior than the other. No. These whole net selection has to happen based on the requirement basically. Okay, if you want to do a specific kind of measurements on plankton, you need to depend on that particular net which is useful for that purpose. Okay, so many kinds of net. This is actually bongo nets. Most of the students make a mistake. They use normal ring net and they will write I used bongo net. No, bongo net has 2 mouth. You can see this is a duplication net. So this is a bongo net. It's a heavy net. Nobody can use by hand. This can be operated only through help of the ship. And this is another modern equipment, not modern actually, advanced equipment which is called CPR, continuous plankton recorders, which is a very heavy metallic equipment, and that can be towed along the route of the ship when it is sailing. So you will have a continuous record of samples which will be collected inside the equipment, CPRs. I will detail on that aspect. So if you look at those were basically traditional historical methods. Now we can integrate multiple methods, advanced methods together to study plankton. And you can benchtop imaging systems are there, vertical imaging systems, vertical net hole systems are there. There are flow-through systems are there. You can install equipments on board. You can run some seawater through the flow-through. You can collect samples. You can image the samples. There are towed systems including CPRs. You can see autonomous platforms are available, which will sink down to the ocean certain depth. It will record the phytoplankton, chlorophyll, even imaging it could do. So now this is an advanced system wherein you can use multiple equipments to study plankton. Now I will go a little more into this particular statement. Plankton is a pulse. So what is pulse? Pulse is basically the rate of heartbeat. So earlier physicians, basically those days when all these so-called clinical tests were not available, anybody goes to a physician, what he would do? He will test your, count your pulse. So pulse will tell everything. Everything in the sense, this is the best vital sign, it will give you what is your health condition. So that's a sense in which I use this terminology, plankton are the pulse of the ocean. So if you can properly understand plankton, what is its composition, what was its composition, what is its composition, how it is going to be changed after 10 years, if you can properly study it, that will be an excellent pulse, excellent indication to understand how climate is going to change and how it is going to affect the marine ecosystem. So this is an important slide. This will tell you in general how overall changes in the, for example, global warming or ocean warming, how does it affect, how it is going to change the marine ecosystem. Because any plants, including terrestrial plants, they require two important things. One is they need sunlight for conducting photosynthesis. Another one, they require nutrients for making the biomass that is required to conduct all this photosynthesis. So these are the two basic things which are required. This is exactly applicable for the microscopic plants in the ocean also. They require sunlight, they require nutrients. But the problem is this, these two requirements, primary basic requirements, very rarely happens at the same place or exist in the same place. Means that these two vital components which are required are in most cases disconnected. In the surface layers you will have sufficient sunlight, but the nutrients are always sitting slightly below, which is not available to the surface layer for phytoplankton to flourish. So this is the problem in most of the ocean. Upper 50-meter water column may have sufficient sunlight, but your high concentration of the nutrients are sitting below 70-meter depth or deeper depths. This is disconnected. Okay, so basically tropics nutrient availability in the surface layer will depend how the primary producers flourish. So now we can see how this is getting changed. This distinction or disconnect is getting changed by the involvement of the physical processes on the ocean surface. Which are they? They are basically, you can see sun, you can see solar heating, you can see precipitation, evaporation, winds. Winds are very, very important factor in the ocean. Winds act two ways on the ocean surface. One is that wind has an effect to directly mix the ocean surface water. You can see it can mix few tens of meters. Maybe from the upper 0 meter to 80 meter in the water column, entire water column, in some cases wind can mix. And even waves are basically generated by winds. So even waves also can mix a few meters of the ocean surface. So you can understand this wind and this waves, okay, and even the heating, precipitation, if global warming increases or goes in the rate at which it is now, all these physical forcings is going to change. It is already got changed and it is going to change further. So if that further change happens, it will have a lot of implications on the biological production in the ocean, the pattern in which it is being distributed, production is distributed along the ocean regions. I will show you some of the cases. You can understand it further. For example, this is a situation wherein in the northern Indian Ocean, wind forcing is maximum. Wind forcing is maximum during southwest monsoon time, June to September time. So you can see all these are wind effects basically. So what wind did here is that wind basically removed that disconnect between the high nutrients in the bottom and the ambient enough sunlight on the surface. So both are existing in the same places. So all these red lines you hear, these are the areas where wind broke this disconnect between nutrients and sunlight, and both these vital parameters are available at the same place. So red is a high concentration of chlorophyll, basically represent the phytoplankton abundance in the ocean. So what about these areas? These areas were blue areas, still that disconnect is existing. Wind forcing is not capable enough to break this disconnect in those areas. So those areas naturally will have low productivity, and these areas will have high productivity. This is during southwest monsoon time when wind is maximum. So this is a condition when wind is minimum. You can understand the difference. So your red color concentrations are very low now. It says that this disconnect is very strong now because you have enough sunlight in the surface layers, but no nutrients. Nutrients are still sitting in deep down, which is not getting lifted to the surface because wind is very less. This is just one forcing, wind forcing I mentioned. So global warming happens. One of the important effect is that the strength of the wind may change. Even the pattern of the wind may change. Even the direction of the wind may change. So just one parameter imagine and just visualize what kind of impact it can cause on the productivity patterns of the ocean. Now about algal blooms, everyone knows algal blooms. At least some of you may be thinking that everyone accept the statement that algal blooms happen when conducive conditions occur. What is this conducive condition? Certain species of organisms may have a particular nutrient requirement, a particular level of solar radiation availability. When those requirements exist together, that particular species innumerably increase. So that is algal bloom. But don't think that these conducive conditions are same for all the species. No. Conducive conditions are completely different for different organisms. For example, two cases I have furnished here. One is Noctiluca bloom that happens mostly during a nutrient-rich southwest monsoon condition it happens, or maybe just after the southwest monsoon condition, when sufficient amount of nutrient as well as phytoplankton concentration is very high, that time this Noctiluca bloom occurs. But this is a trichodesmium bloom occurs when there is no nutrient at all in the surface waters. It's completely oligotrophic, stratified conditions, March, April, May time, this is happening. So essentially what I want to say is that so-called algal blooms, now currently there is a pattern of their occurrence. If climate change impacts the environment so much so that after some time, even their occurrence pattern may change. Even their spatial distribution might change. So all will have implications on marine ecosystem as a whole, fisheries also, it will have, definitely it will have implications. So now we can just come to slightly to fish. This is, plankton, I told different components of plankton are in the ocean, but they are not isolated entities. They are interacting together basically a relationship by eating and being eaten. So that relationship we call it as food chain. So when many food chains have interconnections, interlinking, then we call all together as a food web. So you can see here, these are all small phytoplankton. Normally this small phytoplankton occur when nutrient concentrations are very low. And this large phytoplankton diatom and all those occur during when nutrients are very high. So this large phytoplankton based this food chain is very, very efficient for sustaining the pelagic fishery. But this is not that much because there are so many interlinkings in this food chain. So length of the food chain is larger, so that efficiency of the transfer is much lower. So if you have 100 here, maybe 0.1 may be reaching here. But if there is something 100 here, you may get 10% here. So this is much more efficient. And you just imagine currently there is a nutrient distribution in the ocean. If climate change, changes it, even this size of the plankton might get changed. So for example, if it is oligotrophic ocean, because of the warming and stratification happens in some areas in future, naturally this phytoplankton group will dominate. It will not support so much nutrition that is required for the high trophic level fishes. So naturally, those fish quantity may come down. So one example, this is oil sardine, you know this, and you can see this Fragillaria oceanica. Many of you might be studying even now Fragillaria oceanica as an indicator of oil sardine. But we get this Fragillaria oceanica very, very less amount now. Now one of the recent publications from here, I have seen that Cosino discus is actually the most important diatom supporting pelagic fishery. So there is some change. Many people are not reporting Fragillaria oceanica. This is we found in the mudbank area. We found this every year there. But other areas we have continuous surveys. Very, very, very rare situationally we are seeing Fragillaria oceanica now in all these coastal areas. You don't know whether it is due to climate change or any kind of change, but there is a change that happened. So there is also tricky. We accept that without plankton, fish cannot survive 100%. Directly or indirectly, fish has to depend on plankton. Okay, whether it is demersal or pelagic, whatever it is, it has to depend. Now, these three statements basically supports this. You can see that upwelling regions is just 5% of the global ocean, and it supports 25% of the global marine fish. That is one of the evidence that strongly support the first statement. And the other one, most of the small pelagic fishes directly consumes plankton as their food. And most of small pelagic fish main spawning period is closely linked with monsoon. Basically, that is the time you will have maximum abundance of plankton. So it helps their larval survival. So these three statements strongly support this. But there are some issues in directly linking plankton to fish. This is basically because plankton's lifespan is short, but the fish which you are talking about has a long lifespan. It may be in years, but plankton, phytoplankton may be once. Phytoplankton divides maybe once or some phytoplankton even twice in a day. Some maybe once or 2 times in a day also. So their lifespan is very short. Your fish you are comparing is having a long lifespan, and also this fish distribution has differences. Okay, so you can see all these, many fish have schooling behavior. So it is not that easy to just by number, comparing or relating this fish abundance with the plankton. It has practical uncertainty. And you might have already heard about match mismatch hypothesis, okay, by Cushing in 1990, who proposed that the success of many of these fishes, spawning as well as recruitment is depending on the timing as well as the duration of upwelling incidents like upwelling. But I noticed that CMFRA studies says that in our waters at least that mismatch is not really happening. So all this says plankton is very, very important to fish, but when you try to relate one to one, there are certain uncertainties due to all these, but still we can try to address all those things in a research purpose. Now I will come to climate change. So long-term environmental change in the ocean, I just wrote global warming and ocean acidification. These are the two terminologies. Please don't think and believe that both are the same. They are different. Certainly ocean acidification has a connection to global warming, because ocean acidification is basically related to increase in carbon dioxide, decrease in the acidicity of the ocean. Okay, so carbon dioxide is a greenhouse gas. So naturally, if it increases, it promotes warming. So it has a connection, but both are not the same. So here the main challenge for researchers is that it is so hard to measure anything that is happening very slow. This is the first and foremost challenge for climate change research. Climate change is so slow process, and it is very hard to measure, especially in terms of biology or ocean different parameters. So that is the first challenge. So how to overcome this challenge? You need to look at the environment for longer duration. Then at least you will have a quantifiable change over maybe some decades of time. So this is a challenge in climate change. So if you see the global warming, I wrote global warming and also ocean warming, because global warming essentially is ocean warming. 90% of the warming is happening in the ocean. Okay, because though ocean area is 70% on the planet, 90% of the warming is going to the ocean because specific heat capacity of the ocean, water is higher. So, and it is very slow, 0.2 degrees centigrade per decade. Some people even says that 0.1 degrees centigrade, but still it is very, very slow. Ocean acidification is 0.1 unit of pH in 2 decades. This is the change that is happening in the nature, and you are trying to measure it, and you want to do a PhD within 1 year, and you want to study climate change by doing something. So please remember all this in your mind, what you are trying to address and how you are going to address. Now, two broad ways of studying climate change is this. One is you can study the natural variability of plankton. For example, if I want to study plankton, you can try to understand long-term natural variability. Another method is enrichment experiments. Okay, so both these methods have advantage as well as disadvantage. You can see first one, monitor natural variability of plankton on long duration. The advantage is that, see, the point is this, there is something which is happening very gradually. Some organisms are existing in a particular environment, and it is actually their multiple generations are happening. For example, in an organism which has very maybe months of time, generation time, within a year at least 2 to 3 generations of that organism might be happening in the ocean. So what happens, every organism has a tendency to adapt to it, adapt to the slow changes that happens in the ocean. So what is adaptation? Adaptation is basically a molecular change. It is a change wherein your even protein expression might change. Okay, so that is there happening. Is this gradual change is causing an adaptation by the organisms. So if you do the long-term monitoring, this adaptational change that happens in the organism also can be accounted. But the enrichment experiments, what happens? It is easy to do it, but you may be creating some certain concentrations, and you are just exposing organisms to the, that change and try to measure what actually happened after a period of time. So what is our disadvantage? The adaptation that naturally occurring in the condition environment, that might not get accounted in your experiment. So both methods are okay, but please remember that each method has an advantage as well as disadvantage. Now, global approach, if you see for plankton studies, is long-term plankton monitoring. I will tell you what it is. So you can see relevance of plankton monitoring. If carbon dioxide is increasing, because basically carbon fixation pattern can change, it can affect zooplankton, and you can see also it will increase the acidicity of the ocean. One more point for the students I want to tell. What do you think about the ocean acidification? Are you thinking that ocean is going to be really acidic? Because pH 7 is less than 7 is acidic, right? So what has to be ocean's actual pH? Actual pH globally is or has to be 8.2. It is basic. Okay, because of the increase in carbon dioxide, it is slightly decreasing. Now it is almost pH 8, but still it is basic. Got the point? So if it has to be really acidic, you have to come below 7. But the terminology ocean acidification means acidicity of the ocean increases. So from 8.2, 8.1, 8. And people proposes that if it is 7.9 to 7.8, it will have a catastrophic effect. It will affect all shell building organisms, because dissolution of cells, shells happen, external shell happen, so that marine ecosystem will collapse. Okay, so naturally you can see this will have implications on the plankton as well as the fisheries. Now, what is the CPR? Just think about this particular thing, very interesting. And people started continuous plankton recorded surveys since 1931 between UK and US. You see this. This is the longest running marine plankton surveys. You can see this is the CPR. continuous plankton recorder, very heavy metallic body. Inside you can see some of the mesh nets which are kept inside for collecting zooplankton. So I will show you further. This is interesting thing. Just to see how much effort they have already placed between UK and US since 1931. The distance they towed is 30 times to the moon and back. That much of distance continuously they have already towed this CPR. Okay, they collected, you can see, almost 2 lakh samples. Okay, they already processed the entire route, Europe to UK, and they quantified. For what? Basically to understand how long-term environmental change affect plankton distribution. Some of the results we can see, and this is another sad part. If you see CPR survey status, we says that climate change is affecting maximum in the northern Indian Ocean for the reason that it is actually semi-enclosed ocean, okay, and you see all landlocked, okay. Even ocean circulation is very poor. You know the global conveyor belt, okay, that circulation is not really reaching there. So climate change impact, whatever is happening, will remain there. It will not get, you know, transported away from that ocean, and maximum effect may happen in the northern Indian Ocean. But what about the situation of CPR surveys? Unfortunately, we have nothing there. So far, not even a single CPR survey. This kind of survey is not existing anywhere. But all other ocean, you see, everywhere they are there. All other oceans have CPR surveys between premier organizations. And unfortunately, there is no surveys in our northern Indian Ocean, nowhere around, you know, in this any of these countries. So that is the status. Now we can look at one or two results from the CPRs which were published in journals like Nature and Science. I am very sure that you might have already heard about the problems, climate change problems directly on fish, like you know, decreasing the reproduction length at first maturity, because when fishes are smaller they become mature. Smaller is younger. That is one direct implication. And even fishes are, you know, their regimes are shifting. They are extending their habitat. So those kinds of observations even for already made, I know. But similarly, you see, this is not something which is very new. You see, the for plankton, it's just published in Nature, Science kind of journals. So change of particular copepod. 1960, this was the concentration, and see, by gradually that particular copepods, it's diminishing from that area because the warming is increasing, and warmer waters are happening here. So naturally, that species get omitted. Similarly, you see the range expansion of another temperate plankton. Initially, only this much, and by decades elapsed, it has expanded the entire. It's very clear that this has a clear impact on the composition as well as the habitat, original habitat of plankton. So I will conclude here. I will not take much more time now, because essentially plankton are actually the pulse of the ocean. It is a very good indicator of climate change, but we need to have long-term data to understand exactly how it is actually changing in the ocean and what could be its implications on higher level organisms like fish. And for sure, the pattern and quantity of fish available now may change in future. There is no doubt about it. Already there are indications. I used to see some of the clippings or maybe some media reports even from CMFRA for the last at least 1 decade time, that there is a noticeable change, there is a visible difference that is happening over the time for many fishes, even the size and the size at which it mature, and even compositional change, and some years it is dropping and some years it is coming up, all those kinds of changes which are happening. And for sure, plankton monitoring worldwide would be a very good practice to act as a sentinels to identify future climate change in marine ecosystems. And in fact, CPRs, by realizing the fact that CPR surveys are not there in the Indian Ocean, I did not left that there, because something is not there. It is our responsibility to initiate that. when chance gets. And in fact, we initiated CPR surveys, and there is a video connected to, and this is one important figure. Plankton is so microscopic and trivial, people might think. So, but they are basically, they are butterflies in the ocean, how beautiful they are. You can see this is a lithographic and half tone. Half tone means all these are spots. Small spots are united together to create this by famous ecologist Ernest Haeckel. So this is, all these are spots, and spots are put together to create this. So I will just stop here, and I will just show you one small video of the CPR operation so that it will be clearer to you. In fact, Dr. Grinson requested climate change and how we can move ahead with more detailed discussion with scientists, but I thought that this is not the right forum to do it. I am available all the time. We can do it in another occasion.
And means it is very important to continually monitor their abundance, composition and timing. The Sir Alistair Hardy Foundation for Ocean Science is an international charity responsible for running and maintaining the Continuous Plankton Recorder Survey. SAFOS use commercial ships to tow the CPR, which collects plankton samples onto a moving band of silk mesh. Plankton data and our research provides scientists with essential information on the health of our oceans. Long-term surveys like the CPR are crucial and allow us to understand natural processes and assess humankind's impact on the marine environment. Our method of collection allows us to monitor plankton along an entire ship's route and has been running since 1931. The CPR has now covered much of the North Atlantic and the North Sea, with new routes being established in other areas of the world.
Once again, thank you so much, and also my greetings to all the participants. All the very best for your future endeavors. Thank you. If you have something to clarify with me, please.
Thank you so much for a wonderful talk, Dr. Jyoti Babu. One query which is coming to my mind, across oceans, when the climate change, the temperatures change, and on some part it is damaging the underwater life, the blue ecosystem. Is it possible that some other part it may be benefiting somewhere to balance the entire thing?
So this is actually a question a little difficult to answer, but still I will try, because how will you evaluate the good and bad with that is happening with climate change? Because ocean is warming, tropical areas are much more hotter after some time, but at the same time temperate areas and polar areas will get higher temperatures. But I would say that overall, if you consider climate change, warming in problem will be a negative impact, because I can tell you what is the reason. Tropical oceans, the problem will be, since ocean surface is warming and the surface layer will be more and more stratified, because stability of the surface ocean will increase, so that even the nutrients which is sitting little below, there is even the normal environmental forcing cannot break this barrier and bring the nutrients to the surface, because the surface layer stratification will be much stronger. So tropical areas, the basic problem what is going to happen, that will be much more oligotropic in nature. So that is the first direct impact. But if you go to the temperate and polar areas, you know, then warming happens not only just directly changing the phytoplankton and zooplankton or fish, even it can create so many other problems. For example, sea level rise. Because you know there are this water has three main forms. One is, you know, liquid, solid and vapor. Okay, this solid form which are present in the ocean as well as on the land. Sea ice as well as ice sheets are there. People get confused. If sea ice melt, it cannot increase sea level because of the Archimedes principle, because they already displaced, you know, volume of water from there. So even if they melt, it cannot create much increase in the sea level. But if ice sheet melts on the continents, it melts, it will increase, you know, sea level a lot. So even if temperature is rising, the temperate and, you know, this polar areas, so many other adverse negative effects are there. For example, sea level will rise. So overall, for sure, climate change, warming will bring only adverse effect. Whatever we are enjoying now, whatever we are seeing now, all will change. So people say the best thing, even mitigation now we say, stopping climate change is impractical, no doubt about that, because there is a natural cycle involved in that. In addition is a human contribution. So mitigation, what maximum you have to see is that, can we decrease the pace at which increase, or can we reduce the climate change rate? So that is one of the best mitigation thing. Completely changing the climate change, as an oceanographer, I don't believe, because all paleoceanographic record says in millions of years, multiple times it happened. So it is there. But from 1960 onwards, instead of going like this, we made it like this. Okay, steady increase, we made it as a steep increase. So that is the main challenge. So overall, if you look at this, warming is going to adversely affect marine ecosystem and even the fisheries pattern. It will have a lot of socio-economic issues. Okay. Thank you.
Thank you. Thank you.
Any other questions?
Thank you, Dr. Babu. Very interesting to listen to you.
Thank you, sir.
Very simply, you have taken us to the depth of the oceans and explained it very clearly, the kind of concerns now we are looking at. Now, harping on the word concerns, we have heard someone indicating that there is, climate stress, climate anxiety, kind of, things. In that context, I also go back to the reference you made to Donald Trump.
Yes.
Very skeptical about.
I did not mention that name.
Yes, we understood that. Trump. But this drives whole lot of anxiety and apprehensions in mind that drives billions of dollars of business.
Correct.
So how, as an educated individual, we will be able to face such kind of an onslaught of business in which we knowingly or unknowingly spend a lot of money about it, including the emission standards and many kind of products and facials and UV resistant items human beings can use. What is your take on that?
Sir, that's a very good question, basically. The thing is that what I understand this climate change and all those things which is happening, people say that climate change is a natural process. There is an additive component by the humans. There is a reality, we have to accept it. But this addition component which given by humans, can we decrease it to the maximum possible extent? Because development and all those kinds things which cannot completely avoid. The sophistication, for example, automobiles and the ACs. But whichever way we can cut at least the increasing, incremental increase which humans, not incremental, actually substantial. From here it is going like this now. At least if you can cut down some of those, percentage of contribution which humans is, contributing to it, at least you can decrease of the climate change, that is rate of climate change that is happening. And people very easily, people says we have to adapt. Climate adaptability is another terminology. What is it? It is not an easy terminology, so difficult. If you really want to, for example, if you take only global warming, what is this climate adaptation you are talking about? Your entire thing will change over time. For example, your house, even for your house construction, even your dressing, even your food, everything will change. So it is something like a civilization or cultural change might happen. In a sense, if you really want to do this climate adaptability, it is not so easy terminology. Island ecosystems, we say, we have to adapt. Climate adaptation is the best method. But this adaptation after some period of time, it is going to be a great change. Even the cultural existence of humans, house construction, ways of dressing, even food habits, all may get changed. So as Bhagavad Gita says, change is the most unchanging thing in this world. Climate is changing undoubtedly. Gradually it has been changed. But there is a human component. It increases the pace at which change. Now we are adopting many things. For example, now our electric vehicles. People say fossil fuels fully avoid, go for batteries. Where we will dispose these batteries? After some time, this battery is going to be a big problem. And huge amount of battery and acid. And this battery, which way you are going to dispose it? So, as a educated people, we have to think about it really with your sense, and whichever way you can adjust to it and to minimize your own contribution to increase the climate change should not have happened. Because just like we make cleanliness and neatness in places, even after a lot of educated people surveying in places, also people are just throwing waste everywhere. But at least those minimum kind of educated civic things has to happen, so that at least we can minimize. Now if you say somebody that AC, please don't use AC, it is CFC it produces, so many things it produces, is there anybody who is going to hear it? At the maximum what they will do, they will keep a solar panel and use that solar energy for ACs. So wherever possible, we try to minimize our own contribution. That will increase the pace of this warming. This is the maximum thing one can do. That's what my personal understanding on this.
Professor, sorry, Dr. Babu, I'm not a scientist, but since we handle this, I have studied international relations, and in that way international politics and international ecology as well. In that condition, I have found a paper by some Uppsala University, Sweden based. They had studied that underground weaponizing or underground weapon testing have caused tremendous oceanic damage. Now the damage can best be evaluated by the oceanographers and not the ordinary other people. Now what to your mind is that with the advent of a new concept of growth or development and the arm race consequently, which is happening because India has to survive in the face of China and Pakistan things, that they have to they think the India is a danger to them, and so they also have to continue. So India is also into that dragnet of arm race,
Yes.
which other country are also there. Now, considering these things and considering the survivability of the coastal area people particularly and the entire population of the world as large, what do you think the oceanographers have to do with this containment of the pollution or warming of the waters? And how can you address this situation?
Yes, this is another important question. And see, I think that activity, especially earlier, any pollutants, if you see the initial development 60s or maybe after independence, all those industries which were established, most were on the banks of the rivers or on the shore of the any of the seas. The basic reason is that pollutants they can just throw into the water body. So you can see many of those rivers all on banks. The final motive, most important motive is that these pollutants can be dispersed into the water bodies. So even now it is happening, but now due to regulations, at least new industries are not getting permission to get established those areas. But at the same time, the other point which you mentioned, ocean traditionally, since its volume is very high, it was used as a pollutant and hazardous material disposal place for centuries, especially for radioactive materials earlier. All those radioactive material waste were used to be dumped in the ocean, deep ocean. But those practices are no longer existing. But still there are countries which are doing this kind of weapon testing and under the ocean. And you know how the ocean diplomacy is. Every country has a right of certain part of their ocean around them. So they have the liberty to do it. So individually as oceanographer or scientists, we cannot directly, we can at the maximum, we can write a publications and we can make some awareness program or something to that extent. Beyond which we have no, implementation capacity. Actually, we are not an enforcement, no kind of enforcement capability we have. So we have a lot of limitations. And one more thing is there, sir. You rightly mentioned. I recently heard that many of the servers, computer servers, they are going to keep it in sea. You know how much temperature it is creating? Huge amount of temperatures. So even that they are planning to keep in very safe, watertight box, and they want to dispose in sea. It's already done. That's what I don't know, because social media is, you cannot believe everything, but I think it is happening. So naturally, with the jurisdiction of different countries, they are using their areas for their benefits, and as scientists we have limitations. We can point out all this. We can raise this in forums and discussions, and all, beyond which we cannot really act upon it because of all this. Any other? Okay, great.
Online participants,
okay.
Any questions?
Hello, sir. Hello, sir. My name is Ramachandran. I have a small question. Sir, actually, there is a lot of are you able to hear me?
Yes, yes.
Yeah. There is a lot of interest in deep sea water ecosystems.
Yes.
Deep sea water ecosystems. So I also understand that there is something called a biological pump, where these zooplanktons migrate to the top layer of the water, and they make a migratory movement and other things. So taking that into consideration, can we do some kind of manipulation so that the deep water ecosystem can become a carbon sink for carbon sequestration? Is it a viable proposition?
It is already. This is actually a biological pump. Some people think that it is actually a mechanical pump. It is not that. Basically, it is a concept wherein this organic carbon or biological things which are created in the ocean surface is getting actually going down to deep into the ocean. So essentially this is all about the biological pump. So all carbon dioxide which is created on the ocean surface, which we call it as carbon sequestration, once it is sequestered, and if you can dump those sequestered carbon deep into the ocean, that is a deep burial of carbon dioxide, so that you can decrease the atmospheric concentration of carbon dioxide. That is the whole idea of carbon sequestration and carbon sinking. So, but with respect to zooplankton, which the point which you mentioned, because they vertically migrate for different purposes basically. Most of the zooplankton migration, if you critically look at, is happening within the upper 200-meter water column. There are some zooplankton which are migrating from the deep ocean, for example, even beyond 1000 meters. So those zooplankton might be migrating to the ocean surface maybe once or twice in their entire lifespan. Okay, not by daily, they cannot migrate 1 kilometer from deep ocean to the ocean surface, and they cannot come back. And also one more point, this sunlight, actually one is the main cue that is making the vertical migrations. The sunlight is available only on the upper 200-meter depth. So the sunlight cannot act as a cue or maybe a stimulator to cause vertical migration. So it's illogical saying that based on the diurnal cycle, day and light cycle, zooplankton is migrating from 1000 meter, which is completely dark. Below 200 meter, completely dark. So that is not acting. So this biological pump, it's a reality that is actually happening. Even you might have heard about ocean acidification experiment, which was conducted in the Southern Ocean, southern waters, wherein some areas actually iron is acting as a limiting factor. They actually sprayed a lot of iron dust in those areas and hoping that it will increase the phytoplankton biomass and gradually all will sink down to the deep ocean so that they can capture a lot of carbon dioxide, atmospheric carbon dioxide, send deep into the ocean. So that is about all about the iron fertilization experiments. So essentially for all these activities, the basic concept is carbon sequestration and biological pump. I hope I am clear to you. Okay, thank you.
Okay, sir. Thank you. Thank you.
Thank you, sir.
Okay, thank you so much. Once again my greetings and appreciations. Grinson, I just want to say the other discussion we can make it on another day, so that it will be more effective. Okay.
Thank you so much, sir. It was indeed a wonderful session. We now move to the certificate distribution ceremony, acknowledging the active participation and contributions of delegates over the past 2 days. I invite Dr. Shobha to kindly announce the winners.
As I mentioned at the start of the ceremony, we had a lot of good presentations, and we had this evaluation is being done in different steps. This is the first stage of evaluation which we have done at our level. I understand the Institute of Social Sciences will have their own evaluation done. They had online evaluators also present. So here right now we have picked out the best presentation for the best presentation award from each technical session. So technical session 1, the best presentation award goes to Nandakishore for the paper on decadal thermal variability. I request our chief guest and director to please do the honors. The title of the paper was Decadal Thermal Variability and Coral Bleaching Risk in Lakshadweep, Insights from SST and DHW Indicators. For technical session 2, the best presentation award goes to Mohammad Nawazu Soha for the paper Mapping Waste Generation System in Minikoy, its challenges, issues and way forward. All these papers have multiple authors, but because they are the ones who presented the paper, I am announcing their names as the awardees. For technical session 3, the award goes to Dr. Shanti M. for her paper on Empowering Women in Fisheries, Case Studies from North Tamil Nadu. We have one more awardee under technical session 3, but unfortunately we had actually prepared for one best paper from each session, but it was very difficult for the evaluators to decide, so there is one more awardee. I'll request Shanti to just hand over the certificate for the sake of the photograph, and then to the second person we will send the certificate by post. It goes to Nawaz Shakira Sajid. Have I got the name correct? Shakira? Yeah. It's a relationship between socio-economic factors, awareness of environmental challenges, and nature-based solutions, a case study of Minikoy. We will ensure that your certificate reaches you. Technical session 4, the award goes to Harshita R, who did a marathon presentation of 3 papers, but this particular paper has won the award, that is evaluating carbon sequestration and climate mitigation potential in natural and planted mangroves of the Panchagangavali estuary. Technical session 5, the award goes to Dr. Shelton Padua. I think he presented the paper. You presented the paper, right? Yeah. Interactive maps, an efficient tool for ensuring last mile connectivity in climate hazard awareness. And technical session 6, the presenter was an online participant, Khushi Dikshit, for the paper Revisiting the Environmental Kuznets Curve in Extended Bricks. May I request Dr. Pooja Sharma to receive the award on her behalf? She is the first author of the paper and Khushi presented it. So congratulations to all the award winners, and it doesn't mean that the others were not good, it means that they were slightly better than the others. Thank you.
As we near the close of today's session, it is time to express our gratitude to the distinguished guest who has graced this occasion with his presence and contribution. May I invite Dr. Grinson George to kindly present the memento to our chief guest, Dr. Jyoti Babu R. We are grateful for the insightful valedictory lecture and the valuable perspectives shared. As we come to the close of this enriching conference, it's time to express our heartfelt gratitude. May I invite Dr. Abdul Aziz, scientist, ICRC Amafarai, to deliver the vote of thanks.
Respected guest, director and other dignitaries in the online and offline, a very good evening, and directly going to my task, vote of thanks. First and foremost, I extend my heartfelt thanks to our chief guest, Dr. Jyoti Babu R, Head, National Institute of Oceanography, Regional Center, Kochi, for accepting the short time notice and the insightful address on the phytoplanktons and its role in the ocean. And also we are deeply thankful to our director, Dr. Grinson George for his initial keynote speak as well as supporting this entire program. And also special thanks goes to the our head, Dr. Shobha Joy, for leading this entire event from the backside. And also the project thanks goes to our project PI, Dr. Surjit Mahalanobis, for the framing the entire structures and the man who forcing behind all these activities. And also the special thanks to the Professor Emeritus Dr. Arora, Chairman CMF ISS, Institute of Ocean Science, Institute of Social Science, and the Director Manoj Rai, Institute of Social Science, New Delhi. And we are grateful to our keynote speakers like Professor Vinod Sharma as well as Professor U.S. Bava for their insightful keynote address during this different session. And our thanks goes to all the HODs in the institute and the HORs in the different center and SICs and the session chairs, co-chairs, and our rapporteurs and evaluators for the smooth coordination of the sessions. And our special acknowledgments goes to the PME cell and as well as HRD cells, our administration and finance sections, and our library and documentations, audiovisual and media cell, our guest house and canteens for the efficient planning and supporting of this event. And I thanks to all our FFD scientists, especially our HOD, Dr. Shobha and Dr. Shujita, and Dr. Abdul Samad, Dr. Najimuddin, Dr. Ganga, and Dr. Ramya, and Dr. Levi for their different role and leading in the various activities and various committee for successful of this event. And also I thanks extends to our technicals as well as the supporting and scholars of the divisions, because these people are actually in the ground level, they are force support to the success of this event. And my big and special thanks to this team NICRA as well as marine mammals for their heartfelt support to the entire the sessions or entire the events, especially their scholars and scientists. And my thanks to all the participants, scientists, technicians, scholars for their presence and contributions to these events. And finally, a big thanks to our funding agency, Indian Council of Social Science Research, and the Institute of Social Science and CMFRA for full support of this program and under the section. And finally our project team, Dr. Pooja is here, and of course I already thanks our PI, Dr. Surjit, and our scholars, and thanks to all the people here. Thank you everyone.
With that, we officially conclude the valedictory function. Let us now rise for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता